Hi, this is the week 9 Understanding XREFs and Hatching for the course of AutoCAD Essentials for Civil Engineers. Now let's see what we will learn in this session. In this session, you will be learning to work with external references, various tools and concepts in the external references, and then you will be learning about how to hatch objects, how to create different sectional detail or the fill into the elevations or to the plan in your drawings. So let's start with XREF. Before going to the tools for XREF, I would like to share you what the external references means in the and where it should be used in a process of CAD drafting. Now, while we are working in a project, specifically a building construction project, there are several drawings that we need to work, and all the drawings starts from conceptual design. Then we go to the detailed design. Before that, we work with the schematic design. Then after the detailed design, we go to the construction documentation. So there is a different phases from where we start working. So while we are working in the conceptual design, we start with the architectural drawing that will lead to the schematic design. So once the architectural drawing is done, we have a lot of other stakeholders that would be working in the project. Maybe it be a structural drawing or an HVAC drawing, electrical drawing, or it can be a plumbing drawing, a firefighting drawing. A lot of drawings will evolve from the basic general assembly plan or the layout of the architectural drawing of the particular building construction project. Now, what work sharing in CAD means? It means that when we are working in a team, like when all the stakeholders are working, or the consultants and the contractors are working in a team, everybody would be sharing the drawing. Everybody would be working in a coordinated pattern where they will be working on a particular baseline drawings like the architecture drawing. For example, if we want to develop a structural drawing, we have to look into the basic architectural drawing and then we start with the structural drawing. Same with the HVAC drawing or with the electrical drawings or with the plumbing drawing. So, and then the rest keeps on going around. For example, for the electrical power drawings, so we would be basically taking the electrical drawings and giving the lighting plan or giving the power layout, the circuit layout. HVAC drawings would be also taken from the existing architectural drawings. Then we can have the piping drawings, and there are a lot of stuff that can be done with the. So what happens exactly is there is the architectural drawing, maybe one of the base line of starting the project, and where all the drawings that would be evolved later on would be from the architectural drawing. So here we have the concept of external reference. Let's, for example, if we want to develop an HVAC or an electrical drawing or a structural drawing, let's take an example of a HVAC or a ducting drawing. So in this case, we need to have the architectural drawing which is proved or which is in the design phase. Design approved is there. So from that architectural drawing, we are going to XREF that drawing into the HVAC drawing that we would be making. Now, when we are doing an architectural drawing, probably we are going to have the walls, doors, windows, and all the specification of the spaces there in the architectural drawing. So here we have two things. One is the XREF. That means when we are doing a structural drawing, we're going to extract the architectural drawing to see where the rooms are. Then we will place our columns and and then from there we are going to make the column layout or the beam layout or the footing layouts based on the architectural drawing. So we can refer this drawing into the drawing that we are doing. And this is the process where the external reference occurs. Similarly, so what does external reference means? That suppose, let's say there is a HVAC drawing that we are doing and we refer an architectural drawing. So whatever changes that will be there in the architectural drawing will be there in the HVAC drawing that we are working. That the architectural drawing changes, the reference of the drawing that is in the HVAC drawing will also show the change. That means there is a link. There's a one-way link that is happening. And further, let's say the HVAC drawing is further referred. So now then it goes another way in a flow. For example, let's say there is another piping drawing that has to be evolved from the HVAC drawing. So if the architectural drawing changes, the changes will be there in the HVAC drawing where the architectural drawing is referred, and further in this piping drawing the changes will come down the line. So it is basically the work sharing part in CAD where people in different stakeholders or the different consultants are informed about the changes that is going to happen. So there are various techniques and various concepts in XREF. So let's start with a small example of how we look into the XREF and different terminologies in the XREF. So now coming back to it, so there are external references. So XREF means external reference. So when you are referring a particular drawing in the project from outside file, that a DWG file, you are referring to the drawing, and there is a link between the two drawings. That means the source drawing in which you are referring and the external reference drawing. So if there is any change in the external reference drawing, the change would be there in the main drawing. So let's take an example and see how the XREF works. So here I will create a file. Let's say, for example, so I create a file name as, let's say, architectural drawing. So I'm saving this file as architectural layout, or let's say a floor plan. And this is an architectural layout. Here this drawing will be referred while we are doing an HVAC or a structural, and see how it works. Let's say we create some layers over here quickly, and then we will be referring this particular layout in a structural drawing or an HVAC drawing, or doing a furniture layout, or let's say different scenarios we'll be discussing, and we'll be learning how the XREF will be used. So here we have, we take the units, let's say as engineering, and let's take this. So again, we are using an imperial system over here, right? So we can have an example with the matrix system also, but here we are having an example with the imperial system. So I keep the limits as, let's say, 30 feet, 30 feet. So now make sure, now another thing that we need to take care is about the layers. Layers are very important in XREF. So we have to have a designated layer for each element that we draw in the drawings, right? And then we would be seeing that how the layers will play a dominant role while we are XREFing the files into the other file. So this is an architectural drawing. So let me create, let's say, a space. So I have this, let's say, create a rectangle with the first corner point, and let's say the other corner point is, let's say, 15 feet, 20 feet. So let's say I start with, and let's say I want to create some layers. So let me create some layers over here. So here I create a layer. So of, I would write it A wall and designate it as, let's say, a color red. So then I would be creating another layer, let's say a door, and I'll be designating the color as blue. So then I would be creating a layer called window, right? So let's say I have 3 layers. Now let's make it this a current layer to work into it. So I change this into the current layer as wall. So I have architectural layout. Let's say I make a 9 inches, and let's say I explode this and make it as, let's say, 10 feet. Internal walls I want to create, so I need to explode it. So once we explode it, it will have different lines. So let's say I give it as 9 feet 6 inches as the offset distance. So here I have this 4.5 inches wall, right? So here I have different walls over here, and I will be having, let's say, 10 feet and 4.5 inches. So I'm creating an architectural plan just for the XREF sake. So let me move this entire file. Let's say I would like to move it 5 feet more. or I would like to move it, let's say I would like to move it, let's say 4 feet. So let's say, okay, so then this is a line, and let's say I give it, so this is a basic architectural plan I am creating for a particular use. So let me have this. So now you can see that these are created in the wall layers. Then I will be having an opening over here just to create an example that this is an architectural plan, and create some doors and windows over here. So let me first of all explode it and just give me an opening over here and create a basic window and door. Let's say 3 feet 3 inches as the opening over here. So let me put it like this, and so this is the architectural layout of the space over here. So I can have a 3 feet opening this side and a 3 feet opening this side. So there are two access to the space. Okay, so in this I would just join these two lines so that I can get an architectural partition walls. So here I need the opening this side. Okay, so let me have it here. So I just give a symbol of door over here so that we are in sync. So I create a circle and just create a symbolic representation of a door. This is just for reference. So normally we use blocks for the door symbols, but just I'm creating a fast symbolic representation so that we also revise how we can draft, and then we can also revise about the basic concepts of layers also in this. So just this is a trial exercise so that every time when I draft something, you would be understanding how the drafting can be made speedily. So now this is the basic so I just put this objects into the layer called door, and match these properties with this particular layer, and let me have the door here also, and let me have the hinges. Just I'm taking an basic, I'm not going very accurately over here, just wanted to create a basic layout so that we can have an understanding. Right. Now here we have this architectural plan, basic architecture plan having let's say 3 doors, and you have this walls over here. I can have a window over here, so I can have a window at the mid. So let's say I have a window of 3 feet, and here we are. So now I want to have a detailed drawing of this. Let's say I need to have a plumbing drawing or a firefighting or an electrical drawing or a ceiling plan, reflected ceiling plan for the electrical, or the false ceiling drawings or whatever it is. So I want to have this as a base drawing. So now you see that in this particular drawing I have used 3 layers. One is the A window, and I have this A wall. Now one command that I would like to introduce over here is the purge command. So the purge command basically is used, so if you say purge over here, to delete objects like the layers, text, blocks which are not in use. For example, if I purge the layers over here, so what will happen, so if I say purge all after selecting the layers, so do you have purge dimension style purge? Skip this item. So purge all items. So now you look into it that what will happen is but there are certain layers which is the selected layers cannot be made current, the following. So probably there are certain xref dependent layers which is over here. So let's not worry about it. This is some bugs that has come, but okay. So now we have 3 layers over here. So this is the architecture layer that I have created, and here I have. Now, so what I will do is, this is a plan. I open up a new file. Let's say I open up a new file and name it as, let's say, an electrical layout, or right. So I would say that here I go with the, so press. So here I go with the new, and I'll have an imperial, and here I save this file as, let's say, an electrical layout. So it would be floor plan electrical. So here what I will do is I will xref the file that is created in architecture. So there are two files now. One is the floor plan electrical. Let me name it again, name it correct. So electrical. So yeah, this is the floor plan electrical DWG file, in which I am interested to create some electrical points like the fan, the lights, the switches, and other thing. So what I will do is I would externally refer the architectural drawing into this particular drawing. So for that, I would go for a command called xref. So there are different commands like xattach and other thing, xattach, xclip. So you can directly attach an external reference files by the command called xattach. But here I would suggest that we should go with the command called xref, and then this dialog box will be open. So this dialog box name is external reference. So here you can find that there is a drop down list where it says that attach a drawing. So if I want to attach a drawing, I have to go to the my folder where I have saved. So here I have the drawing. So here the architectural plan is there. So now the moment I open this file, it will ask, just like the block insert, there will be a dialog box like attach external reference. Now here you see that name of the file which is externally referred is displayed over here, and apart from that it displays that if you want to scale this, so specify on screen. So if you click on specify on screen, the moment you will insert this external reference, it will ask for scaling. But here I want to go with an uniform scale, so I click on it, and then there are two options, attachment and overlay. Now by default the reference type is attachment. So what happens, for example, in this electrical plan layout, I have xref architectural plan. Now in the electrical plan, the architectural plan is referred as attachment. Now if I external refer the electrical drawing to another drawing, let's say power drawing, right? So the architectural drawing will come because it is attached to the electrical drawing. But if it is overlaid, if the architectural drawing is overlaid in the electrical drawing, so the architectural drawing will not come with the electrical drawing when the electrical drawing is external reference into the power drawing. So this is the difference. So we will see the difference between the two with some application. Then we have the specify on screen, and you have this, you can have a path which is saved. Relative path means it will take the relative path, for example, not the full path. Let's say if it is in a folder, inside a folder it will take the path. So if it is in a folder, let's say week 10 drawing folder, so it will not take C drive or something. So the relative, if the folder path is defined in the file type, so it will call it from there itself. So it is, so by default the relative path option is chosen in the path type. Then if you want to have the rotation angle on screen, so let's have it angle 0. So I press OK, and then I go for specify insertion point. The moment I specify the insertion point, I can see that the drawing, that is the architectural drawing, is xref. Now what happens when basically I xref it? Now let's go with the layer manager. Now see what will happen. Now over here you can see that the architectural, so this I will this file that I need to unload. I'll talk about it. So okay, so we can remove this also. Let's not worry about this. This is an unreferenced file that had come with the file. So here we have this architectural file, architectural plan, which is the external reference file, and this is the main file that is we are working into it. So there is an unreferenced PDF which is there, so let's not worry about it. So there is a current and there is an attached file. So the attachment is the floor plan architectural. Now if I go to the layer option right now, so here we find that the file that is used, for example, is the for the XREF is the architectural plan. Now here the layers are displayed over here. That was this is the layer of that we had created in the architectural plan. These layers are called XREF dependent layers. So we cannot work in these layers. So you can see that these are the three layers which is XREF dependent. XREF dependent means it came with the external reference. For example, the door, the wall, the window, all the layers had come with the drawing named as floor plan architecture. So you can see that with the name of the layer, the name of the file is attached over here. Now, let's say I want to create a new layer. So I will go for all use layer. So let's say I create a new layer name as dimensions, and I want to also have a layer as, let's say, a new layer as so I will rename it as annotations. Then I will have another layer as so I'll rename the layer as lights, and rename this as fans, and I can rename this as let's say switches, and so on. So here these are the layers that are with the electrical drawing that we have created. So let me have a prefix to it so that I can uh, discriminate it between the architectural discipline and the electrical discipline. So here I rename them and have a prefix. That means before the dimension I'm having a prefix. So I'm renaming it and I'm naming it as e-lights, or I can say light fixtures. So I can have the fans, switches, so and sockets. For example, if I give a different color to it, and for the fans I give a different color, and for the switches, let's say I give a different color, and for the dimensions, let's say I give a different color, and for the annotations I give a different colors. So now you can see that let's say I work on the lights. So I make it current at this moment. I want to get some lights. I want to put some lights to show that tube lights or the concealed lights are placed in the ceiling plan. So this particular drawing is externally referred over here, and I'm using it for drawing the electrical layout. Now let me have some lights and fans so that I can put it over here and create some blocks. So say I want to have some concealed lights. So let me have this. So I make a block, concealed lights, and select the object and pick a point, and here we go. So now let's say here I have this, I insert some lightings over here. So let's say in this corner, okay, and let's say I have the lighting here at this point, and I want to have some concealed or the ceiling lights here. Apart from there, I want to have a fan over here. So let me draw a fan symbol. So that we have already discussed in the previous session. So we'll create a block of this. So I'm going to give the fans and make it a block. Fan, here it is. Select object, pick point. I just select object, and I would like to have the pick point for the insertion point, and say okay. And then I'm going to place it somewhere here. So here I have this layer, and I want to have the fans at this. Let's say I want to have a fan over here, and I would like to have a fan over here. So I'm inserting the fans over here. Let's say center position, and let's say I want to have a fan over here. So this is just a symbolic representation of how we do electrical layout. And let's say I want to have a switch. So let's say one-way switch. So to draft a one-way switch, so have a small circle. Then you can have the, say, make it a sector kind of thing, and just you can put a straight line to it so that it represents a switch. So you can have a one-way or a two-way switch. Different symbols can be used. So let me scale. Right. So here we have this electrical layout, and we have taken the architecture layout as a reference. Now we will see how basically it would be used while we are doing an electrical layout. So let me put some points over here. More points. Let's say I have this lights in the ceiling here, and lights in the ceiling here. Okay, so I can have, so we'll be having different legends for the switches, lights, and other thing. So let me create a layer for the switch. So let's say it's so we have a layer for switch, and we can have a layer for sockets or receptacles, power sockets, and circuits. So I can have another layer for circuits. So circuit lines, it can be a three-phase or a single phase. Okay, so just let us give it a different color. So, and a line type, let's say I want to give a line type of dotted line over here. Let's say I can have a hidden line. So let's say I want to have the circuit with the switch. So just put this into the switch layer, and let's say I have a switch. Select an object and take the base point here and press OK. So if I want to place the switch, let's say take the switch over here and place it. So the moment I enter, I am placing the switch over here. Just move it somewhere at this point. So here it is connected, the circuit is connected. Let's say we want to have a circuit. So I can have the circuit over here. I'm going to give a different color to the circuit. Let's say I want to give a color, let's say over here, and set current. And similarly, you can see that you can draw an arc to show the circuit lines. So you have an arc, you can go for a start point. Let's say you can go for a second point, and let's say this is, so you can have a scale of the line type. So you can go to the properties palette, increase the line types, local line type scale, let's say to 5 times, so that you can see that in a dotted lines. So here we are, and then we can have the switch. You can have another arc from here. So you're looping it. So this is how. So I can match the properties MA, and you can see, and then we can have the switch over here. So we can match the properties, and this is how the looping is done with the lights. So now you can see that we have a scale, let's say 5 minutes. So this is the one loop that I have created for the concealed light or the ceiling light that I had given. So we can have different circuits for it. Now let's see what happens to the XREF. Now let's say here, if I change the architectural plan, let's say I move the door, for example, I move the door here and just change the plan over here. So this is the source, this is the actual architectural plan which has been XREF'd for the electrical drawing, and I have been working in the electrical drawing, and now I would see that if there is a change here in the architectural drawing, how the change will be affected. So I save the file. So I will have to save the file. Okay, so I go with the save option, and coming to the electrical, when we have, now you can see that there is a message that has come. A reference file has been changed and maybe may need reloading. So the moment the reference has been changed, the user, the electrical drawing, the person who is drafting the drawing would be given an alert that the external reference file has been changed. So this is the communication the CAD makes with the other drawings. Now see what happens. So you can see that here we are in this graph where we are doing an electrical drawing. So the moment there is a change in the architectural drawing, in the electrical drawing where the architectural drawing has been XREF gets a message that the external reference has been changed and it needs reloading. So now if we go back to the electrical plan and go with the XREF, let's say, now you can see that it basically shows that there's an option called written needs reloading, right? So right click into it, and then there's an option called reload. So here, go for reload option. The moment you reload it, the change is seen. And now with this change, what you need to do is you need to basically redefine your architectural layout if you want. So this is the external reference use that we have. Now let's suppose if I am using this external reference for the power socket, for example, locating the power lines, or for example, locating how the conduits will be moving and other telecommunications, or let's say for the Wi-Fi lines, how it will be done. So let's say if I want to XREF this particular electrical file, now let's say I'm opening a new file and I name it as, let's say, electrical power. So here what I would be going with it, I would be basically so I would be XREFing the lighting plan that I have done, so that I know where are these switches are there, so that I can have the power sockets there and give all the other lines required, like for example, where would be the Wi-Fi or the Ethernet connections would be there, or where would be other lines like the television DTH connection would be there, so I can relocate them here, and I can make another circuit out of it. So let's say if I am going to XREF the electrical drawing in this electrical power, so here I would go for attach drawing, and then I have this floor plan electrical. So I have this select here, and I would just XREF it over here. Now you see that the moment zoom extent. So now other thing is that now you have XREF the electrical layout over here. So this is the floor plan electrical star. So I would save this file first. So the moment I save this file, so here in this electrical power, this file, so now because it was not showing over here. Nothing was showing over here because I did not save the electrical file. So here it is saying that there's a change that has been done. So go to the XREF. So you would find that if you attach it, if you reload it, right, the file would be visible now. Now here you find that there is an electrical plan which has been XREF along with the architectural plan has come. So now let's say if in the electrical plan, if you are unloading it, let's say the architectural plan, and you're saving the file. So what will happen? So you save the file. So in the electrical power, the moment you reload the file, let's say the architectural plan file. So now what will happen? Now see so here. So we have unloaded the file, but still in the electrical power. So let me unload it and save it again. But now you would find that the architectural plan is still visible over here because it is there along. So the unloading of the file at this electrical plan does not affect the visibility of the architectural plan. So in order to unload this architectural plan in this power plan, so you go to the XREF and you have this option and you can unload it from here. But if you don't want the architectural plan come along with the electrical plan in this particular layout, so what you need to do, okay, there's a simple step. So you first of all reload it, and then you can change the type, XREF type, from attachment to overlay. The moment you make it overlay here, so and save it, so in the electrical power, once you get it, so in the electrical power, the architectural, so if you go and reload the architectural electrical plan, so in this particular, the architectural plan will not be visible. Now let me do it again. Now what is happening is, here in this particular drawing, the electrical drawing has been XREF'd, but in the electrical drawing, the architectural drawing was XREF'd. So along with the electrical drawing, the architectural drawing came over here, because in the electrical drawing, the architectural drawing was referred as attachment. But if the architectural drawing is referred as overlay option, so what will happen in the electrical power drawing, when the electrical drawing is XREF, the architectural drawing did not come. But if you want to see the architectural drawing again, so the drawing in the electrical drawing, the XREF type for the architectural drawing has to be changed from overlay to attach. Now you can see the type is changed. Now what will happen if you save it? You have to save it. The architectural plan over here, the electrical power plan over here, the architectural plan will be visible at this electrical power plan when you reload the electrical plan. So this is the difference between, so reload it. This is the difference between the overlay and the attach option of XREF. So sometimes XREF within an XREF. So this is an XREF, and within this there is another XREF. So it is called nested XREF. So now you can see the ripple is going, right? So this is how XREFs are done. Now let's come to the layer option. Now over here you can see that there are certain layers which you cannot work into it. So what is happening? So, and it comes with the name over here, the floor plan, architectural A, and wall, and other thing. Now if you want to make those layers current, you cannot make them current because you cannot work on those layers. Similarly, these layers cannot be controlled, right? So what you want to do is, you have to remove the dependency. Once you have XREF'd a particular drawing, for example, in this example, I have XREF'd the architectural drawing into the electrical drawing. So if I want, I can make this architectural drawing a part of the electrical drawing and remove the XREF condition from the entire drawing. So what I do, so in the XREF option, there is a XREF dialog. You have got options over here. So option is to bind, right? So once you bind it, means you are removing the XREF and binding it with the current drawing. So the moment you say bind, you have got two options, bind and insert. So if you have the bind option, now what will happen? And you say okay. So what will happen? The XREF will go, and the drawings over here is now now this will be working as a block. So you can explode this block and make it as an actual drawing file. At the same time, you can see that the layers have become active, and you can work on these layers, and you can basically use these layers. They are not XREF dependent layers. So binding is an option of finishing or ending the XREF within the drawing. So now in the bind, there is two options you saw. One is bind and one is insert. Now what is the difference between binding and insert within a bind? So let's do it. Now let's see an example. So I have done an undo. So for binding, you can say xbind. So xbind will have the same thing, like you can bind the layers. Let's go with the bind option, like in the XREF. Let's go with the bind option. Then we will be doing what is an xbind. So here, once we see, so let me tell you what is the exact difference. Now let's say if I have a layer, I go to the layer manager, and here if I have a layer called a door, and this is color is, let's say I give it as red. Now you can see that I have created a layer which is same name as that of the XREF dependent layer. Now we have got two layers with the same name, but this layer is having the name of the file. So when the XREF will be bound, or when you bind the XREF, there are two things. Either these two layers will exist individually, or they will merge into a single layer having the property of the layer which is given in the drawing. So now let's see what happens. Now I have got two layers. Now let's do a bind. So if I go for XREF and I bind the file and I take a bind type, so what will happen? The layer a door exists, as well as the door over here exists. Now you can see after binding, the $sign is shown over here. It means that it is giving a different name to the door and the wall. So it is not merging with this a door, which is of similar name. But if you do an insert option in the bind, so what will happen? The layers will be having an individual name it was having in the source file. So let's see an example. So if I have a bind and if I do insert, that means it is inserting the property of the layers with the name in the drawing in which it is getting bounded. So here you can see that the layers will be having the same name, and here you can see that the door layer which was there in the architectural drawing has merged with the common name that is given over here. So this is the difference between bind and insert. But you know what happens ultimately, the object is turned into a block, and then you can explode it to get individual lines. So this is XREF, and there are certain commands with the XREF that I will be discussing next. Again, to summarize, XREF is basically calling an external file from within the same project for referring for a particular other drawings. For example, you are XREFing an architectural drawing to draft an electrical layout. So here we had shown two examples, and the command for XREF command is XREF, and we did this. We XREF the architectural plan into the electrical layout and saw how the XREF worked. Now further going towards XREF, learning about other commands like xclip and xcontrol. There are other commands in XREF. So I would like to also introduce that we can attach PDF that has been converted from an AutoCAD drawing, which has been converted to PDF. We can bring it over here, attach an PDF, and keep it as an underlay to trace the drawing. So how do we do that? Let's take an example. So I do an xref command over here, and then I have this option called attach PDF, and here I go to the folder where the PDF is there. So let's come over here like to the file that I have. For example, in the week 9, in the drawings, so I have this kitchen layout. So I want to have this PDF inserted into this drawing file. So I put this PDF here, and I can see now this is something drawn in millimeters. So let me have a new file for millimeters, so that I can so I will open a drawing with metric here, because the drawing is in mm. So here now we can see a live example where the PDF is traced using the XREF, and how we can control the layers within the PDF that has been converted from an AutoCAD drawing, and we can control it in the through the XREF command. So we have this XREF option, and then there is an option called attach PDF, and here we go with the kitchen layout, and here we have, so we can insert it in a scale, full scale over here. Okay, now it is inserted in the origin because we haven't selected the insertion point. So now we can see that this is a PDF, and this is the object is PDF underlay, named as, when you select it, it is named as PDF underlay. So it might be having different layers. Now let's see how we can see those layers. So the moment you select the object over here, so you can see that there is an option called show underlay. That means it's showing the PDF, or you can disable it. That means you can show, and you can make it invisible. Apart from that, you can edit the layers. For example, the moment you say edit layer, so what will happen, there are certain layers that can be edited. For example, the doors, you can see, is edited. We can also edit the layers of the hatching, column hatching, and let's say we can also, the wall hatch can be removed. So this way you can control the layers within a PDF file. So very important point is, if the drawing is converted, it is plotted into PDF, and you're using that PDF file, then only the layers will be controlled through the underlay layers option. So now you can see that there is an attachment over here, and I want to convert this attachment into the DWG file. So what I can do, this is as an underlay option over here. Now there is an option called enable snapping. Now you can see that all the points are snapped. You can snap the points over here, and you can trace the wall from this PDF file. So here I can go, and now you can see that okay, so I have traced the wall over here. Now here you can see that there is no layers over here because it is in PDF. The layers are embedded inside the PDF. So let's say I create a wall layer for the wall that I have created, and color it, let's say red. So make it current. So now I want to mainly unload it over here. So you can see that the lines are here. So let me complete this line and match the properties of this object along with this. Now you see that this is the way by which we can trace the drawing that is in PDF into our current drawing. So this is one option, and then here in the XREF you can see that there is you can basically reload it, unload it, and then you can also detach it. So here detaching means you're detaching after you have worked out with the file, you can detach it. Now let's complete this file and see, and then we will detach it. So if you measure the drawing, for example, at this moment of time, let's say if I do a dimension, let's see what the dimension says. So I have the so let me take one dimension because this is a kitchen layout, and let's say you have this dimension 400. So I can do a dimlin and check it over here from, let's say, this point to this point. So just need to check the scale whether it is so now it is coming 14-73. That means we need to change the scale of this particular PDF so that it can be used in full scale. So how do we do it? Because when the PDF has been made, so for this before after inserting it, you can scale the file. For example, take a base dimension. Let's say this is a 900. Go with the distance command and check the dimension. For example, from this point to this point, let's say for this point, you're checking the dimension. Let me see if I'm using the correct points or not. Let's say this is the 2 points. It says it is 900 in this particular drawing. So here we are. So it says 29.8 is the dimension. So you can scale it. So you can go with the scale command and you can scale it, let's say, and take the reference option. Let's say the reference length is 29.88 and the new length is 900. So the object is now approximately scaled to the value that I wanted. Now you can check it again with the distance command and then you start tracing. So this is how we do tracing from an existing PDF file. So let's say if I now check this dimension, so this will be approximately 900. So here now you can start sketching the file. So let's say I do a wall over here. Now you can see what is the thickness of the wall. You can do a dimension check right now. Once you are done, let's say you can see what is the thickness of the wall that I have achieved. Go with the escape tool. Okay. So now you can see the distance command. The distance between these 2 points is approximately 230 mm. So this is how the underlay option for the PDF underlay option is used. So you can detach it and get it away. So this is one option that I wanted to discuss with you. If you have a PDF file, you can always bring that PDF file into your current drawing and then trace it and then detach it, and then your actual drawing will be there. So now let's take an example. Again, going to the XREF, we will be discussing about how we can open and file from the XREF, how we can clip the XREF file so that certain portion of the file is not visible, right? So let's do it. So in the after learning about the XREF and the underlay option, there are certain commands in the XREF that I would like to talk about, and one of them is Xclip. So here we have what is an Xclip? Let's say if you have an external reference like this that we are having. So this is an external reference that is there in this particular drawing. This is an external reference file. So you can clip this drawing. Let's suppose if you have a larger drawing and you want to only see this particular room or a particular space. So what you can do is there's a command called Xclip. So the moment you say Xclip, so it will say select object. Remember that you should select the external reference here. Select the external reference that you want to clip. Press enter. And then over here you have an option called new boundary. So click the new boundary. If you don't have an old boundary, then fine. Yes. So then you can have a rectangular and then click on create the boundary that you want to clip. So the moment you do it, you can see that the external reference is clipped. So if you want to remove, hide this frame that is clipped, so you can go for Xclip frame. And press 0. So here the Xclip frame, if you want to enter the new value of Xclip frame to hide the frame, so you press 0 and press enter. Now you can see the Xclip frame is not visible, but the XREF will be clipped. So if you want to make the frame visible, let's go for Xclip frame and press 1, enter 1, and you can see that the Xclip is there. So this frame is just to refer that how much area has been clipped. So if you want to unclip it, if you want to see the entire external reference, so you can go with Xclip and here select the object, let's say the Xclip object, and then you can put it off. So putting it off will remove the clipping from the external reference. So what is the use of Xclip? So normally, let's say if you have a big drawing, let's say a mall is there or a big detail of the plan is very big. So you can clip, let's say if you want to work only with the toilet plan because you want to reduce the size of zooming and size of the drawing, and you can work properly, the clipping is made. So again, so Xclip if you want to again put it on, so the clip will be seen. Now if you want to delete the frame, delete the X clip happening, so you can select the object and you can delete it. Now it is not only rectangle, you can have a polyline or a different shape. Let's say you go for X clip, select the external reference, and if you want to generate a polyline. Now here what you need to do is if you have an option called a polyline, so here you have to have, first of all, create a boundary, let's say a rectangular boundary, and if you want to generate it into a polyline, that means you want to have polyline from the boundary over here. So you can basically go with X clip and you can select the external reference and you can say generate polyline. So then you have to press enter. So now you can see that a rectangle is generated from the frame. And now let's take another shape of the X clip. So here we go with the X clip option. So I go with the X clip option and I would select this external reference and I would say new boundary. Now here I would go with the polygon option. So polygon option is to have it in a different shape. So this can be X clipping and press enter. And if you want to again generate the polyline from here, X clip, select the external reference and you can generate the polyline. So the polyline is generated from the clip frame. Right. So again, you can go with X clip, delete the clipping, you can go for delete it. Now, if you have a polyline, let's say I create a polyline. So let's say I want to generate the frame, generate the clipping based on this polyline. So what I will do is, it should be a closed polyline. X clip, select the external reference, and then you can say polyline. So you are basically using, so if you have this polyline option over here, so you can select, for example, first of all, go with a new boundary, and then you can say select a polyline, select this polyline, and you will see that the external reference is clipped as per the polyline boundary. So this is the method of external reference clipping. Okay. Next is something called, let's say, so this is what I wanted to talk about XREF, and let's say if I open a floor plan, I would like to discuss about the right block because there is a right block. There is always a question from the users, what is the difference between a right block and XREF? So we have learned about XREF, but there is a concept called right block. So let's see what the right block does and where it is used. Now, for example, a right block is the name as it signifies a block that can be written as a file. Now, remember when we did the block option, right? The block itself could not be saved at the DWG, but here we can basically create a block that can be saved as DWG and can be inserted in the drawing as a block. Let's take the example. Let's say I want to create a DWG file of this legend. So I say W and the right block option opens. This dialog box opens. So I've got three options. Now the options in the right block are similar to the creation of block. So I have got three options. Either I convert an existing block into a right block. So I select the block option, or I create the entire drawing, that means available in the screen, to a block, or select the object. So I select the third option. Now over here, when I select the object, select object that I want to convert it into a block, and then pick the point. Now this is very similar to what we did for creating a normal block. The only difference between creation of a block and a W block is the W block can be saved as a DWG file. So there is a file name that you have to specify. So browse it, and let's say I go to the Skill-Lync folder, and here in the week 9 I save this as, let's say, electrical legend. Now remember that why I have named it as electrical legend, because I have selected this particular set of objects to be, and then I have to select a pick point. So this is a pick point and insert unit is millimeters. So now you can see that there was a clip over here. It means it has saved as a block. Now let's say if I want to use this legend over here. So with an insert option, I just go for the browse option, go to the drive where I have saved or where you will save, and then here we have this electrical legend, and now you see that the insertion point specify on screen, scale and rotation. So now you can see that this particular set of objects will be saved as a block, and the other thing is will be inserted as a block. Now you can see that within this block there is some other blocks also. Now this will be as a block, so you can explode it to get the elements edited. So I'm not exploding it. Now if you see insert option, so in here you can see that with this block the other block has also come. That means you can see these are all blocks that was there inside. So now here you can use those blocks that were nested inside the block. For example, the GFC, let's say the switch. So or you can see that this is the block that was inserted that is nested inside that particular object, single pole switch. So I can now use this here in my, so I'm replacing this over here, the switch that I have. So then, so this is how basically the W block helps. And now with the block, with the W block that I inserted, there were other block that was there inside the objects that we have selected. That also came along with the W block. Now let's take another example. Now let's take this example. This is the block which I want to convert into a drawing. So now you can see that for this I have to go for a right block. So here I select this option block and select the block that I want to convert into. For this case, this is a bed 01. Now these options are basically deactivated because already the insertion point and objects are selected. So now what you do is you need to basically see the file name and the path. So here the file name will be saved as bed01 dwg, and you can save it as a drawing file. So now press OK. Now if I want to use this particular file inside the drawing that I'm working, so I go for insert option. So then I can select the drawing file. Now you can see the DWG file has been saved and press open, and now you can see that the bed will be inserted. Now one very interesting thing that you would see that here the drawing is in feet inches because we have done this, and the bed is in millimeters. So when we created the block, we told that we want to have the, when you can look into this particular floor plan over here, this bed is made in millimeter, but when I created the block I said that the unit is in millimeter. But now you look into it, the moment I brought this block into my this drawing file which is in feet inches, so automatically CAD has converted it. How? So if you look into the units option, there is basically the unit to scale inserted content is inches. So obviously if I am using feet inches, so here the object that I will use as a block will be in inches. Now what happens if I am inserting the block? Now you can see that this particular block, the factor 0.0394, that is the conversion factor from millimeters to inches, this particular factor comes into play. AutoCAD calculates it between inches and millimeter, and then it inserts into the file. Again, let me tell you what. So now let's say if I have a drawing, let's say I open a drawing and I work in feet inches. Now let's say if I go for units and I set it as engineering, and let's say give you an example. So let's see how the conversion can be made. So if a drawing is made in millimeters and if you want to bring that drawing into feet inches, what you should do? This is a classic example. So this is something that, let's say if I have a room, let's say 10 feet, 10 feet. So here I have this room, and now, so you can see, so if you want to dimension it, so you can go for a dimension style, and you can use the primary units as engineering. Now you will get a good idea about how the conversions are made. If you draw something in different unit system and if you want to bring into a different unit system, the AutoCAD helps in conversion with a conversion factor. So here, let's say I have this engineering units, and let's say I go with the fit option. Let's say I go with value of 10, the scale, and set current. So here I will also tell you the alternate unit system, how we can use it. So this is 10 feet, and now if you want to have the alternate unit system placed, that is in millimeter, you can have display alternate unit. So if you want to convert anything, let's say multiplier of all unit, say inches, so 1 inches is equal to 25.4 millimeters. So the multiplier for all the units would be 25.4 millimeter. That is, you're converting inches into millimeter. So here precision is 0. So now I made it below it. Now you can see with this dimension style, both of the units will be displayed. Primary units is the feet inches. So let me give some idea about it. Let's say I would be changing the text style. Okay, so this is the case, and now I want to insert block that has been created. Now let's come to this plan now. Here, this particular plan is created in millimeters. Now this bed is basically measures in millimeters. Now let's see here. So you can see the distance over here. Now let's say if I and the name of the block is bed 01. Now if I want to get this bed into, I want to create this bed into feet inches, I have to change from millimeter to inches, that is divide by 25.4. So that is a value that I need. That means whatever the value that would be divided by 25. That would be in inches. So millimeters to inches. So if you have something in millimeters, if you want to convert it into inches, so you have to divide it by 25.4. So now let's say here we have this particular block. Now let me do another. Let me give you an example. So let's say if you have this particular, I'll take something different so that I can explain you. Let's say I have a chair and desk. So now this particular chair is something that is in millimeters. And now I want to create a W block of it, and I want to insert it into my drawing, which is in inches. So I do a W block option. I select or I can go with the existing block. So let's say is the chair and the desk, and save it there itself as chair desk DWG. Insertion unit. Now this is very important. What would be the insertion unit of it? So here now you need to have that. It would be either millimeters or inches. So now if you create the W block, so it is very important. Now let's say if you select the chair desk, and the default unit in which it was created is inches, so let it be like this, and save it in as OK, and so it has been replaced, and come to the plan. So if you want to get so go for an insert. So you have this chair desk, press open, and the block is inserted. So it's redefined because we have changed something. Now you can see that in this the chair is inserted in the plan. So let me take another example where we should use the W block. So let's say I have this particular file. So here I would be discussing about how we can convert an existing plan which is made in one system and convert it into a different unit system. Let's say the plan is made in millimeters, but if you want to change it into inches, how do you do? And the way out is the W block. So let's go for an example. Now this is an example of a plan where it is drawn in millimeters. Let's dimension it. Let's go for a style, and let's say So we have this, let me have the text in Times New Roman, apply it, close. Okay. And in the fit, I give it as 20. Okay. So let me have the dimension of it so that we can check the drawing. So in this drawing, you have a workstation over here, which is some of the blocks are there. Let me have the dimension. Let's say I can give a value, let's say now 35, 40. That's a standard scale that I would be using for a. So dim-lin. So here, quick dimensioning, I would be selecting the object. So you can see the press enter and select this. So now this is in millimeters that you can see. Now let's suppose if I want to change, I want to get this drawing converted to feet inches. So what I do is I go for a right block and I say the entire drawing over here and save the file here as layout. So this is in mm. So the entire drawing file is now saved as a block and as a drawing file, layout mm. Okay. Now I open a feet inches file, let's say with imperial, and here I go for insert. Now I will browse for the file that I want to insert. Now I can see that it was in millimeters, so now the conversion factor is 0.0394. And here what I would do is I will insert it, let's say, and go for zoom extent. Now you can see that since this is a block, the dimensions are basically not changed over here. So what I'm going to do is I need to explode it and the dimensions are sized according to it. Let's not worry, let's have a particular dimension style over here. Let's say I go for modify and let's say I use a primary units as engineering and in the fit I will go for, let's say, 10 and the text I would be taking as times. Okay, so I can have a technique. Okay, so now let me dimension it and see that if the conversion is made. So now you can see that the conversion is there. So now you can see that along with when the object was written as a block, when you brought this, there were certain files, there were certain blocks that were there, and those block also is now embedded inside the project. Now you can use that for example desk 30 into 60 inches. Now you see that these blocks are also converted into the millimeters. So this is a classical example of how you can convert drawing which is in a different unit system to another one. The W block is very useful. So here let us revise. So W block from an object, from an existing block, from the entire drawing. So we have discussed all the three things. So now we would be learning about hatching. Now what is hatching? So hatching is technique, or you can say is the process of showing cross sections or fillings or making presentation in a plan or elevation or section. So in drawings, which is set nationally and internationally, the ISO or the BIS or the JIS standards, a hatch in a 2D drawing is basically a kind of presentation that is used in order to show the surface property or the material property of the particular drawing object. So the hatch can be filled in a brick, or the hatch can be represent a tiles in a floor, or hatch can be in the cross section of a brick or a cross section of a concrete, or it can be a steel cross section. So if the pattern are basically prescribed by the ISO or the Japanese standards internationally, depending on the type of a hatch, a different material is being represented in cross section. So you look into this particular diagram, so I kept it here. So this is the ANSI standard, that is American National Standard for Information. So ANSI 31 says that if there is a pattern like this, it will show if there is a section pattern, and pattern is given like the slanted one, you can see it represents iron, brick, stone or masonry. Similarly, the ANSI 32 has a different pattern for steel. For cross sections, normally if you provide a hatch pattern, it will show the material condition of that particular cross section. So similarly, hatches are not only for the section, but for the appearance also. Suppose if you want to show a brick clad in an elevation, if you want to show a ceiling pattern, if you want to fill the color. So hatches are used for very different purposes. Now let's see how we can do a hatching in AutoCAD. So now let's say I take an example in this particular file that I was working. Take a rectangle over here and see how the hatch works. So to go for a hatch command, so you need to have H. So it says pick internal points and then press enter. So now you can see that doing so, press the H and then you can see that there is an option called pick internal point. So once you click inside the object, the hatch creation contextual tab is displayed over here. Now you can see that in this contextual tab, there are different panels like the patterns panel, the boundaries panel, and then you have the scale like the angle, the layers, transparency of the hatch, setting the origin, making it associative, making it annotative, and match properties. And along with this, you have this option called hatch setting. So if you open this, the hatch and gradient dialog box will be displayed. Now here there are two tabs, hatch and gradient. So in the first area, that is the hatch type and pattern, there are three different types of hatches that you can select. For example, first is the predefined tab. So if you select the predefined tab, you can basically click on the button and there is a hatch pattern palette is displayed. Now there is an ANSI type. Now you have said that ANSI 31, ANSI 32, ANSI 33. So you have ANSI 38 patterns. Similarly, the ISO patterns and the other predefined patterns. So if you look into it, the ANSI 31, which represents the ANSI 31 represents the stone or the brick masonry. And similarly, you can go for the ANSI 32, ANSI 33. So if I click on this, now I have selected the type as predefined. So predefined means it is already defined in AutoCAD. User defined is user will define the pattern. Similarly, custom is suppose you have a custom file, you write a code, you write a program that will define a hatch pattern. So we are not using the custom at this moment. So let's see, we have a predefined option. So you have this pattern and then you select a color that you want to give. And similarly, you can select the fill pattern. If there is a fill that you want to give to the hatch, or you can say none. So let me give it by layer. So then you have the angle and other things. So we will discuss this one by one. So currently, let's see how the hatch works. So to hatch an object, you need to have a closed region. For example, a circle, a rectangle, or let's say if you have something, a closed entity like this, let's say. So you go for a hatch and then it's asked for pick internal point. So the moment you say H or you go to the home tab, there is in the draw panel, you have the hatch. So the moment you say hatch and you say the pick internal point, the AutoCAD defines the closed boundary and gives a preview of the hatch. And then let's say before doing so, you can always select the patterns. For example, how do you select the pattern? You can select the pattern from, it can be a solid pattern or a user defined pattern. So you can have it from here itself, or you can basically go it from this. Let's say you can have a brick pattern. You can select a brick pattern. Or if you want to go, let's say, if you want to go one step ahead from the dialog box, so I would suggest that you should basically go with the options over here. So once you have these options, now you can select this. For example, if you want to have the predefined pattern, and from here you select the ANSI 31. Now you can see the preview over here. And give some scale. Let's say if you want to increase the scale, so you can pick point and see that how it happens. Again, if you are satisfied, then you can press enter, or you can go again to the dialog box to change the scale. For example, you go with the ANSI 32. right? And then if you want to change the scale, that means if you want to change the spacing in the hatches that has happened, let's say I want to make it 20. So you can see the preview over here, and so the preview shows the actual how the pattern will be done. So press escape to return to the dialog box. So press escape, again you return to the dialog box. Now let's try with more patterns and more scale. Let's say I'm having a scale of, let's say 1. That means it will be shown at full scale how the way it is programmed. So now let's go with the ANSI 32. So we selected ANSI series. Now I can go with other predefined. Let's say if I select this pattern. So this ANSI is for sections, and other predefined can be used for sections, can be used for kind of surfaces. You want to show the elevation of a wall or something, some pattern that you want to show in the wall. So we'll do some examples, live examples. So now let's say if you want to have the brick pattern, and if you want to see the preview, now you can see that the pattern is filled in this boundary. So what happened, the AutoCAD defines the boundary and the pattern is filled. And then if you want to have more patterns, you can go. So custom is something that if you define a file for hatching and you program it, you need a different hatch pattern which is not available either in the ANSI, ISO or other predefined. You can have a custom. So let's go with selecting some of the patterns. Let's say I go with this and I can see the preview here. So now it is a dense kind of thing. So I will increase the scale over here if I find it. So I go with increasing the scale to 10 units, or if I find more density, so I can increase the scale and see how the patterns will look in the drawing area. So press escape and let's say I go with 30. So this is about the predefined. Now with this predefined, you can define a color. Let's say if I go with a color called, let's say I go with a red color, and I take this one. So I will select it from the dialog box. So here you can also select from the drop down list also, because if you know what you want to select without seeing the preview, you can always select it from the drop down list. So I've taken a square pattern. You can see the preview of the square pattern here. Now you can see where the square pattern is. So this is selected, and then you can see the preview, how it looks like. So there is a button over here. There is a tool. Let me go for the preview first. So here we have. Now you can have the scale option controlling the spacing between the patterns. So if you want to have fill, let's say if I want to give a background filling, let's say I want to go with yellow. So you can see the preview. So along with the pattern, there is a fill inside. So press escape. So this is about the predefined. So we'll be talking about the boundaries and the islands and the other thing. But the left hand side, let us discuss about it. Now let's say if you say that I want a ANSI pattern, and here you see the preview. So what you can do also is you can also get the angle. So let's say if I want an angle of 90 degree, now you can see that the pattern changes. So along with this, I would also go for a user defined. Now this is a typical example where I would be creating a horizontal or vertical line. So in the user defined, I have this option called spacings. Now you can see the pattern is deactivated. So here in the spacings, let's say if I want a spacing of 300 units and at an angle of 0 degree, you can see the preview over here. So let me have the sense, let's say I will remove the fill to none. Okay. So let's say if I reduce the value, I have to need to check what would be. So I go with 20. Now you can see that the horizontal lines are basically created as a hatch pattern. So if I want to have a hatch pattern of 10, let's say 10 spacing, then that is horizontal. So this is, and if I want it in a particular angle, let's say in an angle of 45 degree, so I can give an angle of 45 degree. Let's say want it a double one, so I can always have a double spacing. Now I want to have the origin of my hatch pattern. The origin of the hatch pattern is from where the hatch starts. For example, if you can see that the pattern starts from some offsetted dimensions. I want to keep this as the origin of the hatch pattern, from where the hatch pattern basically is filled. So I go to escape and I select the specified origin, click to set new origin. So I set the new origin at this particular point. Now you can see the preview that the hatch pattern originates from this point. So if you put it in the center, so let's say if I put the hatch pattern at the center, there will be options, there will be times when I put it in the center. So you can see that how it basically changes from the center. So we'll be having a case study of that. So apart from that, now moving forward, we would be learning more advanced tools in Hatch. So let's see what are the advanced tools. So for hatching, you give the command H. So here we have this pick internal point. So pick internal point, there's a settings option. So before that, let's create some object. Let's say I have a circle, I have another circle, and let me put more object inside it so that I can explain you the advanced option in the hatching better. So now let's say there is a circle and there are a lot of other circles inside it. Now, if I go with hatch, so there are two options to invoke the dialog box, that is the hatch and gradient. One is through the settings option. You can have this from the hatch creation tab. There is the options panel, and then you can have this dialog, or in the command you can click the settings option. You can have the similar option. Let's say if we select the type as predefined, and then we can pick a point from here. So the moment we pick a point, we see a preview over here, right? So now if you want to go back and change something, let's say if I want to select another pattern, now if I see ANSI 37, but I need to increase the scale, we can also increase the scale from here also. Let's say if I increase it to 5, let's see what happens. So you can see that and the angle over here, if you want to change the angle, you can change it from here also, or from the hatch settings option here, hatch and gradient. So you can see the preview also here. So you can click the escape option. Okay, so now let's say using these options in the tab. So let's say if I want to have more option, let's say I want AR concrete, and let's say if I want to increase the scale to 10 and press enter. So now I can see that okay, so if I press 1, so there are different scales, and if I press less than point let's say 1, let's say 0.1, so this pattern is now there. You can see there is a background filling over here, which is controlled by this particular drop down. So you can say none over here, or here itself in the hatch and gradient, there's the option for the color. You can set the color from here also. So you can see the preview, and if you are satisfied, press enter. Now here you see that when I selected this island over here, these circles were not hatched. The reason why, because in the hatch we have got some settings. So let's talk about those settings. So now let's say if I have a closed loop, a circle, then I have another closed loop, and here. So if I go with hatch, so I can use the hatch and gradient dialog, or I can do it from here also. Let's say I select a pattern. Let's say I select ARB88 and then pick a point. So if I pick a point outside, so the inner circle are not hatched because I've got a different kind of settings that I would be discussing right now. Now, what are the settings that we have? So for that, you need to go with the options setting over here, that is the hatch and gradient. So here in this, click on this more options. So here in the island detection technique, so in the island detection, we have this checkbox on, and we have got three options. One is normal, outer, and ignore. So if we have the normal option, so what will happen? The alternate closed island will be hatched. For example, you can see the preview over here. Now let's see for this particular hatch pattern. I would like to see the preview. So here, let's say it's already hatched. So let me press OK. So let's take another option over here. Now you can see that when we had taken the normal option, the hatch was created in the alternative island. For example, in this particular closed loop, and then there was no hatching here, and then the hatch was here. Now go to the settings, and if we say outer, you can see that as we have seen that only the outer portion will be hatched and the inner portion will not be hatched. So again, going to the settings, now let's with the ignore option selected in the island detection. So you can see that all the objects inside the island will be hatched. So this is now right click to accept hatch or escape to return. So now these are the options that you should choose while you are hatching. So by default, the normal option is selected. Now if I say retain boundary, then what will happen is, so we'll be doing this option later on here itself. So inherit options, we have the use current origin, that's fine. And then there are options like if you want to remove some from the boundary. For example, if I want to remove this particular object from hatching, so now you would see that the hatching is not over here, done over here. So press enter. So the hatch is done. Now if you want to edit this hatch, so go for the command called HE, that is for hatch edit. Select the hatch. You again come to the hatch edit dialog box. So here, let's say if you want to add this to the selection, for example, I want to add this particular object for the hatching. Now you can see that in the normal option selected, the interior of this circle will be hatched. So this is how we do the hatching in the island detection. Now let's say if I want to go for changing. Now I'm doing the hatch edit in the dialog box. So here what I can do is I can change the pattern, right? Or let's say if I want to give a different pattern, let's say okay. So the pattern will be changed in the hatch. So let's do more option here, and let's learn about the gradient filling option in hatching. So once you go for hatching and you have the settings option over here, so the gradient option can be selected from the drop down over here in the properties. So we can have the gradient option, and then we can have different options of the gradient like the GR, linear, GR, cylindrical, and different kind of thing. And also the color. For example, if I want to take the color as yellow, and now I see how it happened. Now you can see that there is one color that we have selected, the yellow, for the gradient pattern. So if I click on it, a gradient hatch will be created. Similarly, I can do the hatching from the dialog box. So here we have this gradient option. Now you can see there is a one color gradient and the two color gradient. So if I want to have a one color gradient, you take this color, select any of the pattern over here and say OK, and pick the internal points, and you can see that hatch is done with one color. If let's say if you want to have the two color option, one is this color one, and the other you want to select a different color, let's say cyan color, or a color which is like this. So you can see the hatch pattern changing over here, and you can basically over here you can select the type of orientation or type of pattern that you want to go for. Go for the preview and press enter. So you have this different type of gradient hatch patterns shown in the screen. Now in the hatch, when you do a hatch, so go to the hatch and gradient dialog box. So we have done the gradient, and let's say there is another option called add selected object. For example, if you want to only select this object for hatching, you don't want to go for internal points, so you can direct select an object, and then you can select the hatch pattern that you want to give. For example, if I want to give an ANSI pattern over here, ANSI 31, so here basically, and then you can give a scale over here, and the angle is 0 because that's the default scale. Now you can see the hatch pattern is done, and so you can press escape to return to the dialog box. So this is how you can basically do. And let's say if I want to remove and make it none, you can see the preview over here. So this is the hatch pattern is done. And then when you do a hatch, let's say if I have this object, let's say if I want to go for hatch, and there is an option called associative hatch. So if the hatch is associative and I select this, so what will happen if I move the hatch is moved from here, but if I move the object is associated with the hatch, so the hatch will also move along with the object. So if I make it non-associative, for example, if I remove this one and make this hatch pattern, and if I move the object, the hatch will remain same at its place and the object will move. So the hatch is not associated with the object that is being hatched. Now there are other options that we should also try to look into it in the hatch. One is the draw order, and we did the associative hatch and create separate hatches. Now what happens with this particular parameter? So let's say if I have got 3 objects and I do a hatch of all the 3 objects together. Let's say I give a scale of 10 over here, 1, 2, 3, and let's say all the 4 1, and close the hatch. So this is as created as a single hatch over here. So if you are going to edit it, you can not control all the hatch patterns. So you have to control it, let's say, all together. So all the hatch pattern changes now together. Now if let's say if I want to have separate hatch patterns, controls of the hatch in the separate boxes over here, so I go to the settings and here I select this option called create hatch separate hatches. So what will happen is here once you select the hatches, let's say I give a scale, let's say 10 units, 1, 2, 3 and 4. What will happen? These objects now will behave as a separate hatch. So you can edit them and give them a different pattern. So this is how we do a control. So we go to HE for the hatch edit, and then you can change the pattern, and now you can see that the hatch pattern is different in this particular box. Now let's go for more tools in hatching. So we did as of now we did in the hatch and gradient dialog box, we did the hatch with the gradient option. We understood about the hatch origin, pick, point, select object and remove boundaries, and the element creation. Now there is an option called draw order, layer and transparency that we will be now looking forward to it. And then we have this gap tolerance, which is also very important, and boundary set, this is for the 3D view. So let's go, and then there is an option called inherit hatch property. So let's go with the inherit hatch property. So in the inherit hatch property, if you want to inherit any of the hatch properties from the previous hatches, so click on it, select the hatch pattern that you want to basically give it to this particular hatch pattern. So now you would see that the hatch pattern is inherited from this particular hatch again. So let's go. So this is the same as the match property in this particular tab. So if I have the match property option, so click on the match property, select the hatch pattern and dip it over here. So now let's say we talk about the draw order. Now let's say you have this line, and let's have solid filling at this particular profile, and we go for a hatch edit, and let's say I change the color. So here I go with the change in color, let's say yellow, and press OK. Now there is an option over here. Let's say if I go for another hatch here, if I say, let's say if I take NC32, so this hatch pattern is drawn over the existing hatch pattern. Now let's say if I want to change the draw order is this line is visible because this line is above the filled line, yellow filled line, and this line is visible because it is up above the filled line. So when we go for the hatch edit, and if you select this pattern, that is the yellow one, and if you say the draw order is sent to front, bring to front, so you can see that what will happen, all the hatches will be not visible because it came to the front of the island. Now if you want to bring it back, now the lines also, the boundary lines are also not visible. So in order to make it back, select the hatch pattern, go for the draw orders, send to back, and say OK. Now you can see. So now this is how it works. Now let's say if there are certain objects which is behind the hatch pattern. Let us take this situation where the filled hatch is brought front over the other hatches. So if I make this hatch transparent, the other patterns will be visible. So I go for the hatch edit and select the transparency option. So if I change the value of the transparency, maximum is 90. So you can see in the preview that the hatches at the back is visible and the hatch becomes transparent. So this is basically used when we have certain objects which is behind the hatches and we want to see them. And then we have the layer option. So let's say if I have a layer I create a layer for hatch and I want all my hatches to go into that particular layer. So I have this layer called hatch and press enter, but my current layer is 0 right now. Now let's say if I want that all my hatch patterns should go into a particular layer. So here in the hatch and gradient dialog box, I would say that it will go to the hatch layer and pick a point. So what will happen is automatically this object will go to the layer called, if you select this hatch pattern, it will go to the layer called the hatch. So this is how you can do you can change the layer of the particular hatch while you are hatching to a particular assigned layer, right? And then the last option that need to be defined is the gap tolerances. So let's say if I have a line which is not closed, which is having a particular gap over here. So let's say now if I want to go for a pick point right now, so if you look into it, the closed boundary cannot be determined. So there is a gap over here. So if I give a gap tolerance of let's say 100 units, so that if the gap is within the 100 units, the hatch, let's say, can be created. So the hatch boundary is not closed. What you want to do, continue hatching this area. So now what it happened is, it had basically detected the open boundary and put a line over here to close it, and the hatch is done. Okay, now other things about interesting facts about hatch is if you do a hatch, let's say, and if you want to create a polyline out of the boundary that you have created, so we have the option called generate polyline. So you can see here in this option over here, more option, you have this option called retain boundaries, and you have got region and polyline. So if you want to retain the polyline, so you press OK, and the moment the hatch is done, you can basically remove the polyline or move the polyline that is created. So a polyline is created from the hatch if you retain the boundaries. So this is done in the settings and in the hatch and gradient dialog box, and this is the settings for it. So when you have a hatch, go to select the hatch, and you can see that the grips of the hatches are visible. So you can basically change the boundaries of the hatches. Okay, so now you can also do the grip editing of the hatches. So if you want to see the properties of the hatch, you can go to the properties, and you can see that one of the very interesting property of the hatch is the area. So now let's say with this particular option, you can also basically find out the area of the closed region. So here we have this option over here. Now moving forward, I would be basically taking down some practical examples from the civil and architecture, and I will be doing an illustration of how hatches can be used for various kind of presentations, like creating sections, creating elevations and patterns. Now let's do an example where we have this a small plan and an elevation. We would like to hatch the wall section. We would like to hatch the flooring pattern over here in these two bedrooms and the living. and then we will be doing an hatch option, hatch pattern, filling pattern at the elevation. So this is the front elevation of this particular plan. So now we have got two kind of situation when we are going to hatch the section of the wall, because when we are showing up layout of this, it is a section of the wall, and then we would be hatching the pattern of the flooring pattern. Now let's see how it works. First of all, you need to in this particular drawing we have a layer called hatch. So I put it current and I go to hatch. The first thing that I want to do is to hatch this particular cross section over here of the wall. So for this, first of all, I would take a pattern. Let's say I would like to go with the ANSI 31 pattern, which is basically for the brick wall. And so I pick a point. Now the moment I pick a point over here, you can see that the hatching is shown. So here again I go to the hatch settings and I would like to have the scale, let's say increase the scale and see how the pattern looks like. So I want to increase it more. So let's press escape and let's say I make it 25. So if I'm looking into the preview, the hatch pattern is exactly what it has been shown over here. And then I want to hatch individually all these particular islands. So now here one thing that I should go is to create separate hatches. So what will happen if I do create separate hatches and I pick the island? For example, I want to hatch this cross sections to show the wall. Okay, this is a window and there's a staircase over here. Okay, so press enter. Now the wall is hatched. Now if I want to give the color to the hatch, so what now here you can see that I can individually change the hatch patterns. So if I wouldn't have taken create separate hatches, then what would happen is all the hatches would have gone to a single hatch. So I can edit the hatch. For example, if I want to edit this particular hatch, change the color, so it will now be changed. But at this moment you can see that the color that the hatch is taking is from the layer. So I can have a red color. So I can go and individually change the color of the hatch pattern. So this is this wall section, how you can do the wall section. So we'll be doing more sections later on. But here we are, and then we have the outer option selected over here. Now we'll see what the outer means. Only the outer hatching would be there. If there is something inside, it won't be hatched. So press OK. So now other thing that you can do is to match the properties of the hatches. For example, if I want to match the properties of the hatch, the color will be changed. So I need to match MA and match the property of this here. Press it. So I think most of the hatch is done. Just I wanted to open the line weight and see how it looks like. So I had given a particular line weight to the external walls, the walls in fact. Now I want to do a flooring pattern over here. So there are two options. If you keep the object over here and let's say the flooring pattern is 600 by 600. So here I would be going with a custom hatch pattern where I would be going for a user predefined, where the spacing is 600 millimeters, means 2 feet. We are doing in feet inches, so it is 2 feet. And we are going to take a double option and pick point. Now the moment you pick the point, you can see that the hatch is done inside this, because it is creating a closed option, and then the text is not hatched over here. Okay, and the objects that are with the blocks over here, they are also not hatched because we had taken the outer option. So what we need to do right now is, if I want to only have the flooring pattern for this particular room, here what I will do is I will create a line which would be basically giving me an enclosure for the hatch pattern, so that the hatch is restricted to the only the floor area of this particular. So let's say here I want to restrict it to this particular line, but I want to give the floor pattern to the staircase over here, or I can basically restrict it at this particular point. So this is something that we need to see, that when we are doing an hatching, we have to have the closed boundary set. Now we have the hatch, and go to the settings over here, and then we have this 2 feet is the distance, and we have an ANSI 31. We can see the swatch, and here we can go with the pick point, and now if you click on it, the hatch will be displayed. Now if I want to start my tiling from this particular point, so now you can see that 2 feet tiles are there, and here I want to make it associative actually also, and here I want to change the origin to this particular point. So here once I change the origin to the particular point, the hatch starts from here. Now you can see the tiles are building from this place, and press enter. Now we have a hatching done. Now I want to give some shade to this a marble, to a tiles over here. So I would be using a gradient kind of hatch pattern below the hatch that I can see. So here again I go with the hatch, and here again I go with the gradient option. But now over here I'll take a one color, and let's say I go with a grayish kind of shade, and see the, and I would be, for the shade I would prefer to have shade like this. Okay, so I can have the tint, we can change the tint from here, let's say, yeah, and then I pick a point over here, but I will try to send it behind the boundary. So once I click into it, so you can see that the gradient hatch comes above the hatch that we created. So we go to the hatch edit now. So how do we go? Select it, right click and hatch edit, and here we have the draw order option, and we will be saying send to back. So this is way how this, and now I can change this particular color. Go to the hatch edit, and I change it, let's say I make it a black, so it is dominant. Now the tiles are visible in this particular floor pattern, and the living room is written over here. So this is how I do hatching in this particular room. And similarly, if I want to do the hatching here also, so in the 2 bedrooms, so what I will do is I'll match the properties. Okay, I'll go over the match properties, select the hatch pattern that I want to match, put it here, and also at this particular portion, because this is also the tiled portion. And again, if I want to start the tile from this particular point, so I would go for hatch edit. Now these 2 objects are separate hatches, so I would like to go with the click to set new origin. So this is the new origin, so you have the preview over here, so press enter. So this is how we have created the patterns. Now if I want to change the origin of this particular hatch pattern, so I go with HE, select the origin over here, click to new origin, and it starts from here. Now you can see that the tile starts from this particular point. So other things that we need to make sure about is, if I don't want this hatch text basically to be a part of this particular hatch, and I want the text to be displayed above it, so I go and select the hatch and do a hatch edit, and here we have the option called remove boundary. Now here you can see the text is there, so you can select this text, press enter. Right, now this boundary is selected, and then if you see the preview, the hatch is displayed and the text boundary is removed. So let us do it for this also. So now here we go and say we go for a remove boundary, and select the object. For example, I go with this hatch, let's say I go with the hatch edit. Let me go with the hatch edit first, HE, select the hatch, and then I remove the boundary, let's say this text, and press enter. So similarly, if I want to do it for this, so I have to edit this hatch, HE, select this and hatch, and then we have to go with the remove boundary option, select this and this, press OK. So the text are displayed above the hatch pattern. So now after doing this, let us do this particular elevation. Now here we have this wall. This is the projected chhaja, projection is there, and this is the window, and we have the window frame, window panel, and the glass. Now let's do this. For example, I want to give a brick pattern in this wall for the surface hatching. So I go with the hatch, select the point, and then we go with the predefined option. Here I have this option called ARV816. So I select it, see the preview of it, but it shows a bigger scale. So what I need to do is I go and create this, make the scale as 1. So I can see the bricks are shown over here. And then if I want to change the origin right now, so I would go with and say select, click a new origin. So I am just laying the brick from this particular point. So now you can see this particular hatching is done, but the internal hatches are not done because the island detection is selected. So this is very important. The outer option should be selected. Now, similarly, if I want to do, this is again a projection, and then this is again a kind of a wall, a parapet that is done. So this is something that I want to do with the brick inlay. So if I want to decrease the size, let's say I want to scale it down, let's say I make it 0.5, so it will become more smaller. Now here other things that I want to hatch over here is this particular projection. So select the internal island for the projection. So let me select, and it will take the previous hatch. So if it is closed entity, then it's not a problem. And then here I would go and go with the solid option, and I would take a color, let's say a grayish kind of color. So press OK, and you can see that the hatch is done over here. And similarly, I want to go with the bottom one, and these are, so now you can see that gray shade is there, which shows that it is a projected elevation somewhere. And similarly, the same shade would be for the projection here. Let's say the projection is at this particular point, so I can use the hatch over here. Now if I want to give a different shade to the frame, let's say I go to hatch and click over here, and I take a different color, let's say a kind of brownish color. So press OK. So now again the outer option should be selected in the island detection. So again, very important is this option should be selected in the boundary selection. So now this frame can be done. And other thing that you should also realize that the option of separate hatches should be there, like because it will create separate hatches, and the associativeness should be there. So press OK. So now the frame is done. Next would be the panels. So I want to give a different color to the panels, and let's say I go with the hatch option and select a pattern. Obviously it would be a solid, but let's say I want to give a different color to it. So I take the color swatch from here and select the color, let's say a lighter shade, so that it is visible. So now zoom inside and just click on the island. Now the hatch boundary is not closed probably, so now there might be some opening that is there, let's say. So now you need to have the zoom area done. Now you can look into it, right? So the screen should be visible. I mean the boundary should be visible inside the screen. Now the panels are, let's say if I want to do this panel, so now if I click on it, so now let's understand what is the problem that is going on. So let's say if I go for a hatch and I select a different color, let me take a different shade. Let's say I go with the shade which is a darker shade. So now let's say if I click on it, it is done, and here it is done. So the panels are done. So now if I want to have the panels, more panels, so it should be visible. So I would like to do the same thing over here, and again it should be associative. So associative means that it would be with the boundary. If the boundary is moved, the hatch will move. Now we have this panels over here, there's a glazing over here, and there's a panel over here. And let's say if I want to have some other patterns, we can do a pattern. So let's go with the hatch and let's see what are the patterns available for a wood. So here I can see that there are certain patterns. I can select, let's say, the ghost wood, because it is not section, so I can have a different pattern. So I click on it. Now you can see that here. And if I want to have some kind of angle to it, let's say if I want to have it at a 45-degree angle, so I can always give it at a 45-degree angle. So this is something, the patterns that we can develop. So this is how. Now if I want to give a shade or a to this particular boundary over here in the wall, so I can always go with the gradient shade option. Let's say I can go with the gradient shade and select a color. Let's say I select a lighter color, let's say here, and pick the point. Now you can see that here the gradient shade is above, so you can go and select the gradient shade, do the hatch edit, and send to back. But the other thing that you should see that what type of orientation you want. For example, I'm taking this one, send to back. Now this will be serving a purpose where we can show the presentation. So this is how we can have a different kind of hatching. For example, if I now let's take another example where we have let's say some columns over here. So I'll be quickly doing this so that you understand. So I have a column, let's say 12,9, 12 inch by 9 inches column, and here let's say I want to give this column, there are a bunch of columns over here. So when I am putting it in the section, the column should be hatched. So you can show the column with the symbol with the presentation, like for example I take an option over here like the concrete one, if it is a concrete column. So here we can go and say AR concrete and pick a point, and then you can always, or you can fill it. You can have different patterns depending upon the standards you are using. So this is how the hatching is done. And the last thing is that there is a command called fill. So if you basically, there's a command called fill, if you put it off, all the hatch will be, and you say regenerate, all the hatch will not be displayed in the screen. So if you want to have the fill mode on and then press RE to regenerate, the hatching will be displayed. So this is was about hatching. I hope you can practice it and create sections, elevations from the detail, and use the hatch wherever required with a section hatching like this or the surface hatching like this. Thank you. Hi, welcome to the week 10 for AutoCAD Essential for Civil Engineers. So this is the week in which we are going to do some very important topics like layouts, plottings, and some advanced tools. Now let's see what we are going to cover in this session. So after the completion of this session, you would be able to use layouts, plot objects, use groupings, and use multi-layers. So before we jump start to the layouts, first of all, let me explain you what is the concept of the layouts and viewports in AutoCAD. Now, viewports are basically the ports where you work. For example, we have a viewport over here in which I am working right now. And also, the AutoCAD has got two spaces. One is the model space over here, and the other is the paper space. That means whatever you work in AutoCAD, you work on the model space at full scale. And later on, when you are going to create the sheets of it, you're going to create the sheets and the layout at a particular paper size. So here, first of all, see about the viewports that are available and we can work at in models place, as well as how we can set up the sheet for printing, for the publishing, or for the plotting, so that we can have the sheets ready for the GFC or the working drawings. Now we will be taking different examples, like we will be having a metric example, and we will also be having a feet inches example. So here I have started with a metric option where we have a plan that we have already done in millimeters. So here, so before that, I would like to tell you about because when you are taking a sheet, so you have to go with the annotation scales and the scales of the sheet. So every sheet would be having a paper size like A0, A1, A2, A3, A4, all are having a different paper size, and the prints are taken as per the scales are taken as per the paper size what we are going to fit. Now let's take an option over here. See a particular example over here. First of all, we'll be learning about viewports, what viewports are, and then we'll be learning about layouts and then about the plotting. So let's start. The commands for the viewports are here. So you can see that in the view tab, there is a model viewport. So we are talking about the model viewport. We are not talking about the viewport in the layout. So here, if you look into the viewport configuration, you can change your screen. That means you can have 4 or 2 vertical, 2 horizontal, or 4 equal you can take. So that if you can basically, if you're working on a 3D, this viewport is going to make you a lot of difference in working faster. So here you can basically have different objects in different view scales. Also in 2D, let's say if you're working in a particular viewport in elevation, so I can work here in elevation and then I can work here in plan. So the point is, the viewport is basically the screen is divided into 4 parts, and different parts is having a different view range. So that's how. For example, here I go with the view. So let's say if I create a view of this elevation, so here it's a very simple. You have this top view over here, so you don't have a 3D view, so you don't need to have it. But let's say if I save the view, I save the elevation as a view, so I go with a new view and I save this as, let's say, elevation. So keep it like this. So this particular view is the elevation view. And then let's say if I want to work in a different legend, so I can save these views and work in multiple viewports. So this viewport can be single, twice, I can have it split into 2, or this viewport can be 3 left. So you can arrange this viewport as per your convenience as you are going to start working into it. Apart from that, there are basically named viewport. For example, the named viewport is create a new viewport. Let's say I name it as V1, and here let's say I set up some styles. For example, for 2D, I change view to elevation. So I'm giving let's say for a particular model configuration, and let's say the visual style. So here you can see that I have created a named view with this particular view in elevation. Now for example, if I want to save this, so now let's say if I go to the single view and I select my named view as V1, I will find the same view arrangement that I had saved. So let's take another example. Let's say if I zoom this particular, I create a particular view over here. So I make it a name of the view as plan and save it. So now let's say if I change this to elevation, the elevation view will come, and if I change into plan, the plan view will come. Now if I want to save this viewport with this particular configuration, so I make it 2, and this is basically where I would say that, suggest that, you know, setup is 2D and the current view is, let's say, plan. So you can see that this particular viewport configuration will be saved with this particular settings. Now here, now the view is plan. This setting is plan and this is the elevation view. So you can change the view to elevation. Let's say if you want to change go to the view manager and change it to elevation. That's all. So here, here you want to save the view. Let's say if you have saved the view to whatever the view configuration, so you can see that those views will be let's say if you want to go to V1, the V1 will be, so different viewports can be created in the named viewport. Now if you want to join 2 viewports, let's say if you want to join these 2 viewports, so you can always have select the dominant viewport, that is the current viewport, and select viewport to join, for example these 2 viewports, and you want to make it a single viewport. So again, this viewports can be joined. The important thing is, what is the use of the viewport? The use of the viewport is you can do multiple works in a drawing. Let's say in a particular model you have an elevation, you have section and you want to work them in different viewports to make them efficient. So you can also split the screen. Like for example, you might be working on multiple monitors. In what one you can basically put the plan, and on the other you can put the elevation, and you can start working into it. Otherwise, or these viewports are also docking, you know. So you can see that these viewports can, the sizes can be changed from here. So this can be docked. So the good thing about this is you can increase or decrease the size of any of the viewport. Now coming back to the layouts. Now the most important part is the paper space or the page setup. Now by default, if you look into it, so here you have got, I'm changing my viewport to single viewport. And here what I'm trying to do is I'm basically trying to explain you what is the difference between model space and layouts. So model space is the place where you work, and the layout is basically the paper which is set in order to take the printouts. For example, if you by default the layout 1 and layout 2 are there. Now over here in the layout 1 there is a page which is set over here. So you can measure. Now you can see the icon of the UCs has changed to a triangle in which X and Y direction is shown in a triangle. And if you measure the distance, you can see that the page size is 299 and this is probably around 206. So this is a A4 paper size that has been set. Similarly, if you go to layout 2, you can also measure it. So we can have different page setup. For example, this same. So this page is a A4 paper size. So we'll be creating more pages, paper sizes, and putting into the layout. Now let's say how we will be starting out with the layouts. So if these layout tabs are not visible, so here you can see the layout tabs, you can put it off, the file tabs. So file tabs is this one. And okay, after the session, I'm talking about the tile horizontally and tile vertically. Okay, I can do it now itself. So let's say if we have got multiple files open, let's say right now I have only one file, so let's not discuss about it. Let's come to the topic now. So now layout is something that it is the page in which we are going to take. For example, to start with the layout, I want to create a new layout. I'm not going to use it, and later on I will use it. So I go with a command called the layout. Here, first example is I want to create layout for the elevation, and I want to create the layout for the plan. So I have a new layout. I say new, and I name this layout. Enter new layout name. I name it as floor plan. Press enter. So a layout with the floor plan is now created. Now I can create more layout by clicking in the plus button, and by default the layout 3 would be there. So I right click on the layout 3. I can rename it. I can make this as, let's say, the elevation. Later on, if I want to delete this layout, I can select them and delete the layout. So I can have as much as layout in my drawing. So I'll be showing you some of the good examples of the layout. But first of all, let's say if I have this floor plan layout, and so by default you can see the paper space is there and there is a rectangle over here. This is the viewport. Now in this viewport, this is the screen of the AutoCAD, the viewport in which you were creating. So this is where the view is there. So in order to go inside the screen, there are two commands. First is the MS for the model space. That means you are inside the model. You can zoom them, zoom out. That means you're inside the screen. And the other command is the paper space. That is you are in the paper, you are in the model. You are in the paper and you are in the model. So when you are in the model, you can zoom the screen and zoom the view. But if you are in the paper, you will be zooming the paper. Now, if this viewport, if you select and erase it, so there will be only the model space would not be there, the paper would be there. Now, I want to basically now create a viewport in which I want to create the plan, because I have deleted the viewport. Okay. So for, let's see in the layout tool, is there any other command that we should go for? Okay. Then we will come into the viewport. You can copy an existing layout. For example, you want to copy the floor plan layout and make it. But before that, I would like to tell you about that. So if I want to create a layout with a template means is an inbuilt template where company's name, scales, and everything is given. Let's see what the template is. So now let's go with the layout and select the template option. So the template option is the DWT option. So here we have some for architecture, for imperial IARC is there, but I want to take the template for the metric architecture. Apart from that, I can go to the sheet set and select the architectural metric. Let's go with the architectural metric. Now you can see the preview of it. There is a border over here. There is some templates over here. Open it. So it has the layout named as ISO A1. So the name of the file was metric architecture, but the layout that would be copied over here. So when I go for the layout option, you can see that the template that I had selected, for example, I selected this architectural metric, and the name ISO A1 is the layout name. I have to select it and press OK. So this name is basically, now this denotes that this particular template is of A1 paper size. So I can measure it. I can go with the distance tool and see the size. So it talks about around 800, and let's say if I go to the width, I can see the distance as around 600. So it's an A1 size, and here I can see some kind of drawing templates over there, like the project, like the name and address, and the paper space is definitely over here. So I can, if I want to decrease the size of this icon, so I go for UCS icon, and there's a property option over here, so I can reduce the size and make it small. So here I can see that there is a template that has been drawn, and I want to get my drawings inside the template and print it. So let's do it without a template, and let's do it with a template. Now other option in the layout is to rename it. For example, if I want to rename the floor plan, so enter layout to rename, let's say floor plan, because it is selected. So if I want to do the ISO one, so I can rename it by right clicking it and renaming it. Let's say if I want to rename it as, so go for a rename option, detailed plan. So now this, we have got three layouts now. So in the elevation also, it is this viewport now here. So if I want to go to the model space, so in this template we have a model space over here. If you go to the MS, right, and probably this is a block. So we'll create our own model space over here. So let's go to the floor plan now. So I think if in the layout tool, if you go for the copy option, enter the name of the layout to copy, let's say floor plan, enter, and what is the name of the new, let's say detailed floor plan. So what will happen, whatever the style of the floor plan was, the paper size and other thing, it will be copied to a new layer. Similarly, if you want to delete a layout, so it will ask you delete option. So you can delete the floor plan, let's say. So it has deleted from the list. So now you have only three layouts. So then you have another option like template we have done. So you can save this as a template. So when we'll be building the template, we can save them. Okay, let's come to the detailed floor plan. We have this entire project over here, which we are going to take it down in the layout. So detailed floor plan. So here we have this particular page. So I want to create a viewport. So to create a viewport in a paper, the command is Viewports. Okay. So Viewports is the command for the model, but here if I want to create the viewport, MV is the command. So in the MV command is a multi-viewport. So I want to create a viewport in the paper so that I can arrange my model space and get the print of it. Now there are these different options of it, like specify corner of the viewport, on, off, fit, shade plot, lock new, named, and other options. So let's say if I want to go with the corner, let's say if I'm selecting that, the plan will come at this particular size of the viewport. So now the viewport is done. So I can basically resize the viewport. I can select them. I can reduce the size. Let's say if I want to only get the plan in this particular, press escape, in the particular viewport. Now if I go to the MS, I can zoom it, and if I want to change the size of the viewport, I can scale them, and I can go inside and zoom it. Similarly, and the other thing is that if you want to provide a scale factor of this particular view in the page, so there is a scale factor that is coming over here. So if you say scale to fit, that means the entire drawing will be fit, but the moment you zoom it, you find that the scale factor is coming over here. It says 0.07816. So I can try with scales like 1:50, or I can try with the scale like, for example, whichever fits well, 1:20. So I have to go in the lower scale. So this is the scale of the viewport that the drawing objects will be having while we are printing it. So 1:100 is the scale. So if I make the scale as 1:100, so I go to the paper space, I increase the, let's say, viewport size so that I fit, and here in the paper space, models page, when I go and I pan the model, I use the pan command in the model and just pan it to the point key. It is visible. So now this viewport is now ready to create the plan, and this particular view is at a scale. If you go to model space, at a scale of 1%. This is 1:100. So this is how you can scale. So if you print it now in an A4 size paper, this particular model will be printed in 1:100. Similarly, if you want to create more viewports, so if you go with the MV command, so here you have corner point. So let's say if I want to create the elevation over here in this particular viewport, I go to MV, and then I go to the MS command, and I bring the elevation here. Now here again I have to check the scale factor. For example, it is 0.01403. So let's me check with 1:200. So 1:200 is fine. So now I will pan it. I'm not going to zoom more because it will. So when I go inside the model space, I'm not going to zoom it, but I'm going to pan it so that I can adjust the entire elevation in the paper. So now go to the paper space. Now you can move this viewport so that you can adjust this particular view so that it comes. So remember, once the scale is set, you should not basically zoom the drawing because it will affect the scale. Now look into it. If I zoom the drawing, the scale is getting affected. So right now if I want to fix it in the 1:200, right? So I only can use the pan option, or I can lock the viewport so that, so there is an option of locking the viewport, where I lock the viewport, I make it on and select this viewport, so that further if I go to model space, I cannot zoom in and zoom out. The scale is locked. Similarly, I want to lock this viewport. I go to MV command. I go for lock option. Select the option as on. I want to lock it. Select the viewport, and the viewport is locked. So now these two viewports are locked for scaling or zooming, right? So if you want to delete them, you can always go to paper space. You can delete them. So you can select it, erase it, you can delete them. Now let's say if there are certain other options in MV, is we talked about on, off, lock. We talked about lock. Let's say if I want to make the objects inside the viewport off, I don't want to make it visible. So if I put it off, all the objects inside the viewport will be off. So if I say on, the objects inside the viewport will become on. Now remember, this is a locked viewport. Okay. Now next is basically going to the MV and using this option called polygonal object named and new. Okay. That would be something that we are going to use. So let's say if I have a circle, I create a circle in this particular phase, and I want to create this as a viewport. So I will go with an object option, select this circle, and you will find that this particular circle is converted into a viewport. Now if you say MS model space, so you go inside, and let's say if you want to show some detail over here, let's say, so you can use, and then you can use the scale from here. Let's say if you want to use a scale of 1:20 or somewhat, or 1:40 would be the scale, would be better. So you can all, or 1:50, I think is more better. So this is something that you can use. Now in this paper, you can see that you have got two different scales. One is 1:100 and 1:50. So this is how you create multiple viewports inside a layout. Now let's come to the detail plan here, because here I will create some viewport. So let's say I create a rectangle over here, or create a polygon and a polyline, and I want to create this as a viewport. That's great. So I go to MV, and then I have an option of object. I select this object, and now this object is not turning into a viewport because the object should be closed. So let me see if the object can be closed. So I have this object which is closed. I go to the MV option, go for the object option, and now you can see the object is. Now if you want to go inside the model space, so now if you have MS, you can go inside and check it for what type of object that you want to give. Similarly, in the MV command, there is an option called named option. So here in the named option, if you click in the named option, this will help you in order to insert the view name that you have created. Remember, we have created a view name called elevation. Now if I say elevation over here, so let me go to the MV command. So the named, if I say the named view, so here I can basically insert a named view into my viewport. So here the named view is elevation. For example, we have created a view called elevation, and then specify location to view. So I click it and I put my elevation over here. This is how I can insert a named view. So you can see that here we have in the view manager, we have already have the elevation view and the plan view. Now similarly, if I want to insert the plan view into my site, into the layout, so I go to the MV command, and I have this named view, and I can say the plan, and I can have the plan view over here. So this is how I basically insert different views that I have created in my project. Now after the named view, there is an option called new view. Now this is a very interesting option. So if, let's say, if you select this new view, it will take you to the model space, and it will give you an option to select the view that you want to have in the viewport. For example, if you click on it, it will basically select the viewport, create the viewport for you, and the view will be there inside it, and press enter, and then you will be able to bring it into your canvas, that is in your paper. So this is the MV view has with the name view. And the polygonal view is, you can create a polygonal shape kind of feature, and then you can basically insert your view. So go to the model space, and then you can increase it. So this is how you can basically use the MV command. And then the fit option is the primitive one. I mean, it basically, if you erase all the viewport, and if you say MV and fit, so it will fit the entire model space into the layout. That means the viewport will be fit into the entire paper space. So this is the fit option. And apart from that, there is more options that we will be discussing in the MV to finish the concept of MV, and then come to the layout portion. So we go to the MV, and then we have this option called 2, 3, 4. So if you want 4 viewports, you can always click on it, and now you can see that all the 4 viewports are there, and you can create different views and scales inside the views for the page setup. And then let's say we have 2, 3, 4 and the layer option. So reset viewport layer properties. So I would say yes. Now other thing that you can see here when we are talking about layers, so it's very interesting. So now let's say if you have got 4 viewports over here. Now here in the layer you can see that there is something called viewport line weight, viewport transparency, and other options are there. So now here you can see that VP color, VP line weight, VP transparency, and different options. Let's check some objects. Let's say we have this wall layer. The name of the layer is the A wall. Now let's say if I go to the layer and into the wall layer option, and I say that the VP layer is blue. So what will happen? The color of the wall in this particular viewport will change. Similarly, if I want to have the color of the wall in this viewport to be different, so I would go to the layer option and then I would say VP layer as, let's say green. So here the wall color will be different. That means in the viewport you can have different kind of permutation combination of the colors, line type and line weight, which will not affect the model space. So let me explain you. If I would have changed the color in the normal color, let's say I'm not taking the viewport color, so what will happen? It will, so if I change the color over here, the entire wall layer will change, color of the wall object will change in the entire sheet. But here I am interested to only specify different colors and line weight at a particular viewport. So it gives you a liberty to, if you go to the layer now, if you say, so it will happen like this. Select the viewport that you want to make it current, go to the layer and then change whatever you want. Let's say you want at the viewport color of the window to be red, so you can change it. Similarly, you can have line weight, transparency, and other thing. So there is an option called VP transparency, so you can also increase the transparency of that particular line, so it will become transparent. So let's say window object, so I change the transparency to 40, so it's changed. So now the window layer, a window layer, the color would be 20 and the transparency is 40. Now you can see it has been affected over here. So just zoom in and see that windows are very light. So because this has affected at this particular, now you can see how the windows are light. Now if you look into the, go to the layer and change the transparency, let's say to 0. Not the layer transparency, but the VP transparency, the viewport, the object inside the viewport. So you can see that some changes will be happening. So now it is of a different color. So let me give it a try with a different color. It's a blue, so that it can be distinguishable. So this is how basically the layer are controlled for particular viewport. So again, let's say if you want to put the particular layer off or on, so you can freeze, not on and off, but you can freeze a particular layer at a particular viewport. For example, if I want to freeze the wall layer at a particular viewport that I have selected, so it will not affect the other layer. For example, look at this here. I have frozen the wall layer for this particular viewport, but wall objects are being seen in the other viewport. So this is what the concept of viewport isolation works. That means every viewport will be controlled by different properties of a layer color, layer line weight, layer line type, as well as the layer control visibility. and of different scales. For example, this particular viewport is having a particular scale. You can set it into 1:100. In this viewport, you can set it into, let's say, 1:30. You can have different viewports with different kind of scales. So this is something that when you're working on a project, so this particular type of situation will come and forth. So this is what about the MV command I like to say. Next, I will be taking a project in which I would be telling you how to set the sheet, and then we will be moving towards plotting. So now we would be also learning about the controlling the layers in Viewport using the Layer Properties Manager dialog box. Now let's see how basically we can control the layers in the viewport. For this, I'll just go with the AutoCAD drawing. So here I have this AutoCAD drawing, and first thing that I will do is I want to create a plan. I want to make this create a layout with this plan in the layout. So for that, I would go with the new layout option. So layout 3 I have opened. Now there is a viewport over there, so I've just erased this viewport. First of all, in this layout, I would like to first set the page setup of the sheet. Now for that, click right on the layout. The first thing that I should do is rename it and name it as floor plan. Okay, so now the name of the layer is floor plan. Now next is page setup manager. So here create a new page setup manager. Let's say floor plan 1. So here in the page setup manager, take the printer that you want to have. For this, I will take dwg2 pdf.pc3 file, and the paper size that I would be looking for is now is the ISO A3 paper size. So A3 would be 420 into 297. Now you can see it over here, and other properties you can see over here. The DPI's quality you can set from the PDF option because of the pdf.pc3 option. The paper size is set. Next, I would so the plot area is layout here, and everything is done according to it, and drawing orientation is landscape. Now because we are using the layout, so the scale would be 1:1 of the layout, but the viewport scaling will change. So we will be talking about that. Then we will be doing the option that we have discussed. So here we want to plot the line weight. That's fine. Or if you plot the line object weight, the object line weight, so when you print it, so at that moment of time, the line weight will be displayed in the paper sheet, that is the A3 sheet. Press OK. So now you have this floor plan 1 set current, and now you can see the size of the paper had increased. So let's measure the size. So here what you can rename it and write the paper size also. Let's say A3 dash name of the sheet, the layout is A3 dash floor plan. So let us do a distance command and check what is the size of it. Okay, it's 416 and 279. So let's go to the page setup and see the size. Go to modify and see it is 420 297. That's fine. So we have an A3 landscape paper set over here, and now we have to draw the viewport. You say it's a VP command, Viewports, MV command in fact. So here we have so I take this particular part for the plan over here. So here if I take this as the MV, as the multiple viewport, so I have this particular plan over here. Now what I can do, other things that I would recommend for the viewport, let's say go to the model and save the views that you want to see. For example, this is a view that I want to see. So here I go to the view, so I type V and create a new view and say plan over here. Let's say, and then current display view category, you can have none and say OK. So set current and OK. So now what you can do is the view command will enable you to get that view inside the model space. So you have the paper space. The symbol of the paper space is this. If you want to go inside the viewport and set the view, you have to type model space command and then go for the view to view command and say the plan. And so now here you can see that there are certain objects that are not required. For example, if this is an object, zero layer object, you don't want them to be there in your screen. So what you can do is, if you now go to the layer manager, so the layer that you don't want to be there in the layout, especially in the viewport, so that layer you can basically switch off. So we have got separate options for VP color, VP line weight, and there are other things that you can do. Like where the VP is given, that means we can control the properties of the layer in the viewport, not in the entire drawing. So if I say VP freeze, that means a zero layer, whatever object is there in the zero layer will be frozen. That means you cannot see those objects in the AutoCAD viewport, in the layout viewport. Now, what happened actually that some of the objects that were in the zero layer also is off. So what I need to do is I have to first of all assign those objects out of the zero layer and to the particular layer, so that the unwanted objects get out and the text and other things remain in their own layer that is defined. For example, now let's say if I go with the, I put it on. So let me see. So what I will do is the layers that I don't want, I will put them into a different, or what I can do, I can match. For example, if this is a object, I will put it into the dimension layers, and I would definitely go and match the properties. So this is how we do it. So you can do it yourself, but for the time being, let's say, so here you can see that when we have this layer manager and I say VP freeze, that means the objects in the zero layer is not seen in this particular viewport. But it does not mean that the object is frozen in all the scene. It is there. So if you look into the model space, the object is visible, but only in this viewport, the object is not visible. Let us take another example. So let's say if I create another viewport for elevations. So let me keep a size for the elevation. So similar thing I will do. First of all, I'll go to the model. I'll create a particular view for it. So I go for the view command and V for view command. And here I will create a view name as elevation. So I go to the new, I create a view called elevation and press OK, set current. And then what I can do is now I can zoom out and zoom in. So you can see the elevation, the plan view and the elevation views all are set. So now in the layout, what you can do is set the view to elevation. So now once you set the view to elevation, so here what you want is, again, if I switch off the layers, now this object, this elevation is in the zero layer. So here I have frozen the zero layer, still it is visible over there. Now for example, so that means that the objects that you change in the viewport will not change in other viewports or in the drawing. It is only restricted to that particular viewport. And what are the other things that we can restrict to the viewport? The other things are, let's say, come to the paper space and let me zoom out and see. The other things are, let's say if I take MS, so we have got two viewports, 1 and 2. And if you go to the paper space, so now you can select this viewport and see their properties. So go to the properties. Now you can see this is a viewport and these are the properties. Then we'll be discussing about how we can change the properties of the viewport. For example, if I say display no, that means the object in the viewport will not be displayed. So yes. So then you have different options like scaling. So if you want to have a standard scale, so if you want to give a standard scale in the sheet. So 1 is to 100. You can provide it from here. So now let's say if I pan it and if I want to lock, so go to the model space and pan it. So if you want to, right, so now scale is not changed, but just I have moved it and come to the paper space again, select the viewport, and then what I need to do is I need to lock the viewport, so that now if I go to the model space, I cannot change the view scale. Now come to the paper space again. So once you select the viewport, some arrow, you can see the arrow heads are defined over here. So here, from here, this is basically, if you click on the arrow, the custom scale. So you can change the scale. Say if you want to 1 is to 50, the viewport will change according to 1 is to 50. Similarly, if you need some other scales, just click into it, 1 is to 40. So this is something that the scale of the viewport will change as per the grips over here. So you can do it now. You can see the standard scale is 1 is to 100. If I lock the viewport, I can change the scale from here. Let's say 1 is to 20 I want to make. So you can see the annotation scale as well as the standard scale changes. So this is what exactly is the viewport properties. Now coming back to the discussion. Now go to the model space or go to the layer manager. So here the viewport that is selected is the upper one, the plan viewport. So here what you will see that if I let's say wall, there is a layer called wall, and if I want to give a different color in that particular viewport, for example, instead of color 10 I want to have the color let's say blue. So what will happen, only for this viewport, color of the wall will change, the layer wall will change. And so you can also give different properties in the viewport. So what are the other things that you can do? Go to the layer manager and see, you can give different color, you can give different line weight, also you can have different transparencies of the object, and then you can basically give the description. So these are the options that you can do. Okay, so apart from that, so this is the properties. Now if you want to write something in the sheet, come to the paper space. Now this is my sheet where I am going to take the presentation. So if I want to write something here, let's say I want to write the elevation over here, so I have to abide by the text in the sheet, not inside the model. So let's say if I want to write something, so let's say, now let's see what would be the size of the text. Let's create a rectangle from where I want to write the text. Let's say I create a rectangle. So let's say this is the size in which the box in which I want to write. Check the distance. So here the rectangle would be somewhat right, let's say 14. So I write a text with the dtext command, keep the base over here, let's say, and let's say height I keep it as 10. So rotation. So here I can write like elevation. So this text is basically the text that is written in the sheet, not for the model. So in the presentation, while you're doing presentations, while you're preparing the sheets, this is a normal process where you write certain text in the sheets itself. So if you want to change the style, select so go to the style option and see the text, and then you can change the style. Let's say I'm giving something called, right, so this is the text style is here, is Arial 1. So go to the style in the Arial 1. I want to give something different. I want to give this sans. Let me take a, normally I use this style, so sans serif. Sans serif is a good okay, so close. Right. So you can also decrease the scale, let's say size. Let's say the height is right now can be changed, it's 10. You can have the height of 5 units, and you can write this is the, so here you can have the elevation right up at the bottom. You can copy it and have it over here, You can also select the viewport and reduce the size so that enough clutters can be removed. So you are clipping it. So just preparing the viewport for the presentation. So here you have, the elevation, and now you want to set the scale of this elevation. So select it, and here you see the scale is, let's say 1:100 you want to set, so it is set to 1:100. So you can write here, so you can edit the text by ed command and just copy it at the bottom, and let's say you can write scale dash 1:100. So similarly you can have like for example, if you want to go here and do it for the plan, so you can give, let's say, floor plan and whatever the scale it is. So you have got two viewports. If you want to switch off the view, you don't want the frame to be displayed in the viewport, so it is always referred that put the layer off in which the viewport is. So for example, for the viewport is in a particular layer, so it is in the layer 0, so I would suggest that you should go with a layer called the Viewports. And here what you do is, all the viewports that you have, the frame in fact, you can always have them in that particular layer, let's say the viewports layer, and put them off, so that turn the current layer off. Okay, so now keep the current layer on. So let me put it into the viewport layer, and so let me select it and keep it in the viewport layer, and now change the viewport layer to put it off. So now you can see that the frame is not displayed. Similarly, you can select it and give it to a different layer. So this is how you can make the display of the viewport invisible. So similarly, if you want to have some tables or schedule over here, so we'll be doing table in this session. So you can always put the table over here from the drawing file. And so in the later session, in this session itself, I'll be talking about how you can draw a table and put it over here. Apart from that, you can create the template of yours. So the template will be created in blocks, and specifically, and the values would be written in the attributes and in text format. Similarly, there are certain notes that you should write in the drawing, so notes will come over here. Then a lot of things that you can do. So each and everything that you do for the sheet will be written in the sheet. For example, if you want to write the notes, so you can write the notes right over here. Let's say it will come over here, so you can write the notes over here, right? So whatever notes you want to do, jotted by point to point, right? And then it would be in the sheet itself. So you can have the size, let's say you can reduce the size, and so this is how you can basically increase the number of information that will go with the sheet. So you can put some notes over here. So like for example, when we write the notes, you can have the notes like this. For example, all the notes from the consultant or the contractor or the engineer will be coming over here in the drawing. So you can have the general notes. General notes are basically the comments that comes from the designer, whether they are electrical designer or a HVAC consultant or a structural engineer. So these notes comes in the sheet, so you can provide them here as general notes, and it will come sheet to sheet actually. So this is the text that you provide. Apart from that, so we can provide the schedules like the door window schedule or the opening schedules or the wall schedule. So a lot of things comes in the drawing itself. So here basically some of the text or annotations you can keep it in the sheet, and most of the drawings would be there in the model space. Now let's pick up some more models. Let's say if I want to have the detail of the staircase, for example. So here what I can do is I can go to the view, and let's say I can say that I want to create a staircase view, staircase. So in a particular plan you should have a lot of views there, because in the sheets when you are referring them, right, so you have that particular view in place. So now let's say I want to put the staircase detail over here. So I come up with MB option and take a square, let's say, or take the detail view. Let's say I take it here and go to the view option, and let's say I go with the staircase. So here what I need to do, I go to the MS model space first, and then I have to select the view, because if I don't go to the model space, the view cannot be there. So this is so come to the paper space, uh, and come to the model space, zoom to the view of the staircase. Now here you can see that this particular staircase is detailed over here. So what you can do is you can always stretch it and you can reduce the viewport to the point that you want the sizes to be taken care of. So this is the staircase detail. So you can always have the dimensions are annotative, the texts are annotative, and then you can put this viewport. You can lock. So there is a scale over here. So now the scale is 1:1. So you can have the custom scale here saying 1:1, or so now you can see when we say 1:1. So there is a scale that we need to work into it. So there is a scale that would be there. So here we have this particular scale. So 1:1 may not be the scale that we are looking forward for. So you can always go and lock this viewport first. Then we can see what scale we would like to go for. So right now it's a 0.01934 is the scale. So you can have the nearest scale. So you to get the nearest scale, you can use the calculator over here in the viewport properties. So here, let's say if I want to see what is the scale, so here I can clear it, this one clutter, MC. So I want to have the calculation as 0.0149 divided by, let's say, so I would be going rather than 1 divided by 0.0149. So this is where I get the scale. So press enter. Nearest scale is 1:67. So probably I need to have a scale. Let's say 1:50 would be the good one. So here I can select the custom scale here as 1:50. So the block changes to 1:50. So then I can here go and give it a viewport. Let's say put it off. So it says, so this is how the detail in the sheets come into play. So one thing is that about the templates and the attributes that we need to do. I will be talking about how the drawing name and the architect's name can be put in the template option. But here this is what the layout. And then if you want to get the page setup manager, you can see. So you have this page setup and close. Now if you want to plot this over here, now continue, and here you have this you can select the page setup over here. So this is the sheets that you want to go. You can see the preview. So here you can scale the line weight. This scale is the plot scale for the layout, so don't worry about it. So now when you print it, you can see the line weights are also scaled, and they are seen properly in the sheet. So now if you want to plot it in the PDF, you can directly go for plot and save it in your student folder that you have would be working into it. So I say floor plan PDF. So the first PDF that you will save is for this particular plan. Similarly, you can have more of the sheets, like you can have sheets for so now you can see that how the sheets is plotted. So this is something that you should do it for your drawings and get number of sheets out of the project for the model space. So what we have understood is layout and sheets are basically output for documentation. In model you have all the drawings that has to be there. Now let's take an example, and we will do an example from an existing drawing set. So I have this exterior elevation drawings, and I want to create 4 different layouts for the different elevation details that has been shown over here. And this is in feet and inches. So this is in the model space. So in the layout I would go for a new layout, and let's say here I rename it as elevation 1, and in the page setup, so here we need to have so click first the elevation 1, and then you have the page setup manager. So the name is so you need to create one page setup, let's say elevation, and here we have the paper sizes. I would like to go with PC3 level 2 PC3, and okay, so it says so I would go with the PDF DWG to PDF, and here I would like to have paper sizes at feet and inches. So I would like to go with ANSI ABC. So because ISOs are in millimeters, so ANSI standards, that is so you have this ANSI A is the equivalent to ISO A4. So you have this ANSI A, and then we have this ANSI B. So let me go to the ANSI B first. So we have taken the ANSI B, that is equivalent to ISO A3. So we are taking the size as the orientation as landscape, and the layout, what to plot is layout, and scale, line weight, and other things. So other thing that is to be taken, that there is a plot style pen assignment. So pen assignments are very similar to like assigning certain rule to the print. For example, there are pen assignment like monochrome, screening. So for example, the monochrome CTB is a color dependent plot style. So plot styles are basically style that controls the display of the lines while printing. So if I say I go with the monochrome.ctb, that means if I see the preview, all the drawings will be displayed in one single color. So let's take it down. So here I go with, so let me first of all set the paper size and delete the viewport, and then we will be going for the plot style later on. So let me measure the paper. So it's here, it says go with the distance command. So if you measure it, so it is approximately 10 inches, and here I have 8 inches. So if I want to change the go to the page setup manager and see the size, it says letter at this moment. So I need to see that the settings that I have made has to be implemented. So page setup is elevation 1, and let's say I would go with the layout option. So I'm changing the page setup and CB over here again. So this is 11 by 17 inch. So 11 by 17 is the, so this is the 11 by 17 was portrait. So 17 by 11 inches is the landscape. So we want to take a plot style, let's say monochrome, and we don't want to plot the object line weight at this moment, and scale the line weight and press OK. So now you can see that the page is scaled. So here at this moment, if you check the distances, it would be somewhat around 1 feet 4 inches, approximately around 18 inches, and 10 feet 1/4 inches. So this is the ANSI B paper size. Now what you can do is go to the MV command and place the elevation that you want to, the viewport. Now if you look into it, the views are coming in black and white. The reason is, in the page setup manager, we have set the plot style to monochrome. So let me put it off and close it. So okay, page setup manager, and change it to elevation 1. Okay, and modify and don't display the plot style. Now okay, so now do the MV again and see that how it looks like. So now the color is coming because the monochrome has been removed and we have removed the viewport. And here I will go with the model space and see the amount of elevation width that I need to be displayed. So let this is be the size, and change the viewport size. Let's say I'm changing it to this part so that we can have more objects over here. And here what I can do is, if I want to print in black and white at this moment, I can always take the pen assignment, go to the page setup manager and say that the plot style is monochrome, or if you say grayscale, so you can see the preview, it would be all gray. So you can always control the color, line type, line weight using the plot styles. Okay, so the page setup manager will not only control the page setup but also the scales and the plot styles and other thing. So now you have this particular you can move this particular viewport, and you want to have a scale to the viewport. Now if you look into it, again you can display the viewport, or yeah, lock it, and then you can go for the scale that you want. So if you want a scale, now in feet inches the scale is different from the matrix. So we have 1 inch is 1 feet and so on. So you can try with the different scales if you are sure about it. 3/4 inch is 1 feet, or you can go with, let's say, 1/8 inch 1 feet. So you can 1/8 feet 1 inch means this actual the custom scale is 1:96, because 1 feet is 12 inches, so it is 1:96 inches. So you can go to the lower scale. 3/32 inches is 1 feet, so you can do change in the custom. You can do 1 feet is 12 inches, 12 into 32 divided by 3, so that would be the 1:2 scale. So here I can see that 332 inch 1 feet is the scale that has been set for this particular elevation further. And you can see that here the scale is also set, the annotation scale is also set over here. So primarily if you want to again hide the viewport, so here mainly what we were discussing about, we want to create a layer, viewports layer. So I have this viewports layer, and specifically I want to put it off so that the viewports should not be displayed while I am printing it. So this is off. So this is how we do start working on a sheet. So you have an elevation 1, and then what you can do, you can have the elevation 2, and now you can take a template. For example, you want to take a template that is already created by your company or you created, and it having an ISO A1 size. So here I have taken the template of the matrix. So I want to delete this. I want to take an imperial template because the page sizes should be in feet inches, in imperial. So because I am working on a feet inches, so I take an I arc, means imperial arc. So here you can see the D size layout. So the smallest size. So Here you can see that viewport is already there. So you go to the MS set. Now the viewport is locked. So in order to unlock the viewport, select the viewport already that is there, and see there is already a layer that has been made in the template as viewports. And what you can do is once you select this, you can say no and go to the MS and just see the scale that you want to allow this particular viewport to have for the drawing. So once you set the scale, the drawing is set, and again you can go to the page setup manager and set the name of the page setup is D-size, so you can go and modify it. And the plot style, you can keep it as monochrome or any other plot style that you want to have. And then the moment you plot it, you can see the preview of it. So what to plot, I would say the layout, in fact, and different options. The monochrome CTB is there, and the page printer should be pdf.pc3, and it is a landscape option. Now you can see that the drawing is printed in black and white. Now apart from that, you can see that there is a part in the template where we talk about the other things like the notes and other things. So before printing it, you can fill the sheet. So now this is a block in the template. This is already created by somebody as a block. So, and the text inside the block, you can see if you do a edit command, block edit. So if you select it, so if you want to edit it, double click it, double click on the block. So the block will be edited. So here we have the attributes also. Now you can see that there is an attribute here. So if I do a edit option, so here you having the title block, so block editor will open over here. Now you can see that in the block editor, the template is drawn as a block, and there are certain things like, for example, certain objects are created in text. So if you do an edit text, you will find that some are attributes. So if you see the properties of it, some are attributes and some are texts. So in the attribute, there are certain text which are attributes that can be edited. So there you can see there is a file name and ref date. So how do we do? So just wanted to make sure about that you understand the template, what is the composition of the template. So if you want to change something, you can go to the block editor and you can add more text over here. So to edit the attribute, you go for at edit. If you select it, you can see that the file name is, let's say, 012020, and the author, I can have Skill-Lync over here, and revision date 101. Now once you do this, you see that there's a change over here because these are attributes, but these texts are basically normal text. So here you have to go with the normal text command, and let's say if you want to have the firm name, give a size, let's say 1 feet 6 inches is the biggest size, but we have to see that what size I want to give to the text in the paper space. So let's say create a rectangle for the text to see what is the height that you want to give it to it. So let's say if I measure the distance over here, I can see that it is around ½ inches. So I go with the text option. I start it from here and I give the size as ½ inches, and write the text as Skill-Lync. So ½ inches is also a bigger one. So here I would suggest that, what we need to do is there is in the properties of the text, you can always go for a fit option. So in the justification option, I would always go for a fit option. So in the fit options, I can basically narrow it, or if I go with the align option, what will happen is the size of the text will change. So if I take the justification as align, so what will happen is once I reduce the length of the text, so the height will also decrease. So I have this firm name and address. So here similarly I will fill up all the text over here. Let's say I have general notes, the notes that I had written previously can be come over here, in the text format. So you will be writing all these notes like with the mtext command or the text command, whatever the general notes that comes with the drawing, 1, 2, 3, and make sure the font and the text that you're using are standard forms and texts, and the sizes are also very important, that is visible in the sheet. So this is how you basically create a sheet out of the drawing. So you can do different kind of, let's say if this is, now you want to have the elevation, so elevation, you want to put this elevation in the sheet, let's say this one. So you can always have this different types of elevation. Now so you have elevation 1 and then you have elevation 2. But once you are done with the scale and once you are done with the view, so it's very important that you go to the paper space, select the viewport that you want to and lock it. Don't put it unlock, so that the scale should not be altered. So this is all about the layout, and a small part of it I would connect at the end of this session, like the table, getting the table inside the layout. Let's move to the next part. Now another very important part, switching from this exterior elevation, I want to take it down to this floor plan to have a very important part. Let's say if in the model space, if we go into this specifically in this staircase detail, so if I know this height of a text, for example, in the particular text height is there, so you can go to the model space and you can check what is the text height. So probably you will find that the text height would be somewhat, so I just put the snap off. So if the text height is somewhat around 374, so if I want to have the similar size of text in the paper space, but 374, because the size of the paper is lesser, so it is 400. So I want to have the same size of the text written in the paper and converted to the scale that is there in the viewport. For example, this viewport is having a scale of 1:50. So if there is a text which is of a size of 400, so obviously it will be scaled down and it will be visible as 400 divided by 50, that is 8. So let's say if I write a text and I want the size equivalent to paper space, the size of the text in model space equivalent to that of the paper space in that particular viewport. Now if I want to see the size, same size that is written over here as 1000, so I start. So here there is a command, transparent command called space trans. So what it is doing is, so it is asking for the viewport. So this is the viewport. The moment I click into it, it basically takes the scale factor that is assigned to the viewport. So now if I have the model space distance, now the model space equivalent is 400, let's say, equivalent to this size of the text. Now if I write something over here in the paper space, not in the model space, so I would see that this size is now converted into the paper space equivalent. If you can see the height, it is 8. So 8 means that the CAD has basically multiplied the text height that we had given into the scale factor. Now let's take another example over here. So let's say if I want to have a text over here equivalent to the size of the text in the model space. For example, let's say if I want to have the size of the text equivalent to this staircase, this is around, so if I want to go to the model space, just check what is the size of this particular line. So it is 138. Now here let us take an example. Now if I go with the dtext command, and let's say if I give start point over here, and in the height, I don't know what height I want to take, but I want to have the height equivalent to this particular riser. So I say here I want to translate the space. So that means in this particular viewport, let's say the model space distance is, the height means is, let's say 200. Now what it will do is, once I write it, it will basically convert, multiplying with the scale factor, let's say 1:100. So whatever size I give, so it will convert into it. So now let's say rotation angle of the text is 0. So now if we write something over here, let's say, so now if you check the size over here, it has now converted. It is now, the height has become 2. So this is what I wanted to tell you about when you are writing something in the paper space, the space transparent command, because it will not work in model space, it will work in the paper space. So before coming to the next topic for the multi-line that I want to discuss with you, there are certain times that we don't create layouts, but we want to take a plot. For that, you can directly go to the application menu. Then you have this option called print, and then you can have the page setup first, and then you can go for the plot preview, and then you can plot it. So setting the page setup in the model page. Now here you can create a new page setup or go with the modify. So select the print. Let's say you want a JPG at this moment, and select the paper size in which you want to print. So if it is a metric, then you can take an ISO size. So I take an ISO A4, and here there are 3 options. In fact, the display option means if you see the preview, the object that is displayed on the screen will be printed. If you go with the extent, means all the objects, whether it is in the screen or outside the screen, will be displayed. Limits means all objects which are in the upper and the lower limits, that is being set by the limits command, will be displayed. Have particular view. Let's, for example, you have done with the view. So if I want to print the plan view, you can see the preview. And then there are options. There is an option called window. So generally we use, let's say I want to only print this particular area. I can see that there is a scale that the AutoCAD has set after I select the window. I can do the center of plot so that the print comes in the center of the plot. Then I can set the custom scale from here. So I can have the nearest scale is 1:100. So I can see the preview over here. And then I can go with the pen assignment. So if I want a monochrome, I can go with the monochrome. So if I want to go with the any other, let's say string 75, what will happen? It will light the pen. It will light shaded print will be taken out. And then if you want to plot the line weight, if you want to take in portrait, plot with line style and plot transparency. If the transparency is there, it will be plotted. So this is how you take a print from the model space. So there are situations when you take a print from the model space, but it is always recommended that you should use a layout for it. So you can now go and plot it. So you, right, after continue to plot on a single, so you can see the preview that has been created, and then there are certain warning message that you can, and then you can save this PDF file and then view it. So this is how you can take a print of from the model space. So now coming back to the topic of the multi-line, the next topic is the multi-line. So I'll be quickly taking multi-lines and the other topics one by one, so that I finish up the session 10, that is the 2D session, and then we'll be going with the 3D sessions. So multi-line is basically style by which we create lines more than one line. Like for example, with the line command, we only go with the single line, but multi-line is like pipelines or the walls. If you want to do with some kind of utilities, so multi-lines are preferred. So let's see what multi-lines are. Then we will be going with grouping and polyline. So we'll finish it off doing all these topics. So now let's say over here I want to create a multi-line. So if I go with the multi-line, so it's just like a line. Now you start like a line. Now this, you can see the distance is very less over here, because so you can create more than one line by a click. It works like a line command. Like for example, if you go with ML, so start point, and you can go with different commands, and then you have this but you need to set the style for it. So for before you start with multi-line, you go with the multi-line style. So ml style is the command, and you want to have a 9-inch wall as the multi-line. Say wall 9-inch. Give you an example. So continue. So here you have the description. You can say wall 9 inches. Now this is the you can have the capping at the start, and you can see how it works. And this is the distance. So you have two lines, and in the 0 there is no line. So above the 0 this is 0.5, below the 0 is minus 0.5. So the width of the multi-line is 1 unit. So let's say if you want to have this as 4.5, it's a 9 inches wall, and this as minus 4.5. So overall you have a 9-inch wall. So if you select this, you can have a fill color. Let's say you want to give a yellow color, and the color of the line you want to put it red. Similarly, you want to give the color of the line as red, and you want to add a 0 element over here. So put it over here, give the color as magenta, and the line type as hidden. So now you have 3 lines. The center line is moving in the magenta color, the upper line red, and different line types are there. Continuous line types are there. So you can put a cap at the start and the end. So now you have this wall 9. You can see the preview over here and say okay. So now if you do a multi-line, so you have the current setting, style is standard. So if you want to change the style to what you have created, so go to the ML style and select it and make it current. So the moment you make it current, and if you go for a multi-line, you can see the style is 9 inches. Now if you click, now you find that the multi-lines are created, and all the 3 lines with the fill is displayed over here. So let's say if you want to create more multi-lines, so there is an option called scale. So here what you can do is you can increase the scale. So top scale is 200. So the scale is basically, so if you look into the distance, it is not 9, it is 9 into 20, that is approximately 180. So because the 9 inches wall, we are working in millimeters, so the wall thickness should be around 230, 115 up, 115 down, but I have taken 9 to show you the scale factor. Now let's say if I use the multi-line scale as, if you go for the multi-line and if you give the scale as, let's say 25.4, so here exactly what will happen, the 9-inch wall will be now converted into a 230 mm wall, because I have done the conversion factor and I have scaled it. So now this is a typical example. If you see that the 9-inch wall style that was created as a 9-inch is now converted into a 230 wall. Now if I want to have wall which is 115 mm, so I can basically scale it 12.75, that is half of 25.4. So let's say if I do a multi-line and if I do a scale and if I say 12.75, that is half of 12.70. So press enter, and now you can see that if you create a line, this is a thinner line, that is 115 mm wall that you have created. So this is the way that you can do multi-lines. And apart from that, now if you want to see if there are more multi-lines, let's say multi-lines are crossing each other, there is basically you cannot trim this line, so you have this multi-line edit over here which gives you the join details that you can have. ML edit is the command. So let's say if you want to have a T section, so select this multi-line. First multi-line is this, second multi-line is this, so a T section can be created. Similarly, there are other multi-line edit tools you can try, like corner joints. So if you want to have a corner joint, so select the corner joint close, and so select this one and select this line. Now you can see there's a gap over here because of the joinery details. This is what the multi-line is all about. So you can use this multi-line, for example, pipes or firefighting, or for any kind of utilities or flow networks that you want to develop. You can use the multi-line. The next option that is to be discussed is, after the multi-line, is the revision cloud. So the revision cloud that you can create, we have already discussed it, is for the markup. So you can get it in the annotate tab, markup panel, revision cloud, or you can basically, let's say if I want to create a revision cloud for the revision, so I can give a command called ref cloud. So in this ref cloud, I have got different options, like for example, if I want to have a rectangular revision cloud, so I can always go for a rectangular revision cloud. Or if I want to go for so now I had given a rectangular cloud, but there is the arc over here, so I have to increase the arc length. Let's say a minimum arc length that I want to give it as 100. Now if I now maximum length of the arc, let's say 200, so I keep a minimum maximum. Now I create a rectangular arc, so I can see a bigger ref cloud is created. So if I want to have the ref cloud as a circle, let's say, so I create a circle. So if I have an object like a circle over here, I want to show it in the ref cloud, I can convert this circular object into a ref cloud by selecting this circle. So say no. So this is how you do the revision cloud. Okay. The next option that is to be discussed is about the spline object, and then we'll be doing the object grouping and editing polylines. So just I want to talk about splines are smooth polylines that so you can have command spline is a smooth polyline. So this is you can try with this. So if you want to have some polynomial curves and which are not arc, you can always have a spline. If you select them, they come up with grips. You can always change the grips that you can do. So this is how the splines can be controlled. And spline edit, you can try with the, you can go with the spline edit, where you can select a spline, smooth polyline, and you can convert them into a polyline. You can fit the data, for example, or you can always you can do a close option, you can do an open option, you can change the tangency of any curve. So there are a lot of options that you can do with the spline edit command. Okay, then another thing that I wanted to discuss about the command called purge. So the purge command is used where basically to lighten the file. So let's say if there are certain layers that we are not using, you can purge them. So purge, do you okay, so it says that there's a layer which is not used. So not only layers, so you can select, let's say, what are the things that you can purge. View items you can purge. So the items that you would be purging is, let's say, the blocks can be purged. So there are certain blocks which are not used, dimension styles which are not used. So purging is basically if you say purge, so you can purge means remove the unwanted element. So the moment, every time if you do purging, purge all items means which, if there is a dimension style which is not used or a layer which is not used, will be purged and removed, and your drawing will be lightened. For example, I'm giving you an example. Let's say if I use a text style, so I use a text style and I create a text style and name it as, let's say, custom 1. So but I did not use it in my drawing. So the moment I do purge and I go with this let's say the text styles over here, so I can always have a purge all option. And now if you look into the style option, you would find because it is current, so I have to make this as current, so I have to make it purge. So you can see that the moment I do the purge, there is this textile will be displayed, and then you select this textile and you purge it. Now the moment you purge it, the textile is removed from the style manager. Similarly, if you create a layer and if you don't use that layer, let's say there are certain layers that you have created but you haven't used it, so if you go for the purge option and then if you look into it, you have the layers option also. To select the layers which are not used, AutoCAD will show you that these are the layers that can be purged, and now if you look into it, the layers are lightened. So this is very important option. Then there is an if you have a polyline, so this polyline can be edited. So if you have a p-edit command, you select a polyline. Now there are a lot of options, and one of the options that I want to discuss is the width option. So if I want to change the width of a polyline, let's say I want to change the width to 0.5, or let's say I want to make it 10 mm. So now you can see that uh, changing the size will change the width. So if I want to make it a significant width, let's say I want to make it 100. So this is how you can do. And then if you want to change it to spline, it can be changed to spline. And then if you want to edit the vertex, now let's say if you want to exit it and then you want to decurve it. So if you want to change the direction of it, let's say you can go with the edit vertex, and now in the edit vertex a lot of other options will be there. Suppose if you want to add a vertex, you can always add a vertex to this, and if you want to break them, you can break it from a point. So you can go next and see which vertex you want to edit. Let's say if you want to change the tangency, you want to have the tangency, let's say a bit steeper over here, so this is the tangent. So this will be affected. Now if you exit it, and if you, let's say if you do a fit option, you can see how the curve is changed with the tangency. So the edit polyline basically is used when you want to have curves and splines, and vertexes can be edited. Like for example, if you select this particular object, there are vertexes which are very important, which changes the tangency of the curve. So you can add n number of vertex. For example, if you do a p-edit option and select this, and you want to decurve it, so it is decurved. So if you want to edit the vertex, and if you want to insert more vertex to it, so you can click insert option and then insert a vertex over here. You want to insert a vertex over here at this point, and if you want to insert a vertex between these two vertex, you can move next, and you can select that I want to insert it over here. So go for the insert option and say that I want to insert it over here. So this is way you change the geometry of the polyline. So this is how you, these are some of the important options in the polyline that you should know. Now there are certain extra tools that can be used in AutoCAD, that is a group. So there's a difference between a block and a group. For example, if I want to group this particular, let's say I create a circle, and if I want to group this and call them in the drawing for selection or any other purpose. So this object is a, I want to not, I don't want to create a block, but I want to group them, and for selection purpose I want to select them. So for example, if I, so to create a group, let's say you have G. So here first thing is that you have to name the group. Let's say if I name the group as circles, give you an example of it. So circles is the name of the group, and then I, so G, name of the group N, and the name of the group is circle. So now and I give a description over here of this particular group, let's say group of circles. So then we will be seeing what is the difference between a block and a group later on. So here you have this select object option. So you select all this object and it becomes a group. Now this object is basically a single group, and the name of the object is circles. So if you want to erase this object, so if you write group over here and if you say circle, so this object will be selected and erased. So one of the most important part of the group is that groups are created to make the selection easier. Now if you select the group, if you right click, you will find that there are certain options. If you want to ungroup them, so you can ungroup it and the object is ungrouped. So press undo. So now if there is certain another object that the circle that you want to add it to the group, so you can go select the group, right click and go to add to group. So you can add these two circles and these two circles will now be a part of this group. Now if you want to erase them, they can be selected at once, or you can call them by name. Second is another thing, that if you want to remove certain objects from the group, you can always go to the right click option, selecting the group, remove from the group. I want to select all the 3 circles from the group, so this object is removed from the group. Now I'll give you a typical example from the drawing where I can use the group and where it is useful. But before that, I want to tell you about, so if you write group over here, there is an option called group edit. So in the group edit, if you select a group, you can do the same things that you did with the right click. You can remove an object, rename a group, and add object. For example, if you want to rename the group and enter a new name for the group, suppose if I want to name it as circles, so the group is renamed as circles. So if you go to the property of it, so you find that this is a group, and these are the properties of the group. So there is another option in the group, is if you, there's a classic mode over here, that which is called classic group, and here you can see the list of groups are displayed. So now you can see the description and other things, remove, add, rename. If you want to explode a group, the group is gone. So this is how the groups are created and they can be used. Now let's take an example from the drawing that I have. So let's say I want to group this particular set of objects into a window. So in the elevation, so I go for a group and I say I want to select the object, and I want to, now it is group, but there is no name to it. So if you want to rename the group, so if you want to see what name it has been given, so you have to go to the classic mode. So if you say group classic mode, classic group, in fact you will see that no name is there. But if you see this option over here, if you see include unnamed, the group has been named as A2. So you can change the name of the group from A2 to, it's a window. So over here, if you want to rename this, so change the name over here and say you want to name it as Windows, and so it is renamed, and it is done. So now if you select it, you find that you can easily, now other thing is that if you are copying a group, so every group is a unique entity. So copying a group basically will create more groups. For example, if I copy this group over here, this here and this here, so now if you look into it, this will be having a different name. System gives it a different name, it will not remain the same name that it was. So unlike block, if you would have created a block, it would have a single name and you can do other functions to it, but group is basically very unique to the object that you select. Now if you want to see what name has been given, again go to the classic mode of the group, that is a classic group option. So you see include unnamed, so bunch of names are there, A3, A4, A5, so you can rename that window 2, and let's say you write it as window 2, rename it, and it will be renamed. So this is how you basically create the groups and use it in a drawing. So at last there is one very important option that I wanted to talk about, is the divide and measure command that we did. So let's say if I have a circle, I created a circle, let's say of dia 20 mm. Now this is a block that I am creating. Now I'll be precisely telling you what is the use of the divide and measure with the block. So let's say if I have a block, if I created a 20 mm block, that is 20 mm is for the, and I put this quadrant as the base point, and here I go with the select object. Now you look into it, why I am doing this and how it will help. Now let's say there's a block over here, there's a rebar that I am drawing. Let's say the rebar is let's say around 1200 millimeter. So this is the length of the bar over here, and I want to put my, this is a main reinforcement bar, or and this is for the slab I am doing it. So in this main reinforcement bar, I want to have more reinforcement over here, like the secondary reinforcement placed over here. So here what I can do is I can divide, or let's say for example if I am doing divide, but I will be doing a measure because I know the center to center spacing. So I select this object, if I want to divide it now and select this object, and it will ask you for the number of segments. But before that, there is an option called block, and give the name of the block that you want to insert. For here I want to insert a 20 block. Align the block, yes, and then number of segment, let's say 30. So now you can see that 30 in every segment the block is inserted. Now this is very useful when you have a staircase kind of situation where there is a inclined line that is going over here, and inclined bar, and you want to have the distribution bars over here. So let's say this is a polyline, join it as a polyline, and here let's say I want to insert some 20 bar in this particular inclined bar. So I would go with the measure option because the spacing that I want to keep is 150 center to center. Select this, go for the block, and then let's say 20 I say, and I will say align, yes, and the length of the segment is, let's say, 200 spacing. So now you can see that this, the bars are placed at 200 spacing over here. Now let me have the rebar more specific. So let's say I'll go with the polyline, and let's say I have a long bar so that you can see this. So this is, let's say, this is the rebar that I want to put it over here, and here I want to go with the measure, because the measure you can give the distance. When the divide, you give the number of segments. So here I'm using a rebar, and I use a block, 20 block, and let's say I want to align it, yes, and the length of the segment is 200 Now you can see the distribution 200, not so the rebars are distributed in this particular bar. So this is how basically there are a lot of things that you can do with the blocks while using in the measure and the divide command. So this ends the session, but before that I want to tell you about something about tables. So tables are very important. Here I will go with the table command, and tables are just like, you can put your Excel sheet type of thing into CAD. Let's say there is option like insertion behavior, specify window. So number of columns you want to have 5, and the number of rows, let's say you want to have 4, and there is a table style that I can do. So if you modify the table style, so the table direction, the first is the title, header, and the data. So every cell style you can provide a cell style. For example, what would be the text style for the data, what would be the fill color, and everything you can go over here in the margins. Similarly for the header, this one you can go with the what is the alignment, what is the fill color, and what is the label that you want to give. So here the label is label, so header, and so you want to go with the label. And similarly for the title, you can have the same kind of arrangement, and then you can select table to start from. So if you click into it, if you have a particular table, you can select the property, but here we are creating a table of our own. So this is the style that we have done, and close it. And let's say here we want to go start from empty table, and I say specify window. So here I want to specify it, and here I have this table formed. So the moment I put this table over here, so you can see that there are certain grips that are visible over here, and you can basically change the grip sizes, and each cell can be edited in the table. Like for example, if you want to write something, double click into it, and you can write a text over here. Let's say I want to write a text, schedule of drawing. So here in the text, so you can change the style of it. Let's say if you want to change the style to Verdana, or you want to give the size, let's say 2.5, no, I want to give it as 18. So this is how you can have the table done. So you can table edit command, pick a cell, so you can always edit the cell. For example, if you want to have revision, and so again, if you want to change the sizes of the text over here in the revision, you can always go with the value and change it, and then you can give the style that you want to go with it. And if you want to merge the cells, for example, if you want to merge these two cells, select it, and then you have different options, like you can merge the cell all, so the cell will be merged. So you can try with this, and then you can basically put this table into your sheets that you have created. You can increase the size of this table by doing a scale option, and let's say if I increase the scale to 3. So this is how a lot of schedules can be done. A lot of text can be put over here, like schedule of drawings, door window schedules, bar bending schedules, everything can be done, and it is a very useful option in AutoCAD. But again, so if you want to copy this table into the layout that you have created, so you can copy this, and directly you can paste it somewhere here. But then the table sizes are very big, so you can scale the table size, or directly do a table here in the paper space. So you can directly go with the table command, and specify the window. So you can specify a window of the table, and you can start directly writing in the sheet also. So this will not affect the, will basically scale down to what the paper is intended to do. So I think now we have basically done the layouts and other tools in 2D. Hope you can draw better using all the tools that you have learned. Thank you. Welcome to the session 11 for the course of AutoCAD Essential for Civil Engineers. So this is a very interesting session, and here we'll be starting up with a new process in AutoCAD, that is 3D modeling. So in the previous sessions you have worked on 2D, you have worked on layouts, elevations, sections and other thing. But here you will be, it's a very interesting session where we'll be talking about the various concepts of creating 3D models, creating isometric model views, creating perspective views, camera views, rendering, and a lot of things till session 12. So in this particular session, we'll be starting with the 3D modeling concepts, understand the 3D space, know about how we can change the user coordinate system to work in a 3D model, understanding coordinate systems in 3D, create 3D models, and various other things. Now, before we start with the 3D modeling, I would like to tell you that the 3D modeling tools are available only in the AutoCAD full version. The 3D modeling tools are not available in the AutoCAD LT version. So again, it is very clear, if you are using an LT version, you would not find the 3D modeling tools in the LT version. Now let's see, we start with understanding the various concepts in the 3D modeling space. Now, use of 3D models. Now in 2D, we are only able to visualize the plans, elevations and section. But in 3D, the real model is can be visualized. For example, you can see a feature over here where the 3D model is created. It can be only visualized from all the three direction, that is the X, Y and Z. And this particular model is having a depth as compared to a 2D drafting. So 3D modeling is something very interesting for civil engineers, architects, designers who wants to visualize the end product, how it is going to look like, how my building is going to look like, how my structure is going to look like. It is basically, and then extract various kind of information there. But for here, for in AutoCAD, we can model a building, we can model an element, we can model a structure, and so that easy communication can be made between different stakeholders, so that the actual end product is easily visualized and can be seen how it is going to be modeled or constructed or manufactured. Now, coming back to it, let's come to AutoCAD, and then we start with different kind of 3D models. So 3D models are basically classified into various kind of models. So wireframe model is just like, you're creating a 3D model with the help of lines. So you can see that this is a wireframe model. There is no surface, there is no solid into it. It is not solid, but it is a wireframe model. So wireframe models are basically drawn with the lines with the help of. I'll show you some example. Then we have the surface model, that is the mesh model. The surface model is basically created of various lines. So when lines are joined together, they make surfaces. And then the actual model is the 3D solid model, which is basically the solid. which is having a mask. So the three classifications of the model that you can see over here is the wireframe model, the surface model, and the solid model that you can see in the screen. Apart from that, the 3D space consists of three axes, that is X, Y, and Z. So if you have a right hand thumb rule, go with the right hand thumb rule. The thumb shows the X axis, the other finger you can see over here is shows the Y axis. So and this shows the Z axis. So obviously, if you are basically supposed to see where is your Z axis, just put your thumb towards the x-axis and the other finger towards the y-axis and the third finger towards the z-axis. It will always show you the direction of x, y, z axis wherever in the space. So you can see this is the plus x, plus y, and plus z. Similarly, while we are rotating an object in a 3D space, so the thumb shows the axis of rotation and the other finger shows the direction of rotation. So we will be seeing that how it works. Now let's jumpstart with the basic tools like the view cube, the viewpoint, the steering wheels, and various other visual tools that will help you in order to work in a 3D space, and the workspace that we are going to work. Very important is the workspace. So while you're working in a 3D model, while we are working on a 3D view, you have to change your workspace. So how do you change the workspace? How do you start working on a 3D? Let's jump start to it. So here we have your AutoCAD screen that you are working into it. So this screen is basically set to work in a 2D drafting environment. So if you and you can see that the various tools in this workspace is basically pertaining towards to drafting 2D layouts, 2D drawings, make 2D drawings. So now for creating 3D models, AutoCAD has given you a different workspace to work into it with different tools. Now to change that workspace, you have to go to the workspace switching option, and then you have two options. The 3D basic option, which consists of some basic tools of 3D modeling, and the 3D modeling tool, which consists of some advanced and basic tools for 3D modeling. So now let's go with the workspace and see how the tools are here. So here in this 3D modeling workspace, you can see the ribbon is having a different set of tools. So you have this 3D modeling tab. So in this 3D modeling tab, you have the modeling panel, you have the mesh panel. So in the modeling panel, you use various tools to create 3D solid models like extrude, loft, revolve, and sweep. These are the concepts of 3D modeling. Similarly, if you want to create some primitive objects like box, cylinder, cone, sphere, pyramid, you can also use these tools. Similarly, if you want to create some mesh objects, you can always go with the mesh editing tools or the mesh tools. Similarly, if you want to edit a 3D model, you can use the solid editing tool, and you have the sketch tools, and there are various tools. And this solid panel consists of the tools for the solid modeling. As discussed, some of the tools are present here itself in the 3D modeling tab, but solid tab, there are different kinds of. So we have these various tools like the solid in the solid panel, you have various tools for solid modeling. In the surface tab, you have various tools for surface modeling, and then for the mesh, and then the visualize tab, in the mesh you have various tools for mesh modeling, as well as like the mesh box, like the smooth object, and other things. In the visualize panel, you have various tools related to rendering like lights, like creating materials, and then you have the UCS options, and a lot of things are there in the visualize tab. And then the other are some of the common tabs that are present in the 2D workspace. So let's see about other things in the 3D model space. Now you have this X and Y. This is very important because this is the UCS. We call it as Users Coordinate System. When the UCS is at the default position, it is called the WCS. That is the World Coordinate System. So we will be discussing more about it. But let us see the main tool to change the view and work in the 3D space is the view cube. So where we get this view cube? So you can see the navigation bar over here. If you close this, to get this navigation bar, go to the view tab, and here we have the navigation bar tool. So if you click into it, the navigation bar is displayed, and then you have the view cube. Now this view cube is an interesting tool which is used to change the view in a space. Now here if you look into it, the view cube is showing top, north is the direction, east is the direction, south, west. The north is directing towards the y-axis, east is directing towards the x-axis, south is directing toward the negative y, and so on. So if you want to have the 3D space active, click on the default icon of the view cube. Now you can see the X, Y, Z. 3 axes are visible in the screen. Now here, as we discussed about the various concepts in 3D modeling, we have the wireframe modeling, we have the surface modeling, and we have the solid modeling. So we would be starting with the wireframe modeling, and we will start with the concept of coordinate system. Now here, before that, here also you can see with the view cube there is an icon called WCS. So if you click on the new UCS, you can create a new UCS, but we're not going to do as of now. So let's put this default position over here, and let's understand about the various coordinate systems that are available in the 3D space. So in the 2D we had absolute and the relative coordinate system. In 3D also we will be having both the system, but the difference is here we will be inserting the third axis, that is the Z axis, while we are defining the coordinate or when we are defining the angles and the other things. Now let's see what are the coordinate systems available in the 3D space. So the absolute coordinate system. Now you can see over here you have the origin. So here the origin is the X, Y, and Z, where all the 3 axes meets is the origin. Now in the absolute coordinate system, you define a point with the 3 axes. For example, let's say if I define a point, I start with a line because we don't have any different command, so we draw a line. In fact, so I want to draw a line which starts from 0, 0, 0. Now x0, y0, and z0. So we are putting a first line point with x0, y0, and z0. So press enter. Now the line starts from the origin. Now if you want to draw a line in the x-axis, let's say 5 units in x. So we say 5 in x, 0 in y, and 0 in z. So a line of 5 unit in x and 0 unit in y and 0 unit in z is created. Now if you want to create a similar line but in the z axis of 3 units, you would say 0 in x, 0 in y. Now you can define the third axis, 3. So now what happens if you define this line as 0, 0, 3? So the line goes at the third axis. So you can see that the line goes towards the z axis and the value of the point was 0, 0, 3. So if 0, 0, 3 has been written, that means the line will go in x, that is 0, y 0, and it will go at the top at 3. Now if you just move the view cube, now how to move that view cube? So you can click on the points over here in the z axis in the view cube. Now you can see the various directions in which the line can be seen. Now this is the right direction that you can see that how the line has moved from 0, 0. Then we had in x 3, 0, 0. That means 3 units from in X from the origin, 0 from the origin, 0 in Y in the origin, and 0 in Z in the origin. But now when we are going from this point and we are saying that the line would, the end point is in X it is 0, Y it is 0, and Z is 0, Z it is 3. So AutoCAD basically finds a point at X0, Y0, and Z3 and gets it over here. Now let's say again, let's start the point from 0 in X, 0 in Y, and 3 in Z. So it starts from here, and if I say the next point is 0, 0, 0, that is 0 in X, 0 in Y, and 0 in Z, the line basically goes to the origin and press enter. Now you can see that a triangle is created at the XZ plane. When two axes meets, it becomes a plane. Similarly, just I am moving the view cube. You can also try. So if I want to draw a line again, and I started from 0, 0, 0, now I am using the absolute coordinate system. So in the absolute coordinate system, all the points are basically referred from the origin, as you have learned. So now I started from here, and I want a line 3 units in y-axis but 0 in x and 0 in z. So I will put 0 in x, 3 units in y, and 0 units in z. So the line is created here. Now let's say if I want to go up in the z-axis. Now here the value of y is 3 and value of x is 0. But if I want to go up, it means that I have to retain the value of x as 0, y as 3, but now the z would be 3 units, no? So it moves up. Now if I want to close this particular, I want to face and I want to come here. So this point is 0 in x, 0 in y, and 3 units in z. So I would say it is 0 in x, 0 in y, and 3 units in z. So, and press enter. So now what I am doing is I am creating some 3D wireframe. So this is the wireframe because I am creating a 3D model with the help of lines, which we call it as wireframe model. Now it is not a solid, neither it is a surface. It is completely wireframe modeling. Now if I want to draw a line, now just I'm switching off the view cube to get a appropriate view. So I want to start from this point. So this point is 3 in 0 in x, 3 in y, and 0 in z. So let's start 0 in x, 3 in y, and 0 in z. So I start from here, and I want to create a line in the x axis. Let's see what is the distance that with the distance tool we can check what is the length. Length is 3 units. Okay. So I started from 0 in x, 3 in y, and 0 in z, and I would go 3 in x, 0 in y, 3 in y, and 0 in z. Why 3? Because we already have a value of 3 over here. So press enter. So it will be, and then I want to join this face. So this face is basically, if I want to have this xy face over here, this point would be 3 in x, 0 in y, and 0 in z. Now you can see that we are about to create a wedge. Only thing is that I have to join these 2 points. Now what would be this point? You can think of it, but if you want, you can do it of yourself or you can follow my instruction. Now if I want to start the line from this point, so what would be the coordinate? The coordinate would be 0 in x, so there is no value in x, 3 in y, and 3 in z. So I would say 0 in x, 3 in y, and 3 in z. And then I want to have this point. So this point is 3 in x, 3 in y, and 0 in z. So with this now we created a wireframe wedge. So we'll be doing more exercises of wireframe, but the coordinate system that I have used right now Friends, this is coordinate system is the absolute coordinate system. So now coming back to the coordinate system. So the absolute coordinate system, as you are seeing that here, this point is 10, 6, 6. That means from the origin, this is 10 units in X, 6 units in Y, and further it goes 6 units in Z. So this is the absolute coordinate system. Next is the relative coordinate system. So in the relative coordinate system, you know that in the 2D system, it was a polar coordinate system and a relative rectangular coordinate system. Here we are having 3 coordinate systems. One, the relative rectangular coordinate system, the relative cylindrical coordinate system, and spherical coordinate system. So the polar coordinate system is now subdivided into cylindrical coordinate system and spherical coordinate system. So we would be seeing various examples of how we are utilizing all the 3 coordinate system for the relative coordinate system. We'll create the same figure that we have created in the absolute coordinate system. So let's start. We'll start with the rectangular coordinate system. So we go with again, we'll create a wireframe. We have a line. So the first point is 0, 0, obviously. And the next point, I want to create a 3-unit line in the y-axis. And nothing in x and z. So I would say at the rate 0 in x, 3 in y, and 0 in z. So here I have this particular line of 3 units. Now if I want to go in the z direction, positive z direction, so I would say at the rate 0 in x, 0 in y, and 3 in z. So I'm here. Now if I want to create a line in the negative y direction, I would say at the rate 0 in x, minus 3 in y, and 0 in z. And then I can close it. So I have a face that is created in the YZ plane. So I'll be creating the wedge from here. So I'll be creating an inclined line over here, not similar to the figure that we have created, just changing the face at this particular example. Now if I want to create a line from this point, so I click over here, or I go with 0, 0, and I want to create a line in the x-axis. So I would say it's very simple, at the rate 3, 0, 0. So I create a line, and then I want to create a line in the y-axis. I'd say at the rate 0, 3, 0, and C4. And then I can say at the rate minus 3, 0, 0. So here I have these two faces, one in the YZ plane and the other in the XY plane. Now let's say if I want to create a line from this point to this point, I can pick from the absolute coordinate system or just click into it. And then if I want to create a point over here, so what I'm doing is I'm going down -3 in Z axis and +3 in positive in X axis. There is no movement in the Y axis. So I would say that at the rate I want to move 3 in X, 0 in Y, and -3 in Z. Similarly, if I want to move from this point, the same thing will happen. So I say at the rate -3 in X, 0 in Y, and -3 in Z. So this is what I have created, something that is in the that is basically created with the help of the relative rectangular coordinate system. Now the other coordinate systems that we can use is the polar coordinate system. So the polar coordinate system has two coordinate systems. One is the spherical coordinate system and the other is the cylindrical coordinate system. Let's see what are these. So if I'll start with the spherical coordinate system. Over here, I define a point with respect to the previous point, and I have two things. One is the length, other is the angle that I have to define. Now in angle, I have to define two angles. One, the angle from in the XY plane, and the other angle is from the XY plane. Now, to explain this better, I would take some examples. Now, let's say if I have a line, I'm drawing from the origin, and this line is 3 units, angle is 0. So I'm using polar coordinate system 2D. Now, if I want to incline this line from the XY plane at 45-degree angle, that means the line will go in the Z axis. So how do I do? I can incline the line in the XY plane by rotating it, or let's say 0, 0, 0, and then from here I can say that press enter. The first point is 0, 0. So first point is 0, 0, 0, or you can say 0, 0, and then we can say at the rate 3 angle 45. That means this particular angle is in the XY plane. But my case is something different. I want to incline this line not from the x-axis but from the plane so that it goes straight here. So here what I need to do, I need to use the polar coordinate system, and that is also spherical polar coordinate system in the 3D environment. So here when I define a line, the first point is 0, 0. So as polar coordinate system, this line is at an angle of 0 degree. So I say at the rate, the line length is 3 units, angle with the x-axis is 0, but the angle with the xy plane is 45 degree. Now here you can see that, just showing you for reference, rotating it, this line was basically at 0 degree with the x-axis, but now this line had inclination with the xy plane. So if you see the front view or the you can see in the view cube, there are, if you look with the front view, you can see how the orientation is done. So this is the line which was created at 0 axis with the 0 with the x-axis, 0 degree with the x-axis, and 0 degree with the xy plane. But this line is at the z-axis, which is having an angle of 0 degree with the x-axis, but an angle of 45 degree with the xy plane. So this line is having an angle of 0 degree with the x-axis, but it is inclined at an angle of 45 degree with the xy plane. So let us do another example. Let us create another line at 2D plane, that is xy, and then we will rotate it at 45 degree with the xy plane with the help of spherical coordinate system. So in the spherical coordinate system, as you see that, you define a line by the length, the angle with the, and the angle it makes with the xy in the xy plane, and the angle it makes with the xy plane, in the xy plane and with the xy plane. So two angle components are there. So let's take another example. Now here I'm just erasing this. I have this line which is, let's say, 3 units, and its angle with the x-axis is 0 degree. Now I have another line which I start from 0, 0, 0, and the length is 3 degree, and this line is at an angle of 45 degree with the x-axis. So the line looks like this. So if you look into the top view, the line will look like this. So now I want to have similar line of length 3 units with an angle of 45 degree with the x-axis. So let me do a dim angle here. So dim angle. So this is the angle that the line is making with the x-axis. Now I will draw a similar line which is at an angle of x-axis, 45 degree with the x-axis, but also having a 45 degree angle with the xy plane. So let's draw a line 0, 0, 0, and at the rate 3 is the length, angle with the x-axis is 45, but the angle with the xy plane is also 45 degree. So just rotate the view cube to see what happens. Now this is the line which is in parallel, which is in the plane, this particular line in the plane, same plane, but it is having angle of inclination of 45 degree with the x-axis, but also 45 degree with the xy plane. So the line becomes like this. So this is spherical coordinate system. We will do one application based on this. And then we have the cylindrical coordinate system, which says that here, if you are using the coordinate system, you give two things. Number one, in fact, three things. Number one, what is the length of the line? Okay, what is the length of the line? What is the angle it makes with the x-axis? And what is the distance that the end point makes with the xy plane? Here we have the perpendicular direction of this point from the xy plane. Now let's do like this. So if I have a line, let's say I'm creating again 0, 0, 0. I say at the rate 3, 0, 0. So I have this line in the x-axis. So I can create this line by again 0, 0, 0, and I say at the rate 3 angle with x-axis 0 and angle with xy plane 0. Now I am using the spherical coordinate system here. But now if I am planning to use cylindrical coordinate system, I have to give one illustration. Let's say if I have a line here which is at a height of 3 units from this point in z-axis. So I will say at the rate 0, 0, 3. Now suppose here this is the depth of the point. The point moves from this point to this point. So if I want to create a line of this length and angle with the x-axis is 0, but the depth of this line is 3 units, so it will be created like this. So let's take an example. So with the cylindrical coordinate system, so the first point is 0, 0, 0, and the next with the cylindrical coordinate system at the rate length of the line, angle with the x-axis, then put a comma, and the distance that it makes with the xy plane is 3 units. So you can see that it just basically creates a line of length 3 units, angle with the x-axis is 0, and the z depth is 3 units. Now let's take another line. So line, first point is 0, 0, 0. Next point is same at the rate 3 angle 0. But here I take the depth as 5 units. Now what will happen? This depth now will become 5 units. So if you basically rotate the view cube, you find that this line is linear with this line, but the depth of the line is 5 units. So there are different coordinate systems that we can use. In relative, we have a rectangular coordinate system, we have a cylindrical coordinate system, and we have a polar coordinate system. So we'll do some application based on this. Now let's create a cube of 3 units side. That means a cube will be having length, width, and height as 3 units, and we'll be using all the 3 relative coordinate systems. That is a rectangular coordinate system, spherical coordinate system, and we will be using the cylindrical coordinate system to create the cube. So again, remember that we are creating a wireframe model. So in 3D modeling, we have got 3 concepts. One is the wireframe modeling, other is the surface modeling, and then is the solid modeling. So wireframe modeling is the basic modeling technique where we show different kinds of line works in different axes. A 3D line work can be shown with the 3D model of wireframe model can be shown with the line works. So let's create the default view over here. So we can also change it towards ourselves if we want to see the XY viewing our eye. So let's start. So now we'll be creating a cube of 3 units. So line will start with 0, 0, 0. Now first of all, I want to create the face in the XZ plane. So I have to go in the y axis. in the YZ plane, I have to go in the Y axis first. So I'll say at the rate 0 in X, 3 in Y, 0 in Z. So which coordinate system I have used? I have used the relative rectangular coordinate system. Again, I will use the relative rectangular coordinate system to go in the Z direction. So I'll say at the rate 0 in X, 0 in Y, and 3 in Z. So I'm using again the rectangular coordinate system. For this phase, I'll be using the rectangular coordinate system. Now, again, if I want to go in the negative Y direction, so I'll say at the rate 0 in X, minus 3 in Y, and 0 in Z. Because there is no movement in Z, there is no movement in X axis, only it is going in the negative direction. So the line will be created. And then I can go for at the rate no movement in X, no movement in Y, but minus 3 in Z axis. So present. So the YZ plane of the cube is created now. Now if I want to start again from the origin, I say 0, 0, 0. Now I will be using the spherical coordinate system. So if I want to create a line which is parallel to in the x-axis, so I'd say at the rate, the line length is 3, angle is 0 with x-axis, and angle is 0 with the xy plane. So I move this side. Now if I want to go in the z-axis up, so I would say at the rate 3 unit is the length, angle with the x-axis is 0 because there is no angle. This line is 0 degree, and then I'm going to rotate it in the xy plane. So angle with the x-axis is 0, but angle with the xy plane is 90 degree. So now you can see you can change the view cube at this moment of time to see it better. So I'll be using this. Okay. Now I want to go and join this point. So for that, I would say that I'll be using the spherical coordinate system again. So I would say at the rate, the length is 3, but the angle with the x-axis at this moment is 180 degree, because if I would be saying 0, it will go in this direction, but I have to go in the negative x direction. So I'd say angle is 180 degree and the angle with the xy plane is 0. So here I have this face created. Now I would be creating the other face with a cylindrical coordinate system. So here I have the first point. So this first point is 0 in x, 3 in y, and 0 in z. 0, 3, and 0. So now if I want to move in this direction and use a cylindrical coordinate system, I would say at the rate length is 3 unit, angle with the x-axis is 0 because it is moving in the x-axis, and comma, and the distance from the xy plane is 0 because it is created in the xy plane itself. So we have 0. Now if I want to move up, I would say at the rate length of the line is 3, angle with the x-axis is 0, but the perpendicular distance from this point in the z-axis is 3 units. So now if you write at the rate 3 angle 0 comma 3, so what is going to happen? Is it going up, or it is basically creating the point somewhere else? So we need to understand the theory of cylindrical coordinate system here. Now what is happening when we said at the rate 3 angle 0 comma 3, so CAD is creating a line of 3 units at an angle of 0 degree with the x-axis, and further it is moving perpendicular up 3 units. So the line is coming over here. But at this moment, we require a line which is perpendicular, straight. So in this case, this is a 0 unit line. So here what we need to do is we have to create a line with 0 unit of length at an angle of 0 degree, but the perpendicular distance is 3 units. So this is what exactly the concept is all about. Here, if we want to create a line at this particular point, so with the cylindrical coordinate system, what would be the cylindrical coordinate system for this? So we are going towards 3 units, in the negative y direction. That means here we are creating a line at this is 0 degree, this is 90, 180, 270. So here we will be saying that create a line of 3 units at an angle of 270 degree at a perpendicular distance of 0. So this line, when it is going towards the negative y direction, is a 270-degree line. Why? So this is the 0-degree line with the x-axis. This is the 90-degree line. This is the 180-degree line, and this is the 270-degree line. So if I say at the rate 3 angle 270, the line will be directed towards this direction. But 270, let us. But now we also need to see how much elevation we are providing to the line. Are we providing any elevation or 0? So it is a 0. So the line is setting over here. I'm sure you will be having difficulties to understand. You have to watch this video again to understand the cylindrical coordinate system. So let me again connect this line. So just click on the views that is suitable to make you understand, or just press on any of the edges, corner points, and just you can have an orbit of it, and now you can see it properly. Now let's say if I want to connect this point, so this point, I would say that line, just pick this point with the object snap, and if I want to go this direction, that is in the x direction, I can use any coordinate system. I can say at the rate 3 units, angle 0 in x, that is I'm using the spherical, and 0 with the xy plane. So this particular cube is created. Now let's again practice some of the shapes with the coordinate system. Now let's say if I am creating a line, the first point is 0, 0, 0. Now if I want to go in the z axis right now with the cylindrical coordinate system, so I have to say that there's a 0 unit of line at an angle of 0 degree, but the distance is 3 units. So I am 3 units up. Now if I want to go, let's say, at the x-axis direction at the rate 3 in x, but the angle with the x-axis is 0 and the angle with the xy plane is 0. So I'm using the spherical coordinate system. Now I want to go up. I am going to create a steps. I want to go again up in the z-axis. So I will say at the rate 0 length, 0 angle, but the unit is 3 units. So I go up. Again I want to go in the right direction at the rate 3 angle with x-axis is 0, angle with the xy plane is 0. So I have another line. Now if I want to go down, so I have to say at the rate 0 length, angle is 0, but the perpendicular distance is minus 6. 3 plus 3, 6. And then I can go for a close option. So you can see that I have created a step over here, and I'm going to complete the thread over here, the riser and the thread. So I start from this particular point 0, 0, 0, and I want to go in the y direction. So I'm using a relative rectangular coordinate system now. At the rate, so 0 in x, 6 in y, and 0 in z. Now if I want to go in the z direction, so I would say at the rate 0 angle 0, I am using the cylindrical coordinate system, comma 3. Then if I want to go back in the negative y direction over here and close it here, so I would say that this line is 3 units length and angle with the x-axis is 0, 90, 270, 180, and 270. So I would say at the rate 3 angle 270, and if I want to use the uh, spherical coordinate system, I will say angle with the xy plane is 0. So now because it was 3 units, so it ended over here. Now let's say I want to create another feature over here, because I wanted to create a slot feature over here in the steps. So, or you can further go at the rate, you can write down 0 comma minus 3 comma 0. So you can close it. We'll create the slot later on. So now here we again pick the line from this point. I want to go in the x-axis. So I would say at the rate, I can say 3 comma 0 comma 0. And here if I want to close it, I would say at the rate 0 comma minus 3 comma 0. So relative rectangular system is very easy. Again at the rate minus 3 comma 0 comma 0. So here now you see that I have to go at the rate 0 comma minus 3 comma 0. So I created one steps here. Further, you can use any number of coordinate systems if you want to create it, but the shortcut is go for a copy option, select the line, let's say this line and this line, and just copy it over here. And here you can basically close these lines and create the step. So here you have to again copy this line, this one and this one, and bring it here so that the 3D wireframe model is created. So 3D wireframe model is a technique which, so I am using a command called 3D orbit, 3DO. So here you can basically orbit the object and see from all the faces. So I'm pressing my mouse, left mouse button, and doing an orbiting. So if I want to join these two lines, which is open from the bottom, so just press escape here, just zoom out, and then you can join these 2 points. Again, you can go with the 3D orbit. 3D orbit is basically orbiting the object to see various faces of it. So this is a 3D model, entirely a 3D model which is having x, y, and z coordinates. So I think the wireframe concept is something that we have understood. Now the next point is I want to create a surface at the face so that the back face is not visible. So it's just like you're creating a wireframe model like the potter do. They create a wireframe and then put a paper to it to create a surface and then make it a solid. So same concept is there. You create a wireframe, create a surface, and then create a solid. So this is the progress of the creation of 3D model, solid modeling. Wireframe, surface, and solid model. So we are going to create a surface into it. So if I put a surface, if I put a paper over it, that means this line will be hidden. So how do I create a surface at the face of a wireframe? So the command is 3D face. So here specify the first point, second point, specify third point, and then you can create a 3-side face right now if I press enter, or specify the fourth point and then press enter. So now if you see that, if you give a command called hide, the object is hidden, which is under the face. Now you can see. And then with the visual style, if you go for shaded, you can see that the face is put over here. Now again, this is a visual style. You can have a 2D wireframe right now. Visual style is 2D wireframe. You can have a hidden option. You can have the conceptual options we'll be discussing later on. And then you have the shaded option. So various options are there. You can try with these options, shades of gray, and a lot of options are there in the visual style. So we are going with the 2D wireframe now, and if I want to hide the surface that is created, I will go for hide option. Now I need to hide this particular face. So I'll go with 3D face again. first, second, third, and then fourth, and press enter. Now again you can test it. You say shade. You can do a 3D orbit, 3DO. You can see how the faces are created. And similarly, you give the faces to the other faces of the wireframe so that a surface can be created from the 3D wireframe. Right click and say exit. Now here in this particular mode, again go to the 2D wireframe. So let's say if I give a 3D face and this particular face, 2, 3, 4, press enter. So you go for a hide option or a shade option. So you can directly go for shade option. Now you can see the faces given over here. So if you want to put, you can also use 3F command for 3D face. 1, 2, 3, 4 the faces. Now if I want to create a face in this L portion, so I go for 3F. So here we have 1, 2. So if I say third is this point, fourth is this point, so it will be creating a different face. So how would I be creating the face? Let's see. So I have a 3 face. So I go for first, second, and then third point is this, and the fourth is this. So I'll be creating partially here and partially here. Again, I go for a 3 face. 1, 2, 3, 4. Press enter. Similar thing I will be doing here also. So in the 3D orbit, if you look into it, if you right click, there are two views. One is the parallel view, that is the orthographic view, and one is the perspective view, which is a non-parallel view. So I would always prefer to be in the parallel view at the first. So press exit and then you can have the 2D wireframe again. If you are going for a hide option, so you can always give a hide. You can see that how the faces are hiding the edges. Now similar 3 face, first, second, third, and fourth. Enter. So again hide, again 3 face, first, second, third, and fourth. Hide. So if you want to go for a shade option, shade view, shade. So now again you can go with 3D orbit and you can see that how the surfaces are created at the face. So this is basically converting the wireframe into a surface. So you can try with more wireframes and then you can give them an edge as I have done. Let us take some examples of creating more wireframes. Now I'll be teaching you some shortcut ways of creating some wireframes. So let's say if I have, so here I will be using move and copy option also. So let's say I want to go to the top view. So the way to go to the XY plane parallel to the screen is either you go with the click on the view and say top. So this is one way, and the other way I will tell you very soon. So let's say I have a rectangle and rectangle is at the rate 10, 10. So size in X and Y is 10, 10, and I have an offset, let's say 2 units offset. So it comes inside. So here I want to move this rectangle 5 units in the Z axis. So I would say move, select, take a base point, and here for the second point I would say at the rate 0 in X, 0 in Y, and 5 units in Z. So now I have got 2 rectangles. One is in the XY plane and the other is at a distance of 5 units from the XY plane. Now what I will do is I'll create edges connecting the 4 points of the 4 squares. So I have a truncated pyramid that is created. Now see, sometimes you have to use the view cube to have the correct wireframe modeling. So this is a wedge that I have created, and if I want to create, so I'll just copy it, this rectangle, and now I'm doing a copy option, and I am copying it at the z-axis at the rate 0, 0, 3 units. Now what I will be doing is I'm creating another feature. So I just can have the 3D orbit command here so that I can see how things are created. So I'm joining this point. I'm creating a compound object. Now you can see, now I can use the 3D face command to make it a surface. So let's do it. So I have this 3F, 1, 2, 3 and 4. Press enter. So if you hide it, you can see that it is hidden. Or you can go for a shade option to see the shaded part of it. 3F, 1, 2, 3, fourth point. Just go for a 3D O and just rotate it for a particular position. So how do you rotate? Go for 3D O, press the left mouse key and just rotate the hue. So 3 face, 1, 2, 3, 4, 3D face, 1, 2, 3, 4, 3D face, 1, 2, 3, 4, 1, 2, 3, 4, 3D orbit, 3D face, 1, 2, 1, 2, 3, 4. So now you can see, just press undo if you're having some problem with the 3D face. Just rotate the 3D orbit and see if you can correctly click the points. 3D face, 1, 2, 3, 4. So this is how you created a wireframe and then a surface with help of lines and some commands. Now let's do the last example. Now this is the perspective view. In order to change it to a isometric or a parallel view, go for 3D orbit and then change it to the parallel. So just you need to have a lot of practice to create different wireframes. So I'll give you another example and then I will be switching off to the surface tools. And then we will be doing the 3D solid modeling tools and end the session. So now the modeling concepts are getting more and more interesting. Next, move on towards another model that we want to create. Now, again, to come to the top view, just click on the view icon, view control icon, say the top, select all of them, erase it, and then go to the 2D wireframe option. Now, I have another rectangle, let's say, at the rate 10, 10. Just exploding this and creating another 3 units offset. Or what I would say that create a rectangle which is length is 10 units in X and 3 units in Y. So why I'm doing so, see, so I'll be moving this rectangle with the base point and the Z axis would be 0, 0, 5 units. Now let's say if I'm joining this points, I'll be having some different kind of. So now this is another 3D model wireframe that is created. Now let's say we'll be doing more options of this, but once we learn the UCS option, then things will be easier. Okay, now let's erase it. Now come to the topic called surface. Surfaces are basically created with the lines. Now let's take an example. The first surface that we will be doing is a ruled surface. Now what is a ruled surface? So for the ruled surface, you need to have two particular curve. For example, I'm having this. I'm doing it in 2D. So if I am going to join these two arcs threaded, it will become a surface. So ruled surface, as the name suggests, is basically joining the two curve and create a surface. So if you shade it, you will find that a surface is created. So again, surface is basically created from lines, and solids are created from surface. So the first thing that we are going towards the 3D modeling concept is from line we are going to surface. Now if I want to smooth the surface, I want to create more lines and mesh geometry over here. So before I do a rule surface, I would be going for a command called surf tab 1, whose value is 6. I would make it 24. Or if I make it 40, so the maximum value that I can have is, so keep on creating. You can have 300, you can have 100. So if you have 1000, so you can create as number of mesh that you can add. So if I go for a rule surf right now, so I select this, so you find that there are 1000 lines which are joining. Previously it was 6. Now let's say if I undo it and give a surf tab value 1 of, let's say, 10. So what will happen if you do a rule surf? So the surface will be having 10 lines. Similarly, if the surf tab value, so after creating the surface with the rule surf, you cannot change the resolution of the surface lines. So if I have 30 and you say rule surf, so 30 lines, so it will be more smoother. So the ruled surface, the surface is ruled by two curves. So let's say if I have one line, let's say if I have a straight line and if I have an arc. So if I want to create a surface joining these two curves, so before creating the surface, we have to see what is the value of surf tab 1. It is 30. So if you say rule surf and then you see the value is surf tab 1 is 30, and then click on this, both the points, the surface will be created. So if you shade it, you will see the surface is created. Okay. Now if you have now here it is very interesting. Let me have it is into 2D wireframe. Now give you another example of rule surf that I always find very interesting. You have a circle and you have a point at the center. Now p-type, you can command p-type command to change the point style. So if you're moving this, or in the Z axis, you can do it either by the move command, take the point and say at the rate 0, 0, 3. So it moves at the 3 units. It's very high. So let's have a lesser value. Let's create the circle with a greater radius. Let's say the radius is 10 units, so that it is a bigger one. And here I have this point with the Z value at, let's say, 3 units. Now if I say rule surface, I select this circle and this point, a cone will be created. So this is very interesting. When you go to the 3D modeling concepts, you will find a lot of interesting things happening. So rule surface is a surface which is created by two curves, and for that you have the setting called subtab 1. Now again, go to the top view. The next surface command that I would be using is the edge surface. As the rule surface is for two curves, the edge surface creates a surface by four curves which are joined end to end. For example, if I have a line, so I copy this line over here at bottom, and I have an arc which is connected with each other, right? Now I want to create a surface from the four edges of this particular geometry. As such, when the surface will be created, this line will be connected with this, and this line will be knitted with this. So now if you go with the command called edge surf, here you have to set another surface tabulation, that is subtab 2, because subtab 1 is already set to 30. Subtab 2 would be basically the surface tabulation for the second set of curves. The first set of curve will be having 30 units. So let's do surface tabulation 2 and give the value as 30. Now you go with the edge surf command, and here you can select these two curves as the first joining curve. Now select object 3 for surface edge. Now look into this. This surface is created with the help of the four edges. Now if you shade and you have normal shading, the surface will be created. So now you have understood that the surfaces are created with the help of the lines and are joined by surface tabulations. So we'll do another example of edge surf, and then we will go to the another set of commands in solid modeling. So here actually in the 3D modeling for civil engineering and architecture, the main emphasis would be on solid modeling. So the next set of tools that I will be teaching you is about solid modeling and how we can create architectural models or civil models, civil related models more proficiently for our project. So this is a concept that I am going through it, and then I will be taking the momentum and explain you regarding the application of the 3D modeling concepts into the project. So coming back to the topic, so you have this another, let's say we have spline, which is a smooth polyline I'm using for the first time right now. So smooth polyline is just like a curve. Now you have another set of spline, which is a smooth polyline, and then you have to join the edges one to one. Let's say I have another smooth polyline, which is here, and then another set of smooth polyline here. Now remember, the edge surf command will only work if the edges are connected with each other, otherwise it will not work. So we have the command called edgesurf, and you need to see that subtab 1 is 30 and subtab 2 is 30. 1 and 2, 3 and 4. The surface is generated. So the more surface tabulation you require, the more value you have to give. So you can give with the 3D orbit command and you can see the surface is generated. So here what you can do is go with the shade and see how the surface is generated. The next command in the surfaces is our rule surf. We have done the edge surf. Now we will be doing the rev surf. So this is again a very interesting concept which will be further used in solid modeling, which is a surface which is created by revolving a line or a curve within an axis. So for example, if I have an arc, so let's take an example of a arc, start point and end point at the bottom, second point let's say here, and this is an arc, and there is a line, straight line, which is an axis. So what will happen? Imagine what will happen if I revolve this arc within this axis. Can you imagine? Okay, so a curve will be generated with the profile of this arc. So again, for rev surf is surface created with the revolution of an arc over an axis. So again, surf tab 1 is 30, surf tab 2 is 30. You have to look into it and then select object to revolve. So this is the object that we want to revolve. Select object that defines the axis of revolution. So remember that the object should be a line for the axis. So I select this and now it says start angle, I say 0 and the end angle is 360 degrees. Now you can shade it and see how it looks like. So let's take more example with other parameters. Now let me go back to the top view and let me copy three copies of this particular curve with different options I will be showing. Now rev surf command, give it in the command prompt, select it, select the object that defines the axis of revolution, start angle is 0, end angle is 360. So this is a curve that is generated, surface that is generated. Rev surf, object to revolve, axis, start angle 0 and the end angle is 180 degree. This is a surface that is generated. Rev surf, object, start angle is 90 degree and the end angle is 180 degree, included angle. So this is how you generate revolved surfaces from curves. Now let's take another example. You have a circle and you have an axis. So if you revolve this surface, what will happen? So circle, axis. So this is the rev surf command. Select axis, angle 0 and included angle is 180 degree. A tube-like structure will be formed. So if you want to shade it, you can see it. You want to give a color to it, you can always give a color to it. Go to the properties and give some color. If you want to see it smooth in conceptual, you can see. So this is how the revolve surface command works. You can create domes, you can create sphere. So now what happens if the axis, I'm just undoing it, if the axis passes through the center, let's try it. So we have the surface command. Select the axis of revolution and 360-degree. A sphere will be created. So this is how uh, you can try with various kind of options and use the ref sub. Next, going to the next set of surface tools. I hope you will be enjoying it while you do it. And then we have the, go to the top. The next is basically the tabbed surface. Now the tab surf command. So this is called a tabulated surface, not surface tabulation, tabulated surface. Now how it works? If you have an arc and there is a line which is a perpendicular vector going in the z-axis, so you can do it by direct entry, just clicking the z-axis, go through it. In the ortho you can go in x, y and in z. So let's say I'm going in the z direction. Now this is a direction vector. Now if you want this arc to basically go up and create a surface in this direction vector, you can use the command called tab surf. Select object for path. So this is the object and this is the direction vector. So a surface will be created in the direction vector. So this is the tab surf. Here the subtab 1 value is taken. So this ends the basic of surfaces. Before we go to learn about the solid modeling tools in this session. So you can have these tools that I have taught you in the mesh tab, and these are the tools like you have the rule surf, tabulated surface and the edge surf. Now let's go to the solid modeling tool. Now next part, it is very important to understand what is a solid model. Solid models are basically 3D solid objects which is having mass properties. So the difference between a surface model, the wireframe model, and the solid model is the solid model is having mass. That means it is the whole stuff of object which is inside, it is a solid. So any model that we will be creating over here with the solid modeling tools will be having the mass into it. So we'll be seeing how we are creating. So first of all, let's understand the basic primitives of the solid models. The basic primitives are the boxes, how to create a box, cylinder, sphere, and then we will be learning some 3D modeling tools like the extrude, the revolve, sweep, and then we will be also in the sweep we have got sweep and loft, and then we will be having some Boolean operations like union, subtract, intersect, and then we will be learning about how to slice an object, 3D object. Then we will be learning about how to fillet, taper and create shell, and there are a lot of other options that we'll be learning. And then we will be learning about how to create practical objects, different objects like wall, doors, windows, staircases, columns, beams. How can they be created in our project? So now the next couple of hours or next hour we'll be discussing about various concepts of 3D modeling, and here also I will be taking the concept of UCS, user coordinate system, and how we can use. First, let us quickly have the tour of basic solid objects, and then we will be looking into the other tools. So box. So if you want to create a box, creates a 3D solid box. Give the first corner of the box, first corner, other corner, create a rectangle, and then give a length. So you have the other corner, and then give the height. So if you want to give a height of, let's say, if you just click it, the box will be created. Now, this box is completely solid object. Now, if you use a command called mask property, if you click into it, you will have the entire mask property like the centroid, the moment of inertia, and the volume of the box and the mass, taking the density as well. So similarly, if you want to create, now let's go up, escaping it, and create a box again and see the various tools. BOX is the command. So you can create a box from the center, specify the center of the box, specify the corner of the box. Let's say you want to give some corner point and the height. Again, the height is from the center. So we'll be doing it by certain values. Let's create a box first. First corner point, just click it somewhere here. At the rate, let's say other corner point is 10, 10. And the height that I would be giving is, let's say, 10 units. So here I would say other corner point at the rate 10, 10, because that's what the other corner point is. And the height, so I would be giving as 10. So a box is created, a cube is created 10 in 10 length, width, and height. So again, let's go with the box. First corner point and other is 5, 10, and the height I'm giving as 5 units. So a cuboid is created now. Now, if you want to create a box from the center, so center option, click into it, and now you can see the creation is from the center. You can have a length option. Length of the box is, let's say, 10 units, width is 10 units, and the height is 5 units. So the box is created from the center. The point that you click is the center of the box. So you can try with the other options. Coming to a cylinder will be requiring a center point, like specify center point. So I click over here, the radius of the cylinder, I would suggest that I give it a 5 unit. And then there are various options, 2 points and axis endpoint. Now these are very important points. So if I only specify the heights, so I say height is 5 units. So cylinder is created. Now if you go into the property of the cylinder, you will find that the radius and height is given. You can change the height. Let's say I want to change the height to 10. The cylinder will be increased. Now here another thing that you see here is the grips are created. So with the grips you can increase the height, decrease the height, whatever you want you can do. So again, if you look into the properties, there is an option called solid history. You can record the solid history, show history. Yes. So we will show the history. So if you go with the solid history, select it into the value solid history 1. So with the mask property, you can see the value of the solid. So here I have gone here with the properties option, and then if I want to create an elliptical cylinder, so here you can have the major axis. Now you can give it as 20. So a elliptical kind of cylinder is created. So if you want to create an elliptical cylinder, you can go to the top. You can go for the cylinder command. You can say elliptical, create the ellipse endpoint, the other endpoint, and specify endpoint of the second axis. So you have this base created, and by 2 points you give the height. Now let's say the height would be somewhat like this, like the 2 points you give. This is the distance, the height. You can see that a cylinder is created of that particular height. Now again, let me do it again to show you the 2-point option. So I'm creating a center of the cylinder, radius I'm giving, and with the 2 point I am specifying that the height would be this much high, 4 units. So this height of the cylinder will be taken from the 2 point that I have given. So again, you can create a cylinder with 3 point, 2 point TTR and other circle option, you can try with this. Sphere will be having a center point, again the radius, let's say 10 units. Now over here, if you are creating a cylinder that's a curved surface right now, you will see that if you do a hide operation, the meshes are not smooth, right? To make the meshes smooth in the hide operation for the curve solids, you have a command called face stress, face resolution. So the maximum value is 10. Now if you do a regenerate command and then you go for a hide option, you can see the surface resolution of the solid object changes, both for the cylinder and the sphere. Now if the face stress command is, let's say, 1, now if you say hide, you can see the surface is not so smooth. So even if you shade it or see in the realistic, you can see the smoothness is not so achieved. So for that you have to go with face stress command. The maximum value is 10, and then you can see. So now here in the hidden, the surfaces would not be seen, but in the wireframe the surface resolution can be seen. Go for the height. The moment you zoom, it will be gone. Okay, so this is the sphere, and you can try several options for sphere. Now here you can increase with the grips, decrease with the grips. So friends, this was the option for basic primitive solids that you could do. Sorry. So there is something called polysolid. So here we have more solids over here, and let's try with this one. The first thing is the polysolid. Specify start point of the polysolid. So you specify the start point, and then the next point, you can see that a wall type structure is created over here. So it means that it is having a thickness. So if you create a polysolid, here you have the width. You can set the width. Let's say I set the width to 0.5 and height to, let's say, 3 units. So now if I start this point, 0.5 height, 0.5 width and 4 unit height of solid will be created. Now this is entirely a 3D solid. So if you shade, you can give the shade command to shade, or if you hide, you can see that the 3D model is generated. Now what else I can do with this polysolid? Go to the top and go to the 2D wireframe option. So in the polysolid, if you want to set the height and width, that is fine, and you can select an object. For example, if you have a arc and if you want to convert it into a polysolid, that is a curved wall example. So you take a polysolid, you take a width, you take a height, and then select this arc. A polysolid will be generated. Now if you go for height command, and if you increase the face stress command value, now it is maximum is 10, it will not go beyond 10. So if I say 15, it is not taking. So you can see this particular ball like structure is generated. So let us go to the top view again. So this is about the polysolid, and then we have this wedge option. Wedge option is just like a box which is cut. So you have the first corner point, so all the commands will be same as the box, other corner point, and if you get the height, a wedge will be created. You can go with the command prompt. Let's say, for example, go for a wedge. First corner point, let's say I give @10, 10, and the height I give as a 10 unit. So a bigger wedge will be created. So this is something that can consider. Next is the cone. For the cone, you have again like a cylinder, the cone works. The only difference it would be meeting at a point. So center of the cone, the base radius of the cone is 3 units. Height of the cone is, let's say, 5 units. A cone is set. Now if I want a truncated cone, so I have a cone over here. Take a cone option. Center point, radius is 5 units. And I want the top radius to be, let's say, 2.5 units. And the height I give it as 10 units. So I can see a truncated cone created with the help of the cone option. So other options are very similar to what we have learned. So now one of the very interesting option over here is the axis endpoint. Now if I want to have the axis at this particular, in the Z, the cone will be created. But if I want to have a cone which is lying on the ground, so I can give the axis endpoint in the x-axis. Now you can see the cone is lying in the xy plane. So this is what I can have a different option in cone. Next is the pyramid. So specify center of base or edge or sides. So let's go with the center point of base. So center point is this, and this is the base radius. So let's say if I give the base radius as 5 units and you have the height as 5 units. A pyramid. So now you can see that if I use the distance command, this particular length is 10 because the base radius was 5 units. So the length is 10 and the height is given what we have decided. So let's go again and say the command pyramid, or go the pyramid way. Center point, or you can go with the edges. So if you want the first edge point here and the second edge point at, let's say, 10, 0 in the x-axis, and now if you want to give a height of 5 units, so a pyramid of 10 units edge of, so now you can see and height of 5 units will be created. Now let's go for more options in pyramid. So in pyramid there is another option called the sides option, where you can create a polygon kind of thing. Hexagon, you can have a center of the hexagon. Again, you can create inscribed or circumscribed. So the base radius is something, the distance from the center point to the perpendicular to the edge, let's say it is 5 units, and you have the height. So hexagonal pyramid is created. So you can have pyramids of base geometry of different sides. You can have pyramids of base geometry of different sides. For example, now let's say if I take a pyramid and if I go with edges, first point, and because the side we have taken and the second point at this point and the height I can give. Now let's say if I want to have a truncated pyramid like we had a truncated cone, let's say I go for the pyramid option. So I go with the edge option. So I take this one, and here I go with the top radius and give a top radius value, let's say 5 units. Now you can see that. So, and the height, now I have to give the height, let's say 10 units. So a truncated kind of pyramid is created. Now let's go with some values. So I have a edge option. I can go with the edge option, the first point at the rate 5, 0 in x-axis. Now let's say if I go with the top radius of 5 units and the height, or I can give of 10 units. So I have got a pyramid of this shape. Now let's take some example with this square edge. So I go with the pyramid and the center, let's say I go with sides 4 now, and the center point is this, and the base radius is, let's say, I give it as 10 units, and for the top base radius I give it as 5 units, and the height I want to give, let's say, 5 units. So you can see that this truncated pyramid is created. So you can also have a pyramid lying down in the XY plane. Like for example, if I want to create a pyramid with center point of base here, base radius as 5 units, and if I want to give the axis endpoint here, so it is lying on the XY. So this basically shows how we can create the pyramid with different options. You can try with all other options, and definitely you will be able to create pyramids. So now let's do with the last option called the torus. Torus is like a tube, like center point of the torus, the radius of the torus, like a tube radius. Let's say I have a radius of 10 units, and the tube radius that I want to give it as 1 unit. So now you can see a tube of 1 unit radius is created with the help of the torus command. So this is the torus. So let's create the torus again. So command for torus is torus. So you can create by 3 point, 2 point, TTR, whatever options you can. You can give the diameter. Diameter of the torus is 20 units. And the tube radius, let's say, tube diameter is, let's say, 5 units. So a torus is created. So here we have done some basic primitive. Now let's talk about custom creation of 3D solids. So the creation of 3D solids custom base starts from some commands. We start with the extrude, revolve, then we go to the press pull tool, then we go with the sweep and the loft, and then we will be doing all these options series. We will be having the fillet edges, how the fillet and chamfer can be done. In the 3D, how we can taper the surface, how we can extrude a surface, and then how the shell can be done. So there are a lot of tools that we'll be learning in the 3D modeling concept, and we'll be doing a particular model of a building element. Now, let's say if you have a profile, if you have a circle. Now I'm having two options. I have a closed edge. These are the profiles, and I am all creating this in the XY plane. So I have a circle and I have a line like this, and I trim it. Now these are all wireframe objects, 2D objects. I want to extrude this circle. I want to make the solid of the circle as such. If I extrude it in the Z axis, a solid will be created. Now here, to extrude a wireframe object, it should be closed and it should have a region. The first step is to, if I want to extrude the 3D object, the 2D object in the Z axis, I have to make a closed region. The first thing is that to make it a region, select this object, a region is created. So region is just like a surface created before you are creating a solid. So this is the surface. So if I want to extrude this particular closed surface, I have to make the region of it, and make sure that to create a region, it has to be a closed entity. For example, if this is an object which is like this, the endpoints are not closed, regions will not be created. So you have to basically have a closed entity. So region, select. Now I have got 3 regions, and now I have this extrude option. Select object to extrude. So here I select this object, enter, and then I have got different options. First is the height of extrusion. So I give the height of extrusion 5 units. ext is the command. Select this object, enter, and the height of extrusion is 4 units. ext is the option. Select it, height of extrusion is 5 units. So you can see that different objects are created from different regions. So now I will be also telling you other way of creating a region and then creating a solid. So now I will be jumping towards some practical examples. So let's say I have, first of all, I would like to make this as a top view and have the visual style as 2D wireframe. Now let's say I have a line like this. I want to extract the closed portion as a region and then extrude it. So for that, I cannot use the region command, but there's a command called boundary. Boundary is just like a hatch. So if you say the object type is a region and pick a point inside, this object, the closed entity inside will be identified as a region and it will be created. Now, if you want to extrude it, you can give a value, height of extrusion 10 units. Now you see that if you move this object, the original profile will be there. The only thing is that the region is extracted from the closed loop. Now let me give you another example. If you have a circle and let's say if you have some profile like this. Now you go for a boundary option, pick a point and select this. See, the region is created from the closed loop. Now if you extrude this object, you can see that the profile remains where it was and the region is created separately and the object is extruded. So boundary option is another very interesting option that we use while we are working in a particular project. So we will be using it regularly, the boundary option. Now, another thing is that, so in extrude, there are various other options. So if I have a circle, if I go with an extrude, so there is an option called taper angle. There's an option called path and there's an option called direction. So let's take with the direction. Direction we have done. Let's say start point of the extrusion is this and I want to extrude this object in this direction. So extrude direction is parallel to the plane of sweep curve, so it is not working. So in this case, if I would have the direction in the z axis, the object would have been created. So we'll be talking about more application of the direction, how the direction will matter. So it has to be an inclined line parallel to the x axis or xy plane and inclined to the xy. Now let us take an example. If I want to explain you the direction option, there is a circle. There is a line which is at an angle of 0 degree with the x-axis but 45 degree with the xy plane. So how do we do with the polar coordinate system? The line is 10 units length, angle with the x-axis is 0 and angle with the xy plane is 45 degree. So this is inclined to the xy plane. Now I want to extrude this particular circle with a in this direction. Now let's do it. Extrude. Now we have this object. I have to create a region, or for circle I don't require actually. So extrude, select the object. Okay, the direction, the start point is this and the end point is somewhere here. So you can see that how the circle is extruded in the direction mentioned by me. The next option in the extrusion is the taper angle. Now, let's say if I have a circle of radius of, let's say, 5 units. Now, let me copy this circle to give you the example. Now, if I'll make these two circles a region, I am extruding this circle at a height of 10 units with zero tapering. Tapering means I am tapering the faces with the z-axis, but here the angle is 0 degree. Now, if I want to have a taper angle of 10 degree with the z-axis and the height is same, so go with the extrude option, select the object, so go with the extrude option, select the object, and then go for the taper angle. Now this taper angle is the angle that the solid will make, the faces of the solid will make with the z-axis. For example, it is 15 degree angle, and the height that you are giving is, let's say, 5 units. Now you can see that the faces of this particular extrusion is at an angle specified by the user, that is 15 degree. Now let's take an example of a, so let me go with the shaded and 2D wireframe option and go to the 3D orbit and make it parallel. Okay. Now let's say if I have, so let me again bring back the shaded option. I have a rectangle. So here I go with extrude. So I'm not giving a height, I'm giving a taper angle of 15 degree, and height now I'll be given as 10. So you can see it is taper. Now let's take a custom geometry. Let's say if I have a circle like this, go for a boundary option, select it, extrude. Now if I directly extrude the taper angle of 0, so but I want a taper angle, let's say, of 15 degree at an height of, let's say, 10 units. So the faces will be tapering from the curved as well as the flat surface. So this is the utility of taper angle in AutoCAD 3. Now let me tell you one particular option that we have used in 2D, that is a polyline. Now let's say if I have a polyline and if I want to make the polyline in the z-axis, this polyline will not go to z-axis because this polyline is a polyline which is only applicable in the 2D axis. It will not go into the z-axis. You only have it in the x and y axis. But now let's say, but it is a single object. If I want to create a 3D polyline, the command is 3p. Now this is very interesting. Now you have a 3p command. Now let's say this polyline can go in any axis that you want to go. Now, since this is the polyline that it can go at any axis, you can utilize this for the next command called the extrude by path. Now let's say if I have a polyline which is going straight first, a 3D polyline which is going straight, let's say you can see the length, it's 68 and then coming down and here. Now if I create a circle here, make it a region, rather than extruding this circle in direction or in taper angle, I select the option called path. So I have to select a path which is perpendicular to this profile. So you can see this path is perpendicular to this profile. So if I select this circle will be extruded in the path. Let me give another example. You have a rectangle. I put a cut over here in a rectangle, let's say here, and I create a boundary region from this particular point. Just place this region at the tip of this polyline, right? Just move it, 3D polyline, and then extrude, and use the option, select the region, path. You can see that this object will be extruded along the path. So this way you can create a lot of features like the profile features of the columns, of girders, and then a lot of things, and let's say door frame you can create. So we'll be using this extrude by path in a bigger way. So the extrusion command is basically extruding an object in Z axis with a. So for an extrusion you require a profile, you require height, path, direction, or taper angle. So this was extrusion. So we will be doing more of extrusion later in this session. Next is basically the revolve. Now you have done the revolve option in the surface. Now let us do it in the solid. Now let's get the 2D wireframe and the top activated. So you have let's say an arc, and here you have this feature. Now to revolve this particular feature in a particular axis, so for revolve you need a region, closed region. But if you revolve an arc, it will be a surface, but you need a region to revolve. So if you revolve a region, it will be a solid revolve. So revolve command is for the solid. It will ask you to select the region. So for that you need to create a region. So reg is the command. Create a region. And then if you shade it, you will find that the region is created. Go with the revolve command, rev. Select the object to revolve. Select the object to revolve. So you have selected, press enter. Now you have got options. Start point of define axis by point. So this is the axis that you're defining, and then angle of revolution. So if you say 180 degree, the object will be revolved at an angle of 180 degree. So similarly, you find there are other options in the revolve tool, like the start angle. So if you define the axis, it will say what is the start angle. So if you say start angle, it as 90 degree, and you end the angle of revolution. If you say it is 180 degree, it will create a revolve profile starting from 90 degree to 180 degree. So this is a revolve option. Now you can always go for the 3D orbit to look into it. Now in the 3D orbit, one feature I am talking about is the visual styles. You can have in different visual styles. You can check with all the visual style. And then there is something called continuous revolving. So here we can go with the visual aids. There are uses icon, grids, and other thing. And then okay, in the other navigation mode, there is an option called continuous orbit. So if you just click it, it will keep on revolving in continuously. So if you have something that you want to see in the space, you can always use a continuous orbit. So you can go here now, go to the 2D wireframe, go to the top, and let's create more revolve feature. Now let's say if I want to create a, so we'll be doing more tools in Revolve. Let's say if I create a feature like this. So now let's see how the Revolve will create. So for this, I have to create a region either by the boundary command or region command. Let's say I have this axis here. So I want to create a revolve with this region and this axis. Next, I want to create the axis here. So there are two options that I'm going to check. REV select. So here I can select the axis by object. So I can select this object. So this will become the axis of revolution, and the angle of revolution I can have it at 90 degrees. Similarly, I can use the revolve command, select it. Now if it says I want the x-axis to be the axis of revolution. Now what will happen if I say x-axis? It's very interesting. So let's say if I have the y-axis, so if I take y-axis, the object will revolve along the y-axis. So it will take the y-axis as the axis of revolution. Similarly, if you take x-axis, it will take x-axis as the axis of revolution. So now if you say revolve and say object, so you can select this object. So this object will revolve in this particular axis. So again, you can go with the shade option, 3D orbit, and you can check it how it happens. Now next, after the revolve option, we will be doing sweep and loft. Quickly, we will be taking these tools and then I will be teaching you the Boolean tools and ending the session. And the next session, I would be taking some practical examples. So, the sweep and the loft. Sweep and the loft are two tools which are created or which are used to create 3D solids out of cross sections and out of paths. Give you an example. Sweep means that if any solid is created from a profile in a particular path, then that solid is a sweep solid. So let's take an example. If I have a circle, now we have done extrude by path, but in extrude by path, the path has to be in perpendicular axis. Now let's say I have a circular region. I create a region, and then I have an arc. Let's say create an arc. Typical examples I will be giving, and then we will be doing some kind of so I do an arc with let's say center of the arc, and let's say I create an arc like this. Now let's say here I want that the circle should sweep the arc and create a solid. That means the cross section of this particular arc should be a circular shape. So here I go with the sweep option, select the object to sweep, I select this and press enter, and here I will be having the sweep path. So here I can see that the circle jumps to the start point, create a profile over here, and then creates a surface, create a solid. So this is a 3D solid. So if you go for a mask property, it will be having a mask property. Okay, the volume is given. So let's take some more examples. So let's say if I have a circle, let me trim this. Let me have an offset. I have a boundary. I create a region from here. Right. Now shade it. Now I want to have this particular profile sweep in this arc. So I'll go with the sweep option here. Select this, enter, and this is the path. Now you can see that this particular shape is created. This can be a roof, this can be any structure that I would can go. Let us take an example of a cross section of a bridge, or a, let's say I want to have a bridge profile at this particular, or a road profile at this particular. This is the alignment of the road. So let's say if the road is somewhat, I'm not having a very exact kind of profile. Let's say this is the profile of a two-lane road. Let's say, so this is a divider here, the median, and so what I will be doing is I would be excluding this and then later on joining. So I mirror this particular line, not selecting this one. So this is something, the profile that I would be looking forward for, let's say, and then I'll be creating a region out of it. So I can trim it. I can create a region by the region command or the boundary command. Let's say I'll be using the boundary command. So let's say I have this boundary command. So now it says specify a point. So this is fine. So now if you shade it here, now if you say sweep, select this object, select this path. So select this object that you want to sweep, select the path. You can see that the object is swept, but the alignment is at the bottom. Now we can have different settings over here. Now if I go for a sweep option, this is an object that I'm going to sweep, and then I can have the base point, the scale, the twist, and the alignment. So we will be doing this one by one. Now let's say if I want to have this object, the region, and the path is this, but I want to make this perpendicular to this particular profile. So here I go for an alignment, align sweep object perpendicular to the path. Before sweep I say yes, and now select the path, and you can see that the profile becomes perpendicular and the two lanes are visible. Similarly, if you want to have, now if you are sweeping this object, you select this sweep, and let's say go for the alignment. So what is happening, once you sweep it, the object is aligned at the midpoint. So the midpoint of this profile is aligning with the arc, and half of it is here and half of it here. Now if I want to sweep this particular profile, let's say I select this, and I want to have the base point, I want to have this point sweep at this particular arc, and the entire section moves inside. So I change the base point to this particular point, select the sweep path, and you can see that the point has moved inside and the sweep is taken from the outer corner. So this is the base point option of the sweep. The next is, let's say if I have a circle, now I select this object and there's a scale option. So if I want to increase the scale twice, so you can see that the circle is increasing 2 times at the end. So this is a sweep that is created with the scale option. That means when it is sweeping, the algorithm reads to the endpoint and it becomes twice the size it was there in the start point. So here I can have, let's say, a rectangle, and let's say I go for a sweep, select it, and I say scale, and here I give the scale factor as 0.5 and select the path. So the object will be scaled half at the end. So this is way. Now you can see that a ramp-like structure is created. So there are a lot of applications would be there. Now if you look into the front view of it, so it is scaling uniformly and it is getting half size when it goes to the endpoint. So again, so there are a lot of good applications in 3D. So now let's go with some more sweep option. One more is left. Let's say if I have an arc. So now let's go with the 2D polyline. Let's say if I have a polyline, right? I explode it. I have a fillet of radius 10 at the edge. So I think radius 10 is too much. So radius 2 I take. Okay. And then I join to make it a single path. So here I go with a circle. Let's say dia is 1 unit. So if I have a sweep and select the object to sweep and the path, and before that I go for a twist angle, and let's say enter twist angle or allow banking for a non-linear planar sweep. So twist angle is, let's say, 5 degree. Now what will happen is the circle, the object will twist. Now 5 degree is less, so let's give some twisting angle greater than 360 degree, or if I give 360 degree as an angle, now you see what will happen. So twist angle, let's say if I give 360 degree, so the object will twist. So you can see if you shade it, the meshes will twist, or if I give more value to the circle, let's say 1. So we have a sweep, select the object to sweep, take a path and say twist angle is, let's say, 1050, sweep path. So the twist would be basically depending upon how much knurling that I have. Now to see the twist happening, I take a rectangle. So I go with sweep because circle, the twist is not so valid. So I have the sweep path. So before that I have a twist of 360 degree, let's say. So I select this angle of 360 degree, press enter, select the sweep path. Now I can see that this particular section has been twisted. So you can try with various sections and you will understand the reason why twist is done. So now, so after doing the, let me erase this, go to the top. The next option is the loft. So as you have done the sweep option, the loft is similar to the sweep option, but it is in a different concept. Let us first of all revise the sweep option. So if we were doing a rectangle sweep, at least the twist option. So we have this sweep, select the twist option, let's say 360-degree twist, the path, the object get twisted. So you can have the shaded portion on, and you can see that how the twisting is done. So this is the uh, sweep option that we have discussed. Now the next we will be talking about the loft option. So loft is basically a command that is used to create a solid from cross section. Now let's imagine that you have a circle and you have got multiple circles inside in a XY plane. Let's move this circle. So we will be having some practical examples with the loft later on. So now if you want to create surface, not a surface in fact, 3D solid from these three cross sections, then we should go for loft. So to create a region of all of them, so go for a loft, select the cross section first, second, and the third. Now you can see that beautiful 3D lofted object is created. There are several options. We can use them later on when we'll be doing some of the practical approaches. But here you need to understand the difference between. Now there are various grips are developed. Like for example, if you click any of them, there are various options. You can try like the position G0, G1, curvature G2. So you can have different. So you can have a draft angle, you know. So you can go with different kind of curve sections, bulginess that you can have in the loft section. So coming back to it, the loft section is created. So if I want to have the loft, cross section 1, 2, 3, from different cross section, press enter and press enter to finish it. From different types of cross section in a particular axis or a particular direction. So we'll be talking more about it in some of the uh, process when we'll be doing in further sessions. But so this is the loft option because I wanted to tell the difference between loft and sweep is basically a command that creates a solid of a cross section along a path, but loft is basically created for the cross sections. A lot of cross sections are there. So it be, and then from the cross section a solid surface is created. A solid is created. Okay. Now that next thing is that the press pull. Now the press pull tool is something that create a region. So if you have a press pull tool, so you can press it, select any of the bounding area and pull it. So this is the press pull tool. So if you have a now if you are using a press pull tool, you can select any surface and pull them and press them and pull them. So this is the press pull tool that you can use in 3D modeling. Now coming to the next set of commands that are used while we are working in 3D modeling. So these set of commands are the union, subtract, intersect. And then we will be doing certain commands that will be helping you to create some objects in 3D space. So let's do that. First of all, union. So union is, let's start it from the basic concepts in the region. So let's say, then we will go to the solid. Let's say I have got two rectangles, one and another is 2. So I have created these two rectangles in two regions. Now you can see if you shade it, you can see. Similarly, I have got two solids of this rectangle. The second one I extrude, and the previous one I keep it without extruding. Now if I do a union command, this is a Boolean operation. So if I select these two regions, these two regions will become a one region, and then I can extrude it. I can press pull it and make it a extrusion. Now these two solids are created, but I want to union it. After doing the union, these two objects will become a single object. So union is basically combining two regions to form one region, or combining two solids to become one solid. So let's take an example of a circle and a rectangle. So if I do a region of these two and make a union of this region, so this will become a single object. So when I extrude it, this will be extruded together. Similarly, if I have a rectangle and a circle with 2 points, and if I do a region, extrude them individually, and then make a union of it, the compound object of these two will be created into a single object, and this will be a single object. So union is basically uniting two surfaces or two regions or two solid to be one surface, region, or a solid. Next Boolean operation is, so I can go to the 2D plan, is the subtract. So what we do in the subtract, we have the two regions. Let's say I have a rectangle and I have a circle. Now here, let's say I do a region, go for the shade option. Now if I subtract, this is the rectangle and circle from the rectangle, a cut will be there. Similarly, let's take an example where I copy these two objects. I go with the circle over here and just put it here. I subtract the circle from the rectangle, so a general cut will be there. Similarly, so you can see that after doing the subtraction, this object will be a single object from the region. And similarly, if I go with the extrusion of both of them and then I subtract the box, the cylinder from the box, so a hole will be created. So subtraction is basically getting the mass out of a solid object, subtracting one object from the other. In this case, it was the cylinder from the box. So this is the subtract operation. And the third operation is the intersect, where let's say we have got two regions and I would like to do an intersect option. So intersect option is basically finding out the common portion of the two objects where the common is. So it's basically a set operation theory, Boolean, union, subtract, and intersect. Now let's do it quickly and understand all the three options over here. So in the next part here, after this, we will be doing the UCS option, and then I will give you some demonstration of how to create a particular object. And then in the next session, we'll be doing about the solid editing tools and like fillet and taper and other options. Now let's go with the union operation. So union operation, if you have two solids Let's say if I have a box, if I have a cylinder, these are all solid object. Remember, it should be two solids. So if I do a union, this will be created into one object. Similarly, if I have two regions, so I have two regions created. So if I do a union, it will be into a single entity, and then I can extrude it. If I have three regions and I subtract the smaller circle from the bigger one. So first I have to subtract the object from which I'm going to subtract the bigger one, and then press enter, and then select the object that I want to subtract. So if you do a shading, you will find that the cut is there, and then you can extrude it. Again, let's say if you have a circle, you extrude it now. If I have another circle, I extrude it, and now I want to subtract the smaller circle from the smaller cylinder from the bigger cylinder. So select the bigger cylinder first, the smaller one, and then you have the subtract option. And the intersect, if I want to do the intersection here, so select both of them and the intersection will be there. Now here we have done most of the tools in the 3D solid modeling. So let's do some practical examples. So in doing this example, I would be also taking the UCS session. But before that, just give you an example of what UCS is. Now, for example, if I have a rectangle, I create a box, and I want to create a circle, extrude it backward and create a hole of it. So I have to create the circle in this space. So the UCS command basically allows me to select a face where I want to work. So again, UCS is basically user coordinate system, and if you want to sketch something, if you want to do 2D features, you have to have the XY plane. For example, now if you look into it, currently the XY plane is at the bottom. So whatever I am creating, it has been created at the bottom. For the UCS, there are various commands. So one of the command is UCS, by which you select the UCS. And then there is another command called UCS manager. And there is another command called UCS icon. So first thing that we'll be doing is the UCS icon. So if the UCS icon basically changes the visibility of and the properties of the UCS icon. For example, if I'm switching it off, I can do it from here also, on and off, UCS icon. Now, if I want to, now you can see the UCS icon is on. Press UCS icon again. So you can put it on and off, properties. Now you can have this icon style. You can change the color. You can change the size. So now you can see it is having something different properties. So UCS icon is dedicated to the change of property and visibility of the UCS icon. So I go to the UCS icon, I take the 3D and increase the line size. That's good. So now other thing is that if you want to do this from the ribbon, so there are a bunch of tools over here, and apart from that you can also save the UCS. So you can have named UCS. We will be talking now about it, but before that, let's say I want to create a circle in this face of the solid. extrude it and subtract it from the solid, this box. So for that, I will go with the UCS option, and then I will be just going with the first option, changing the origin, change the X here, and change the Y here. Now what has happened is the XY is in the face of this particular box. I will change, I'll create a circle over here, create a region here, and let's say I will go for an extrude, and I'll extrude a bit into the half. Now if I want to subtract this, so if you look into it, the object is subtract. Now let us take another example where I want to change my UCS over here. Now what happened when I changed my UCS over here in this particular phase? The origin has moved to the point. If you look into the origin, if you can test the origin, see the origin is over here. Now if you want the UCS back to its default position, so you can always go for UCS command and go for W option. You can also have these options from here. If you check it over here, UCS icon properties, UCS. So same UCS command you can invoke from here. Then this is the UCS name UCS. This is a UCS world. So UCS world is the default position of the UCS. And then now if you want to change this UCS into this phase, so you can have various options like UCS. You can have the option called phase option. So if you select this phase over here, that will ask you X flip and Y flip. So if you do X flip, the X, now you can see the Y axis is flipping in the X axis, along the X axis. So the direction of the Y changes, and according to the thumb rule, the Z axis is changing its direction. Now let's say if I do a Y flip, so the X, again you can see the Z axis is changing its direction. So let me keep the X in this direction, Y and Z in this direction. Press enter to accept. So now if you create something, you can, if you create a circle again, it will be created in this. Now if you want to create a cut inside, you have to go negative Z. So I would go for minus 10. So it is cutting through. Minus 10 is huge. So you can go for a subtract. It will cut the hole through. So how do I go subtract? Subtract, select object this box, and this cylinder is the another one. So you can see that if you shade with the shade tool, it is cutting through. So next is okay. So again, to know the UCS better, so let me have more options of the UCS. So let me go to the UCS world because that's what the default position is. So I have this rectangle. I extrude this rectangle up, and let's say if I want to create another, I want to go for UCS, and I'm using the option called, let's say, the Z axis, or I can have the various option, but I have taught you phased. Now you will be learning about X, Y, Z and axis. Now let's say if I have the X axis option, for that I would like that the UCS should be moved into this and have this face here. You can understand it better. Now if I rotate the tripod in the X axis, the Y will rotate and the Z will move up. So it's just rotating the tripod in the X axis. So now see what happens if you say UCS and X as the option. So what it is doing, it is rotating the tripod, keeping the X axis constant. So now in this case, if you say X axis, the rotation is 90 degree about its X axis. So now you can see the Y has come down and the Z has. Then now the working plane is XY, again the horizontal. So if you want to basically go for X axis and then if you go for 90 degree, now you can see the working plane is at this face. Now if you want this as the working plane, so you have to make it X and Y. So let's say you go with UCS uh, UCS and you say y-axis. Now if you look into it, if you say y-axis and if you say 90 degree, so this particular face becomes the working plane. So if you want to create something, you can create. So again, this was a situation prior to rotation. So I want to rotate this ZX along the y-axis. So here the Z will be here and the X will go in this plane. So XY plane is the working plane. So UCS Y and y-axis is 90 degrees. So the XY plane is now this particular face. Now certain times, let's say if I want to, I know the Z axis and I want to have the XY plane according to the Z axis. So here we have the UCS and here we are saying that the UCS would be as such that the Z axis starts from here and this is the direction. So what will happen in the due course, if you have this as the Z axis, press enter. So this will become the XY plane. So if you want to make this as a XY plane, put this as a Z axis. So let's try with it. UCS. So we know that for this plane, the Z axis is this one, the origin and here. Now you can see. So now you can save this positions of the UCS and then recall it and use it in your drawing or in your project. So how do I do it? Now let me put it at UCS world and let me change the UCS from time to time. Let's say if I have a face option and I want to save this UCS as a particular name. So here there is an option called settings. So here you have the name UCS. So orthographic settings and a lot of things are there. So just what I would suggest is, first of all, go to the UCS manager, UCS option. There's a named option, enter an option. So restore, save. So you want to save this particular UCS location as 1. So if you have gone to UCS world and you want that particular UCS location as the origin and as the XY to be restored. So now from this drop down list you can get it. Now let's see if I make this UCS face here. I want to save this UCS, so I go to UCS command and then I say name UCS and save this UCS and make it 2. Now I have got 2 locations, 1 and 2. So if I want to work at this face, I will select the 2 option. If I want to work in this face, I will select the 1 option. If I want to work in the top face, so I have to save this. Let's say I go here and save this, save like UCS, named option, save this UCS, let's say 3. Now you have got 3 UCS saved. So go to UCS world, 1, so you can work in this. So this is your working plane. Again, this is 2. So this is your working plane. You can now do a lot of things. And this is 3. So this is the concept of UCS. And you can go with the UCS manager option and see that these UCS can be also set current and can be used at various times in the 3D modeling. So let's do some kind of practice with this particular example, and then I will finish off the session today. And in the next session I will be talking about some editing tools, of solid editing tools, some texturing tools and lighting and go towards rendering. So here, let's say, so now I have this small layout of a room where I have a window and I have a door and a wall. So for that, first of all, I will create a layer. Let's say I will create a layer of a 3D wall. I'll create a layer of a 3D door, and I'll be creating a layer of 3D window. I'll tell you why. So we'll be doing some more examples of how. So let's be put the window 3D window color different, 3D wall something different, let's say, and the 3D door, let me keep it a different color. Now since you have known about the layers also, so I think you won't be having a problem. Now this object is created in the zero layer. Now here, let's say, if I want to create a wall, how do I do? Let's say I keep this sketch over here and I don't have the elevation right now, just to see how it works. So let's say if I have the layer, first of all, make the 3D wall layer current, and go for a boundary option. So here I have this boundary, this and this boundary. Let me have this boundary, the region. So if you go for a shaded option, you would see that this is a region. Now the height of this wall would be somewhat around 10 feet, right? So I created this two wall sections, but since there is a window in this section, so I create another, let's say, rectangle, make a region of it, extrude it, and put it till here. So now what I will do is go for a hide option. I will make this union so that it is a part of the building. Now go to the 2D wireframe, take this rectangle again. Now move this rectangle to the sill level, that is the 3 feet. So if I have this rectangle created, I will move this, select this rectangle, take the base point and move it in the z axis at the rate 0, 0, 3 feet. Now let's say the height of the window opening is 4 feet. So I'll take this to the height of 4 feet. Now I will subtract the window opening from the wall, and if you look into the hidden option, the so here you can see that the how the wall openings are created. Now we will be doing a door opening also. So I just change it to the 3D basic so that I can use the layers from here. I can also do it in the 3D modeling workspace. So I'm just switching it off. So now let's say if I have a rectangle, I create a rectangle for the window. Now I move this rectangle at 7 feet where the door opening will end. So I say at the rate 0, 0, 7 feet, and then extrude this rectangle 3 feet high and get a union of this particular. So here you have the door opening created. Now if I want to put another opening at this face. So I'll go with UCS. I'll select the face here. Now, so I have this UCS and face. Now, other thing that you need to understand about UCS is if you want to work in this, if you want to see this plane parallel to the screen, there's a command called plan. So in the plan, the screen where the UCS is parallel, the face with which the UCS is parallel, is now parallel to the view. Now let's say if you create a rectangle, let's say for the window opening, so I say at the rate 3 feet comma 4 feet, create a region of it and then place it somewhere at the mid, move it 3 feet to the sill level, and then you can basically extrude this in the Z axis, let's say minus 9 inches, and then subtract it from here. This is how you create a building with openings. So in the next sessions, I will be talking about how you can basically create doors and windows out of it. But this is the start. So go to plan. If you give the plan command, it will take parallel to the UCS. So here the UCS is XY. So you go to the parallel to it. But if you want to go to the UCS world, so now if you say plan, it will move parallel to XY. So you say 2D wireframe, and here you can basically say UCS is world already, and you can place the UCS at UCS icon at origin. So zoom on. So UCS is placed at origin. Now, so this is how you create different 3D models with the help of union, subtract, and extrude. There are a lot of other options. So if you want to create a column, let's say one more example, if I have a column, let's say I create more layers. So I go to the layer property, I create a column, I create a beam, I'll create two particular layers, 3D column and 3D beam. So let me give it a color so that I am able to understand it, and then I'll create a footing kind of thing. So it's very simple. Now let's say here you have a column, let's say at the rate. So I put the column layer as current. So I have a 9-inch by 18-inch column. So I copy this column at 10 feet distance, let's say. So if I do a region and extrude this, both of them, select both of them, and I extrude it at 10 feet. So this column will be generated. Now if I want a beam here, so I can have two options. I can first, I can place the UCS at the top face over here, create a rectangle or create a line, take the section of the, I can do an offset here because the UCS is here, otherwise I could not have done it. Create the profile of the beam, make it a region, and now extrude this beam to the depth, let's say minus 15 inches. Now you can have a union of it so that it it becomes a single entity. So if you want a footing over here with a taper, so here you can go with the, again I come back here, I'm just doing an undo operation. First of all, let's say my footing is 4 feet, so that it has a distance of 3 feet. Let's say I'm doing an offset. So let me undo it so that it is only the rectangle is there. So I have to remove the region, so I can explode the region, it will become a rectangle, that's not an issue. So let's say if I take a footing at let's say 3 feet offset from both of them, I can do a fillet. I'm just creating a footing to give you an example of how then I can do a example from a base plate. So here it is a curve option, so I have to have the fillet radius 0, so I can go with the multiple option and quickly I do a fillet here. Okay, so now let's say I create a region of this part and extrude it, let's say minus 18 inches. So I can have this, I can have the region over here, and similarly let's say if I want to have the I have a region over here. I'll give an example how we do it. I copy this object here. Let's say if I want to extrude it, but I will be having a taper angle, let's say. So I can have a tapered kind of footing. Let's say taper angle is 15 degree and the height is, or I can have it more than. So I can have the taper angle, the Z axis, because this should be more than, let's say I'm having 120 degree and the height is, let's say, minus 2 feet. So I think the angle of taper has specified height of extrusion. So I have to have a taper angle and the height of extrusion I have to take along the direction. So here if I do the taper and then if I get my column, now I can extrude it. So we'll be doing an example where the taper angle I may be knowing, and then so the taper angle is the angle that the face makes with the Z axis. So here you can see the columns are there. So there's a footing. So we can have, let's say, we have a footing with the taper option of the extrusion. So there are various options. Let's suppose if you want to create eye sections, and you can try. Now let's say the last example that I want to give is of the staircase. And before that, I would like to also give you one command, that is a rotate 3D, how 3D rotate can be done, how it is different from the 2D rotate. So we can do this command rotate 3D and mirror 3D so that you can do some objects for the project. So I'm going back to the 3D modeling concept where we have these commands already there. 3D modeling workspace. So here we have these commands. So you can see in the solid Okay, you have this taper faces, you have this fillet edges. So okay, this will be covered in the next session. So let's talk about two commands called the rotate 3D and the mirror 3D command. So these are the commands which, so you have the layer option here in the advanced 3D modeling workspace. Okay, so how it works. Now if you have a rectangle and if you want to rotate this, so you have a rotate, so it rotates in a point. But if you want to rotate this in an axis, let's say between these 2 points, you have to take this as an axis and the angle anti-clockwise. So the command is rotate 3D, ROTATE 3D. Select the object that you want to rotate. So here I would just talk about only one option, the 2 point, the first point and the second point. Put your thumb around the axis that you have defined and the rest of the finger will show the angle. So if I say 90 degree, it will stand up. So now rotate 3D is rotating an object along a particular axis. Now let's say if I want to rotate this object in this particular axis. So I have this rotate 3D and select this object. So this is first point, second point and 90 degrees. So now it is going anti-clockwise. Now you can see if you put your thumb along the axis, the fingers will show you the rotation angle, positive direction of the rotation angle. So here you can see that if you have some objects, you can rotate them in 3D and then start working into it. Or if you have any object which is created in plan, let's say this is the object. You do a region, you do a subtraction. So now if you look into this, if you rotate 3D, select this object, and if you want to rotate this particular profile in between these 2 points and have 90 degree, now this is rotated and now you can extrude this at a particular axis. Now why I am telling you, because I will be using this command for the staircase. So for example, I will be creating a elevation of the staircase. Let's say the riser of the staircase is 6 inches and the tread is, let's say 12 inches. So what I'm doing is I'm just copying this profile to a particular flight. So here we have, let's say, and let's say here we have the landing at 3 feet, 2 feet more. So this is 3 feet, and then the base slab is here, let's say 6 inches. And let's say I draw a soffit line here. So I have a 6 inches base slab, and I'm joining this along with this. Okay, and now what I can do is I can join this with this. Okay, so here I have this. I can do a boundary region. So first of all, I have to look into the layers. Now here I can rotate 3D, select this point and the x-axis, probably this one, 2 point and 90 degree. Now what you can do is you can select this region and give 3 feet as the height. So here you have the staircase created. Now you'll be doing the railings. I'll teach you how to do the railings also. So here you have this plane. Put the UCS here. Select, create a circle. Let's say dia 2 inches. And the height of the post is 3 feet. See? Now what you can do is you can copy this, taking this base point, all the threads, and you can also copy it. Now you can join this points with the 3D polyline 3p, because 2D polyline will not be joining. So I can have this 2, 3, or directly you can join them till here, or you can till this particular point, and then you can have a straight line. So let me take it again. 3p, first point, and then the last point is at this particular staircase where the last flight is being there, and then you have, this is the profile of the 3D polyline. Now let's say if you have a pipe section over here, so you can have this 3D polyline a bit stretched, or you don't require it. So you can keep another 3D 3D object here, let's say somewhere here, or you can pull it down, so that you can increase the handrail. You can just put it there. Okay, no issues. So if you have a circle which is a cross section of the, you can put it here and use the sweep option, select the circle, select this part, the handrail will be developed. So this is how you create the handrails. So just try with the handrails, you can do it, and the staircase. Similarly, if you want to take the path of the staircase, so 3D orbit, so we'll be doing some reinforcement detail also. So here you can go with parallel and zoom it. So now let's say the next stair starts from this particular face. So you can have a UCS face, put your UCS here, and then you can start developing the profile from this particular point. Let's say 6 inches, and then you have 12 inches. So let's say this is the profile that you have 12 inches, and then you have 6 inches, and then you have 12 inches. Then you can come back 6 inches, and then let's say you want to join it with this particular point, and then you want to have a boundary option. Pick a region, click the boundary, and then extrude it to this particular point. Now you can union it together. So union these two staircases together so that they become a single one. So this is how you create staircases in 3D modeling. So the last thing that I would like to discuss in this session is creating a basic reinforcement detail in a column. Let's see how it works. So let's take an example. I'll take a new file. So I go to metric and take a new file. So I have maps, let's say, okay, a rectangle, let's say 230 into, let's say 3, say rectangle 300 into 300. So you have a cover of 25 mm. Let's say if you have circle of dia of 16 mm. So what I will be doing is I'll be just covering a basic how the reinforcement can be done. So let's say if I have this, I'm just taking one face. So just copying the set point, moving to the perpendicular here, and mirroring this option so that I can have the 3 over here, and let's say I have the same 3 at this particular point. Let's say this is a column section reinforcement that I want to do with the rebar. So let's create a 3D view of it. So go to the view. So you can always have the workspace changed. Go to the 3D basics or 3D modeling, and let's say I take the view cube on and here. Now let's say first of all I would create the formwork, that is I'll create the column, or I will create the column, let's say 3000, and here what I would suggest is I would be creating I would like to have the stirrups first. Let's say the stirrups are diameter 8, and you can have a sweep option, and the object, the path is this. So you have the stirrups, just move this stirrup, let's say 100 mm up, and then you can array the stirrups, and you can have a rectangular array here in which the columns is 1, rows is 1, and the number of levels you can increase it with a distance, let's say 200 mm. Now okay, now the number of levels that you want to give is 12, or you can increase the numbers, let's say by pulling this. So this is the stirrups that are created, and eventually if you want to create the rebars, so one of the option is to directly extrude it, the rebars, and then take a path of it and sweep it and give a bending curve over here. The other thing is that what you can do is you want to have the profile of it, so go with the UCS and change the UCS X and Y here, and now rotate the UCS. Now you have this UCS option, go with the X axis and rotate it 90 degrees so that the UCS become XY like this. Now what you can do is you can have the plan option. Now from the you can create a polyline which will be extending beyond here. So now you can see that the polyline is created as a path of this particular. So now you can have a sweep option, select this and take the path option as this path, so the rebars will be having some curve. So this is the way you create the rebar, or then if you want to create you can erase this. So this is how the reinforcement modeling can be done in AutoCAD. So with this help you can basically show the reinforcement, how the reinforcement is done, and other options I will be teaching you in 3D how we can make it. So we are just ending the session. Welcome to the week 12 session for 3D visualization for the course of AutoCAD Essential for Civil Engineers. So in this session you will be learning about the topics like the solid editing, modifying solids or editing solids, and rendering. So these are some of the very important topics that will be used while you are doing solid modeling. And let's see what are the topics that we will be discussing. So we will be talking about how to edit the existing model, like extrude the face, taper face, move face, and other thing. And then apart from that, there are other tools for solid editing, like the body editing and the edge editing. We will be also discussing over here. And regarding generating a section by defining a section plane, how we can create a section plane and define a dynamic section or a live section in a 3D model. Then generating drawing views of solid model. For example, if you have got a 3D model, how you can develop a section view that is a drawing view of the solid model by using the solve view command. Next, we will be also doing we have already done the mask property, so we will be also taking care of the mask property, understand about what mask property is all about. And then we will be doing filleting the solid model, chamfering the solid model, and then we will be also doing up with mirroring the solid model, arraying it, aligning the solid model, slicing the solid model, then understanding the concept of rendering, how we can assign materials to 3D objects, and then we'll be talking about the basic rendering techniques. And then going forward, we will be talking about how the lights can be added to a 3D model or a scene, and then how cameras can be used, and then how we can create animation out of it. So these are the topics that will be discussed here, along with a project that we will be doing here to illustrate the application of all these tools. Now let's start with the first topic, which is the editing of the solids. So first of all, make sure that you are into a 3D modeling or a 3D basic workspace. So here, let's say if I have a rectangle, I have a solid object. Let's say I created it by extrusion that you have learned in the previous session. So just I would like to change it to a conceptual visual style. Now here, so you can do a 3D orbit and then you can rotate it and see the faces. So this 3D object, solid object, is having certain sub-object, like the faces you are having. So it is having 1, 2, 3, 4, 5, 6. So 4 faces, and the side and the top and the bottom. We can edit these faces, we can edit the edges, and we can edit the body of this particular solid. So there are certain commands that we will be doing, like the solid editing commands, by which we can edit this solid. So let's start with the solid editing set of commands that we will be doing here. So the command is solid edit, and the first set of command for the solid editing is face editing. So if we want to edit a face, for example, there is a face over here. So what are the options that there? We can extrude a face, we can move a face, we can rotate a face, offset, taper, delete, copy, color, material, undo, etc. So extruding a face. For example, if I select the extrude option, I can select a face. For example, I select this face, so it says one face found. And then if I want to extrude this face, let's say if I want to have a height of extrusion, let's say if I go with 20 units, so, and it asks for the taper angle, let's say 0. See, the object is extruded 20 units. Now let's check the height, actually what is the height of it. So with the snapping over here, there is a 3D snapping also on. You can have the 3D snapping on, where other option is also there, like perpendicular vertex point, but the normal snapping will also work over here. So let's put the endpoint on. So let's say if I want to measure the distance, what is the height? Let's say it is 627. So let's have some bigger value for the solid edit face. So now in the face, I want to extrude the face. So I select this face and I want to extrude at the height of, let's say 100 units, or let's say 300 units. So, and the taper angle is 0. So the object increases its height from the face. Similarly, if I select this face, extrude, and select this face, and if I want to increase the height, so I will say height of extrusion at say 500 units. So, and the taper angle is 0. The face extrudes and the object is resized. Similarly, if I want to extrude this face with a taper angle is basically the angle that the perpendicular face will make with the z-axis. So let's say if I do an extrusion and select this face, I have selected the top face and I want to have the height of extrusion, let's say 400. And now here I want to have the angle of taper for extrusion. So here I give 15 degree. So the face will be extruded and the faces would be tapered at the given angle, that is 15 degree from the z-axis. So here the extrusion of the face can be also done with the height as well as the taper. Now let's do more option in the face. Let's say I want to extrude this face in a particular path. The path should be perpendicular to the face. Now I want to extrude this face in path. So I create a polyline. Let's say I put the ortho on, and let's say this is the path in which I want to extrude. So I want to have my view cube over here. So click on the view cube. So here the view cube is, let us put it into the default state and go to the 3D orbit and make it parallel projection. Okay. So now you have this path. So go to the 3D modeling. There is also the option of face extrude if you find it over here. So there is an extrude face, taper face, another thing. You can select the extrude face option of the solid edit. Select the face that you want to extrude. Then you have the path option over here. Select the path, which is a polyline, and the face will be extruded at the path. So this is way you can also edit a face, extruding it in a path. Then now the next option is, we can also select it from the drop down, is a taper face. Now for this I would be having a different set of solid. Let's say if I have a rectangle and the height is, let's say, 700. So here I want to taper this face within this axis. So I want to taper this face. I want to taper this face, and I want a tapering angle from this edge, that is the perpendicular axis over here. This edge one, the vertical edge. So here I have this solid edit face taper, or I can take the option from here from the drop down. I can say taper face, select the face, and then press enter. Now it will be asking you the base point, another point along the axis of tapering. Now the axis of tapering is this edge, this is the point, and then give the taper angle. Now let's say if I want to taper 45 degree, so you can see that face tapers at 45 degree. Now let's say I do an undo, I go with the taper option, select the face, press enter, and the base point is this, the other point is this, and angle is, let's say, minus 15 degrees. So it will be tapered into the negative direction. So this is way you can basically taper the faces of the solid. Now if I want to taper two faces which are sharing the same tapering axis, for example these two faces, so I can go for the taper option, select this face and select this face. Okay, now let me make sure that I have selected the right face. So I will taper face, so select this particular face, this face, and press enter. And let's say if I have this axis 15 degree, so here you can see that the different faces have been selected. So you have to be very careful when you are selecting the taper face. So let us go with the hidden option, or I'll go with the wireframe first. Okay, so let me go with the shaded option. So that's fine. So I use taper face, select this face, and then select this face. So you have got two faces, press enter, and the taper axis is this. And let's say if you want to taper 15 degree, so the both of the faces will be tapered. This face will also taper and this will also taper. So if you see from the top view, these two faces have been tapered. So this is the tapered face option. So go to the 3D orbit, and go to the parallel view and press exit. So I'll just change it to 2D wireframe and then shaded option. Okay. So the other option in the solid edit you can write solid edit in the face is the move, rotate, offset. Three options are there. So let's check how these options will work, and then later on we will be doing copy, color and material. Now to illustrate the move option, so what does the move does? So the move, basically if you select the move option, you can select any of the face and select the base point, and you can move it at the direction that you want. For example, if I want to move this in the this is according to the UCS is the y-axis, so I want to move it at the rate 0, 400 in the y-axis. So minus 400, in fact it would be in the negative direction of the y-axis, so minus 400. So the face will move 400 in the negative direction of y-axis. Similarly, I can also select the move option from here, the move faces. I can select this particular face, let's say the top, and if I want to move this up in the z-axis, so I would say at the rate 0, 0, let's say 700 in the z-axis. So the face moves and the geometry basically flexes its shape according to the new face. But here you can see that the extrusion and move options are looking very same. Now what is basically, if we can move the face by extrusion, then what is the use of a move option? I have taken a special case. I have taken a box where I have a slot over here. It can be an opening in the window, or it can be opening in a particular solid object. So and practically when we have to look into it, let's say there is a window opening and we want to move that opening. So we will see that practical application. But let's say here we have a slot, and this slot, if I would see it in the 3D orbit, so it has 1, 2, 3, 4, 5 faces over here. And if I want to move the position of this slot, let's say in the negative x direction, that is 200 units this side, then what I should do? Then here I can select the 5 faces to move the slot. So how do I do it? So for example, I want to select the 5 faces. So for here, I go for solid edit, face, and I have a move option. Select this face, this one, this is fine. And then to select the other faces, just use the view cube tool. So then zoom in, and let's say I have selected the 5 faces of the cut. And now I want to move these 5 faces in the negative x direction. So press enter, and there's a base point over here. Let's say if you do it manually, you can move it, or you can say at the rate minus 600, 0. The entire slot will move in the x direction. So here the move option basically works. Now selecting faces. For example, I would like to share here. For example, if you select go to the select face option in the solid edit, and if you do a move operation, and if you select the edge which is common to 2 faces, 2 faces will be selected, so 2 faces form. But you want to remove this face, so you can go for remove option. The remove option is activated, and you can remove the face, and then you can move this object wherever you want. So here it is the move option. The next in the I would like to go with the delete option, and then I will go with offset and copy option, because delete option may be very useful here in the slot. So if you have a slot like this, and if you want to delete all the 5 faces, you want to remove the slot or remove the cut, so you can use the delete option over here. So here I go solid edit, face, delete. So I select the common edge, this one, common edge, this one, and just change the view cube and select this face. Now see if all the faces are selected. No, this one has to be selected, and then press enter. The face is deleted. So this is the way you can use the delete option to delete the faces in the solid model. So here I want to introduce the dynamic UCS over here. So the dynamic UCS can be put on from here. So what is a dynamic UCS? If the dynamic UCS is on, and if you want to select any face as a working plane, or if you want to change the UCS aligned to a face, let's say if I want to draw a rectangle, So I just keep my mouse over here. Now you can see the UCS is selected. Now here I can work. Click on the face in which you want to work. Create the profile. Now here the rectangle is created and I want to extrude this rectangle. So, okay. So I'll say last means the last object created, and then I want to move downward. Let's say just pull it down. So let's go with the wireframe and see how much it has gone. Okay. So this is something that another solid has been created. Now I do a subtraction. So enter and press this one. So a slot is cut over here. Now here I want to tell you the offset option. Here if you look into it, there's a through slot over here. I want to basically reduce the, let's say I take a dimension over here and it measures it around, let's say 8739. So I want to reduce each faces. I want to offset each faces by, let's say 300 units. So if I take a single face for offset, and then we will take the multiple face. So face offset. So if I select this face over here, and if I say an offset distance of 500, so it will move 500, but we can do it by move option also and by the extrude option also. So what is the relevance of doing an offset when we select a multiple face? So if I have a solid edit, face offset, and if I select multiple face, for example these two faces, and if I say, let's say I'll give more value, let's say 700, both of the faces will now requires okay. So let me do it again. Solid edit, face offset, select the face, the common face, the common edge, enter, and give a distance, let's say 700. You can see both the faces now are offsetted, right? This way you can reduce, you can offset the faces or face of a solid object. Or if you can do with single object, you can also do like solid edit, face offset, and select any individual face, and then you can give a value. Next is in the category is the copy face, and then we will be doing rotate face and the color face. So let's say if I want to have the profile of this particular face and I want to copy it, so I have to go with solid edit, face copy. So here I have this face and I can create a copy of this here. Now creating a copy will give me a profile to further use it for different purposes. So now this is a, basically if you can look into it, this is a region, and if I explode this region, it will become 2D entity. So I can use this for 2D sketching and drawing. So I can copy any faces that I want to do. So if I want to copy this face, particular face, let's say solid edit, face copy. So select it and copy it where you want. So the face is copied in this case. So then you can explode this face and create the 2D lines. So this is how you do a copy of the face. So you can do it from here also, from the solid editing panel. So you have the copy face. And the second last, and the other option of the face is the color face. So if I want to give a different color to this face, so I can always go with the color face, select the face, press enter, and select the color that you want to give. So you can have different colors to different faces. And then one tool is not there in the drop down, which is the material option. So you can give different materials to the face, right? If you know the material name, you can give the material name. So we will be doing in the rendering part in this session itself. So how we can assign different materials to different faces. So you can give a different color, but how you can assign different materials to different faces. So we will be doing it. So face, and then just I'll give a different color, and let's say I give a different color, so to make it a multicolored option. So the last option that now remains is the rotate option. So I can rotate any face at any axis. For example, if I want to rotate this face in this particular axis, so I will go for solid edit, face rotate, and I select this face, select this 2 point as an axis, and let's say I want to rotate 30 degree. So this face is rotated. Similarly, I can, if I want to rotate the upper one, this face, so solid edit, face, rotate, select this face, and then if you have these 2 points, and if you want to rotate by 30 degree. Now here the problem is because of the cut, the symmetry does not allow to rotate it. So you can now rotate the other faces. Let's say if you want to rotate this particular face at, let's say this is the axis of rotation, and if you want to rotate it in 15 degree, so it will be rotated in 15 degree. Again, you have to follow the right hand thumb rule, where the thumb is the axis of rotation and the fingers are the direction of rotation. So you can try, when you're giving the axis of rotation, put the thumb in the axis of rotation, bring your finger, fold your fingers, and the direction where the finger goes would be, all the other fingers will go, or the palm will go, is the axis of rotation. So here we finish up with the face option of the solid editing face option. Then we have the edge option. So what we can do with the edge option? So we have edge, two options are there. We can copy any edge. For example, if I want to copy this two edges, I can select them and copy them if I want it for some profile, if I want to check the length or whatever it is. If I want to color any edge to give it a discrete color, so I can select, let's say, the edge color option and select the edge option over here and give a color. Let's say a red color would go, so the edge will be red in color. So here if we have the shaded option, the color will not be shown, but if you say shade with edges, the color will be shown. So let us give different colors. Edge color, L is for the color, and select, enter, and give a different color. So you have got a different color for the edge. So let me give it again. I'll select this edge and give a different color to it. Let's say a magenta. So due to the visual graphics, probably things may not be visible. Okay, now it is visible. Two colors are visible. Now we have done the edge option. Now we will be doing the body option. Other thing about the edges, if you go to the solid editing panel over here, so we have got this color and copy edges. There is another option called extract edges. So what does it does it this command do? If you select the object, it will convert the entire object into a wireframe. So if you look into it, it is copied. The wireframe object is copied and the solid object remains as it was there. So let me try with this. Let's say if I move this particular object above, now you can see that the solid has been converted to a wireframe structure because it has extracted the edges and made it a wireframe structure. So this is again a very interesting command where a solid object is converted into a wireframe. Okay, so let us do with the body option, and then we will be doing the imprint also later on. So I have this solid object, and let us go with the solid edit command and go with the body option. So here in the body option, I have got imprint, separate solid, shell, clean, check, undo, exit. Now let's say if I have got two objects, which is two separate objects which are not having common edges. So what I wanted to mean is, the next command I will be doing a separate solid. So let's say if I have got these two solids, set of solids, one solid is having a common edge, and if I do a union option right now for these particular edge, it will become a single object, and also if I do a union option, it will become a single object. Now let's say if I want to separate these two objects into a different solid because they are in union, I can use the separate solid option in the body. So if I select it, the union will be broken and these two objects will be different. But here the union will not be broken because it is having a lump. So if I do a solid edit and if I do a body separate, P for separate, now you can see that the object is press enter, the object will not be separated. So with the separate solid option, you can only separate objects which are in union, but they are not having lumps. Now the other option that I would like to do with you is the shell option. Now this is a very interesting option also. Let's say if I have a circle, dia is 400, let's take the dia, and I extrude this particular circle and make it a cylinder. Let's say I make it 700 extrusion. So here I want to create a shell. I want to create a thickness into it, and I create a hollow over here. The one thing that I can do is by using the extrude option, but AutoCAD gives me a command which I can do a shell in a particular face. For example, if I want to create a shell in this face and I want to keep the face cover, I mean, I don't want the it hollow throughout, but I want the punch to be here and the thickness should be here. So let's see how it is possible. Solid edit, so body, and there is the shell option, and select a 3D solid. So it says select a 3D solid. So I selected a 3D solid, and while I am doing a shell, I want to remove only this face. So I click on this face and now give the shell thickness. So let's say the shell thickness is 30 mm, and you can see that if you press enter, double enter, the object is having thickness from all the faces. So this is the shell option that can be done. Now let's do it in the box. So I have a rectangle, let's say at the rate, let's say 700 into 300. I extruded this box and made a height of 2100. Now I want to create a shell at this face and at this face. These two faces I want to remove, and the thickness of this board or this particular shell would be, let's say, 30. So solid edit, body, and we have the shell option. So select the 3D solid, remove the faces that you want to remove while you're doing a shell, and give the thickness as 30 mm. Now you can see that the shell is done. Now here I would like to give you a small example. Suppose if I want to create racks over here, slots over here, so I can go with the face option over here, and I will do a copy option, select the face, press enter, and let's say I copy it at the distance of 500 in the Z axis. So now I can extrude this face, let's say 30 units. I can have the shell, I can have the 3D solid. So this is also one of the application when we do modeling of different kind of architectural elements. So this is the shell option with the body, and then we have the option called clean and imprint. So I will be taking this now. So here I would be talking about the option called imprint option in the body. So the imprint option in the body is used for you have this imprint option to create some extra faces or edges in the body. For example, if you have this, if I shaded this object, and if I want to separate these faces into two parts and have a kind of profile, so I go with the UCS. Let's say first of all I will use the dynamic UCS. So let's say if I have an arc, so I keep my UCS here, and okay, let me fix the UCS right here. Let's say I'll not go with the dynamic UCS right now, because now let's say if you have an arc from here to, let's say first point is this, and second you want to, let's say, or you want to draw a line. I'll take an option at a line, then we can settle down with the point. Let's say I want to, so the dynamic UCS I'll put it off because it is having a problem. So this is the dynamic UCS. So my UCS is in this particular phase. I have a line option, and let's say I have this So I am separating this face into two parts with this line. So if I go with solid edit, body and imprint. So if I select the 3D solid and select this line, remember that it should, if you are going to separate the face with the line should connect to the corner point. So now let's say if I want to select this line, that is not getting selected. So what I need to do is I need to change it to the wireframe so that it gets selected. So go to the solid edit, body, and then I have this option called imprint. Select the 3D solid, let's say for in this case this, and this is a line, and delete the source object. The source object was a line. I would say yes and press enter. Now you can see that this line is a part of this particular face. So now you can basically have the option called face extrude and select this face, and you can have it extruded at a particular axis. So let's say if I want to go for face extrude, solid edit, face extrude, select this face, and let's say if I want to extrude it at a height of, let's say, 500. So there's a tapering angle that is being shown. That is the reason. Solid edit, face extrude, select the face, and the height is, let's say, 500, and the tapering angle is 0. So now you can see that the face has been extruded and with a profile, and it has been made. So this is the option for the imprint. Let's see if I want to have a circle imprinted in the face. Solid edit. So first of all, let me take my UCS here. UCS, set it over here. Create a circle, and let's say press enter first. Create a circle here, and I want to go for an imprint. Solid edit, body. So I am imprinting the particular curve into the face. So 3D solid is this, and object is this. No, and press enter. Now I can now have this circle as one of the faces in this particular. So if I select this, and if I have an extrusion of, let's say, 500, so it will move ahead. Or if I make minus 500, it will be subtracted. So solid edit, face extruded. Now it will be subtracted minus 500. So you can see that a cut would be there. So this is the solid edit body imprint. Now moving towards, we would be doing more commands. So I'll have the plan option. The plan option will make me into the XY plane. So I would go with the 2D wireframe, select this, and I would say zoom, enter, all enter. Now the next option would be how we can rotate in 3D. Already we have done. How we can array in 3D, and how we can move in 3D we have done, but there is also some command for move in 3D. And slice is basically how you can cut the 3D object into two parts and aligning the object. So before that, these are the modification tool, but there is a fillet and chamfer option in 3D also. Now let's say if I have a rectangle here, I say 300 by 500 is the rectangle. So this rectangle is at an height. So now the UCS is in the vertical place. So I would make it UCS world. So now it is XY here. So you have this rectangle at the rate 300, 500. Now you extrude this at 700. Now I want to have a fillet in the edge of this particular 3D object. Now let's see how we can use the fillet edges option to create fillets in the edges of a 3D object. So here you can see a 3D solid. So in the 3D solid, you want to create rounds at these edges. So there is an option of in the solid tab, in the solid editing panel, you have this option called fillet edge. So select the fillet edge option and select the edge where you want to put the round. So here if I want to do a single edge over here, and if I want to give a radius, let's say, of 300 units, so it will show you and a preview of it before you do a fillet. So you can go with the radius, let's say 100 units, and then press enter. And here there's an arrow that is you can enter again to accept it. So here you have done a fillet to this particular edge. Now let's do it again. You have this fillet edge option. You want to fillet this edge. So with the radius, particular radius, you can, let's say 150 is the radius I want to give. So here, let's say if once you give the radius, and then let me change it to the side, press enter, a grip will be created. So you can use this grip to increase or decrease the size of the fillet dynamically. And then if you want to accept it, press enter. So this is how you create fillet in single edge. Now if you want to create a edge in loop, let's say, or in chain, so you go with the fillet edge option. The command is fillet edge. You can write fillet edge and select the chain option. So select an edge chain. For example, if you select this, so if you select only this edge option, edge over here, and if you click into it, so there will be a radius that you can do. So here, let's say if we give a radius, let's say 100 units, press enter. So this edge will be filleted. Or let's say if you want to go with the chain option, so fillet edge, select the chain option, and select all the edges that you want to fillet at a time, and press enter. And here you have this again, the option. So here if you basically drag it with the left mouse, you can see the fillet is happening over here, right? Or if you want to give a radius, you can give a radius of your value, whatever radius you want. So go with the radius, and let's say if I want to give a radius of 100, so it will be filleted, and then accept it. So this is the edge option, the chain option, in which you can fillet multiple edges. So this was fillet, and then there is option called chamfer, where again, let's say if you select an edge over here and select another edge of the same face. So let's say you want to have the chamfer here. If you want to have a chamfer over here, so you need to give this particular edge this, and press enter, and then you can see how the chamfer is done. So if you give a distance right now of the chamfer, let's come up with a distance first. So we have a chamfer edge option, and let me give the distance as distance 1 as 50 and distance 2 as 100, and I select an edge over here. So with this you can see that the fillet, the basic fillet is created, another edge of the same face. So you have this, if you select this one, so if you select this one, so it will be chamfered in all the edges. But if you want to chamfer it in a single edge, so you can go with the, you can undo it. You can give the command chamfer edge, select the edge. First of all, set the distance 1. Let's say distance 1 is 100 and distance 2 is 50. Select an edge that you want to chamfer. For example, if you want to chamfer this, so it asks you another edge on the same face, or press enter. Let's say if you press enter, the chamfer will be created in that particular edge that you have selected, because you are not doing a multiple chamfer. And then you have got two arrows, so you can click on any of the arrow, and then you can basically change the distance over here by double clicking it. So click on it, and then this particular distance icon will be displayed, and then you can chamfer it. So this is how you do a chamfer. But if you want to do chamfer in the multiple edges, so you have this chamfer edge, and then you can have this loop option. So first enter an option, so you can accept it, and select an edge in the loop. Let's say you can select this one, and press enter. So now you can see that but if you want to give a distance, let's say it is going, the chamfer is going throughout. So if, let's say if you want to go for a loop, that means entire edge of the face, so you can directly go to chamfer, go with the loop. First of all, select the distance. I would say 100 and 50 would be the good distance. Go for the loop, select it, press enter, enter. So it is in the loop, all the edges will be chamfered. So this is the chamfer edge option in so this is the 3D chamfer that you can do. Okay, so apart from that, so I will be also discussing about the 3D rotate option as well as 3D move. Now let's say if you have rectangle here, so I'm taking a rectangle, I'm not taking a solid right now. So if I want to rotate it with the normal tool, rotate tool 2D, so it rotates at a point. So you can see that it rotates at a point. So if you want to rotate it in an axis, so you have got two options. One is the command is the 3D rotate. Now look at this command, what 3D rotate command is all about. So here when we select the 3D rotate option, anti-clockwise angle direction, angle base is 0. The moment you select the object, press enter and select a base point, now axis tripod will be displayed. Now this shows a particular axis. This is the axis for the X, in the X axis. So you can basically drag it and you can rotate it like this. So let me, because this is a dynamic rotate that you can do. So 3D rotate, so I'll just give you more illustration. Select the object, select the base point. You see this entire axis, the green, red and the blue. So if you want to have the green one, so green axis would be the Y axis, you can see here. So keep your mouse over here. So you have picked the rotation axis. Now it says start point from where you want to start. So I want to start from here and then start about, if you can type an angle, that is fine, or you can dynamically rotate it in this particular axis. So if you want to put an angle, anti-clockwise is positive. So you go with 3D rotate option, select the object and then the base point over here. And let's say if you take the green axis, which is the Y axis, and the angle start point. So you start the rotation from here, and let's say if you want to give a 45-degree angle, so it will rotate at 45. So similarly, we can try with the other axis. So this is 3D rotate option that you can use in AutoCAD. Now after understanding the 3D rotate option, now we would be learning about the 3D mirror command, the 3D move option, the 3D array option, the align option, the slice option, and then the rendering concepts. Now let's see what the 3D mirror command is all about. So before learning the 3D mirror option, I would like to first of all go back to the 2D mirror option and see what is the difference between the 3D mirror option and the 2D mirror option. So the mirror option that we used to do in the 2D, basically here we do a mirror command and we select the object and select a mirror line. That means with 2 points the line is defined. So we have first point and second point, and then the mirror, the replica of that, the mirror image of that selected object is created on the axis line. So here one thing that is of sure is the mirror actually is, the 2D mirror is the command that is used while you are taking a line and then mirroring it. So in the 2D mirror, the only thing that you can do is to mirror an object or to create a replica of that object over at an axis, not at a plane. So at an axis means if you want to mirror this particular object that you have created. So that means using 2 points you can define an axis and you can mirror it. But let's say you have an object like this that you can see, a 3D object. Now I want to mirror. If I want to use a 2D mirror command, so if I do a mirror, so I can only mirror it in the axis, like I have done like this. So if I want to mirror it, so with the 2D option, that is the mirror tool, I can only mirror it at a particular axis like this, 2 points. But let's say if I want to mirror it using a plane, that means if I want to have the mirror, like for example, this is fine in X and Y, I can mirror it. But if I want to mirror it using a plane, XY plane or a YZ plane or an inclined plane, then how am I going to do? So in mirror 3D is the command here, or 3D mirror you can say. So here it says select object, and here you have to select a plane, not a axis. So now in 2D mirror you were supposed to select an axis, but here you are supposed to select a plane. So to select a plane by point, you need 3 points to select a plane. The origin, for the first point is the origin, second is the one axis, let's say X axis, and third is the Y axis. So 2 axis and origin will define a plane. For example, if I want to, I'm using a 3-point option here. So how do I define the plane? So it says specify first point on the mirror plane. So I first point, second point, and third point. And then now you can see that if I say no, the object will be mirrored. Now this is fine. This one I can do by normal mirror command also. I don't require a plane, but I would be only requiring 2 points. I can do the same thing. But here in the mirror 3D, if you want to have the same mirror option, you have to have a plane. And the plane can be defined by 3 points. Now let's take another example where 3D mirror or mirror 3D is the command. Now it says you can also use the XY, YZ and ZX plane. So if I want to use the XY plane, so if I say XY, XY means the plane which is horizontal, the XY. So now it says specify a point. So if I am taking the horizontal as a plane, I am saying that the plane passes through this particular point, then the mirror would be down. So the XY plane is the horizontal plane and the mirror would be down. The mirror object will be created in the downward direction. Similarly, if I say mirror 3D and if I select I have to be very particular about the command. Okay. So now if I say, let's say XY plane, and if I select the top point in the XY plane, so it will be mirror at the top. So XY plane, similarly you can see select the YZ plane, or you can select, let's say if there is a line over here and if I select the YZ plane and the plane is going through this line, it's passing through this line. So what I can do is I can go to mirror 3D and say select object and select the ZX plane here. So this, if I want this plane to be the mirror plane, so I will say ZX plane. So I select this point from where the mirror plane is going and click. So now you can see from the 3D orbit the distance between. So this line defines the ZX plane. Okay. So this one you can all, these all mirror you can do also by the mirror command. Now let's take an example over here. So I chamfer this edge. Let me check the distance. Okay, it's 7.7 units. Okay. So for chamfering, either you go for a chamfer command or a chamfer edge command, that is the chamfer 3D. So we have already done the chamfer edge command. So let's say I select this edge, chamfer edge, and I give a value, let's say distance 3 and 3, and press enter. Press enter. Now let's say if I want to create the replica of this particular model, taking this inclined plane as the mirror plane. So let's do it. Mirror 3D. So here basically the mirror 3D command will be useful. So if I select this, and here I will take the 3 point. So you have this 1, 2, and let's say 3. So so now you can see that how the object is mirrored. So I will shade it in the plane. So this is how the mirror is done. So this is basically the plane that you select while you do a mirror 3D. Similarly, there are other options like, for example, there is an option called XYZ, and there is an option called last. Last means the last, whatever last mirror plane that you have taken, and then object. Fine. So let's say if I have an object, let's say I create a rectangle at this top. So the rectangle, let's say if I want to create this rectangle at the top, let's say, so I have to use the dynamic UCS, or I can change the UCS to that particular plane. So here, let's say if I want to create a rectangle at the top of this face, so I say rectangle, and if I am using a dynamic UCS, so I have to be very careful regarding that, the plane is selected. So let me put on the dynamic UCS. So here we have the dynamic UCS. Okay, it's already on. So here we have the icon. So now it means that dynamic UCS is on. So right, you can also press F6 to put it on, as we have discussed earlier. So if you have a rectangle, and let's say I am placing my mouse over here, the work plane is selected. So now I'm just telling you the idea what I wanted to do. Let's say I put my mouse here, and let's say you have the rectangle. So now let's say with the 3D rotate, let me put the rectangle here, move it here. So the idea why I have moved it, so now if I do the mirror 3D option and select this object, then we have an option called object. So you can select arc or a 2D polyline segment. So if I select this object, the object will define the plane of mirror, and you can see that the mirror of that particular object will be done considering the object as a mirror plane. So this object, this 3D object that we have selected, is mirrored considering this object as a mirror plane. Now let's incline this object and give a inclination to the mirror plane. So 3D rotate. So select this object and take this as base point, and I want to rotate this, let's say, so the start point is this, and I want to rotate it. I think snapping goes wrong. Select it, and rotation axis, let me put this as the y axis, x axis as a rotation axis, the base point. So first of all, if when I select a 3D rotate option, so the base point is this, I bring the tripod, okay, and then I get this direction. So pick the rotation axis, start point is this, and I just put the ortho off, so that, and also the snapping off. So if I, or an angle, let's say if I want to give an angle of 45 degrees. So here, so this is 45 degrees. So this is the rotation. This is the plane that I want to have, this direction. So here, if I want to have the mirror 3D and take this object as the plane, and you can see that. So what is happening is I have to do, let's say I take a mirror of this particular. So I want to change. So I have this mirror 3D, and I go with the command and select this object as the mirror plane, and now you can see that this object will be uh, you know work as a mirror plane, and the object that you have selected got mirrored using the object as a mirror plane. So here we have this mirror plane selected by using the object option. So that's what about the mirror 3D option. Now the next option that is needed to be discussed is the moving a 3D solid. So how do you move a 3D solid? So let me get it here. So one of the way, so 3D orbit and put it in the parallel view, and you can always have the shade SHA 2D wireframe to get in the 2D wireframe. Now let's just have a rectangle. It's a 2D rectangle, and the command for the 3D move is, so you can also have the move command as the, you can as to move the object in the 3D. So you can see that here we have this tripod. Now select the base point, and so the difference is the, so once you use the 3D move and select the object, the tripod is visible. Now here you can see that the X is colored red, Y is green, and Z is blue. Now here the different planes are there. So move your cursor to the axis you want to move. Now here it snaps up. Now a line is shown in which the movement can be done. So click on the axis, just click, and then move point. Now here specify move point. So click on it, and click on the axis, and just click where the destination you want to move. So this is the 3D move. Dynamically you can do this again. So you just put your mouse on the axis that you want to move. For example, this is the axis that I want to move. Click on it, and then if you want to go for a copy, so once you go up, a copy of an object will be displayed. So this is the 3D move option. Normal move option is if you press M and take a base point, so you just can move up, you can just move down with the ortho on. So 3D move basically provides you with a tripod, as you can see, and basically helps you in order to move at a particular point where you want to go. So again, so put your cursor, get the track, and go up and go down. So here we have done the 3D move option. Now let's go to the next. Next is basically the 3D array. Normal array and 3D array. So here let's go with the normal array first, and let's see where the 3D array, how 3D array is different from normal array. So the normal array command. So let me shade 2D wireframe, and let me have the small box. So the distance is 0.3, for example. So let me create a rectangle first. Change the units. Engineering. Create a 9" by 9" column. Make the column as 10 feet. Okay. Now I go with normal array command. So if I use the normal array command, so here what I have this in the rectangular array, I can basically have this option level to level. So you have this column. So let's say the distance between the columns is 10 feet. So you can have the and the distance between the rows is, let's say again 10 feet. I have 4 rows and 4 columns. So this is something that you can see over here. So if I, so this is in X and Y, the copy is there. Now let's say if you want to copy this in the Z direction, do you have the levels option. So let's say if you have 3 floors, or let's say 2 floors, I can have 3 floors, and the distance is 10 feet or 6 inches. That's right. So now you can see that if you close the array, the object not only is copied in the x and y direction but also in the z direction. So this is about normal array. Now let's see what the 3D array commands had to store. So if you have the 3D array, you can say 3a, or 3D array command is 3a also you can say. So you have this column and select this. Now you go for a rectangular. So here there is no contextual tab. Directly it says number of rows 4, number of columns 4, number of levels 5, and here you can give so 3D array as such. The difference between the two commands, the array and the 3D array, is in this particular command you cannot do the associativeness, but it is an old command actually. Prior to having this ribbon, development of the ribbon based tool, this command was there. So Autodesk has kept this command. So you can do the same while you are doing a array command also. For the polar, how it matters. I have a circle. I create a cylinder. It may matter over here because here things are a bit different. There's a cylinder, and here I have let's say another rectangle here, and I put it somewhere here. So let's go to the top view and align this with the center point, and let me have this option here. So changing the view to panel view. So now I go with 3D array, and I select this object, and I want to have a polar. Now here the number of items I need 4. Angle to fill. Rotate arrayed object, yes. Now here one thing that is seen is the axis of the array. Now center point of the array would be this, and it asks for the second point. So now you can see that the object is arrayed on the axis. This one you can do with normal array option that you have in the let's say I redo it. Let me get the rectangle again. So the normal array command is the AR, where you have this contextual tab. So we go with the array and select this, and we have this polar option. And so here also you can see, if you say that there is a center point, so here you can do the same, right? Here also you can select the axis of rotation. So here you can give these 2 points as the axis of rotation. So the tools that are there in the 3D array are same to the options that are available in the array command. So you can do the 3D array operations using the new tools, that is the array tools. So let's also see what 3D array has in. So if you have this circle and you want to extrude it, and let's say select this, and I want to extrude it in this particular direction. So let me have this rotate this. So I can use the rotate 3D option over here, where I can select this point, select this and say 90 degree, and let's say I have this line. So I can extrude this, let's say, yeah. So now let's say if I want to extrude this particular object in this particular axis, so I can go with 3D array and select this object, and say polar, and I take number of items 4. I take this as the axis, yes, and this as the axis, and the second point of the axis. So you can see, let me have the axis again. So what is happening exactly is, so now if you have an object like this, and let's say, let me create the rectangle first. Let me create the, okay. So now let's say you have this object and you put it here in this. Now if you want to have the array of this polar array, so 3D array is the command. Select this object. You have this polar array option, and number of items is 4, and 360 rotate arrayed object, and then you have the center point here, and you can take this other point as the center point. Now you can see that it has rotated in the axis. So here the 3D polar array, you don't define a point, but you define an axis. Okay, the next option that I would be taking is the aligned option, 3D align or align option. So here mainly the align option, if you have an object and I have another object and I do chamfer, so I give a command called chamfer edge. So now see the application of this. Let's say I give it as 1 feet and 1 feet. Okay, and press enter. So now let's say if I have an object created at the bottom, let's say small piece, and okay, I want to align this face. I want to align this object with the face that is tapered over here. So align, you have to write the full. So select the object that you want to align. I want to align this object, and I want to keep this first point here, the second point here. So now the third point, I want to keep it in this line. Now this is how the object gets aligned. So aligning is, again I repeat, so you have an object which is again it should, the geometrical object should have faces to align. You have an object which is standing on the horizontal plane, and then you have an inclined face over here. Let me give you a better example of it. Let's say I have got small boxes over here, and okay, so here I want to align the box, this box, the midpoint of which should be in alignment with this. The first destination point is this, and the second destination point I want to give it over here because to keep the direction, and the third destination point I want to give here, and let's say here. So now you can see that the object, the first destination point was in midpoint, got aligned with the mid of the plane. So here you can look into it. So now it went down because there was a wrong plane that was selected. So now again we have to get the alignment done properly. So ALIGN, select the point. You can take any point. Let's say I take this point, first point, take this point at the second point, third point I would suggest this. So shade, so that you can see how the alignment is done, and you can see that, so it is going down. Since the reason why it is going down is the point is not properly picked. So what should I do if I want to have the alignment correct? So what the mistake I was doing, you have to understand. People generally, when they do alignment, they select points which are arbit. So what is the correct way? Now let's say if I have a rectangle box and if I want to align this face, so now you have to go with the algorithm. So let's say if I, let me extrude, if I go with the align tool, and first point is this, second point is this, and third source point is this, and
I want to align in this axis. So probably now this is the right way. Why I wanted to tell you this, what would be the right way? Let me tell you again what is the correct way. So when you do an alignment, you have to be very careful where the point goes. So the first point is this source point, and then the destination is this. So you want to start the alignment from this point, and second point I want to align to this particular edge, and the third point is this edge I want to align to this particular edge, that means parallel to this edge. So I click on this point. So now you can see that the object gets aligned. So you need to check every time you do an alignment, because there are a lot of alignment that we do in a constructional project. So let's say if I want to move it in the midpoint, let's say mid to mid, and I want to do a press and pull, let's say, right? So again, snapping should be off, because most time when you do a grip, the snaps plays a very vital role. So let me go back. Okay, and so I can, so this is how basically I can do an alignment. The next is topic is the slice option. Now this is an interesting option. That's a something I like the most about slicing an object, and it's a concept that you should understand what slicing is. So why slicing is basically cutting the object, 3D object, into two parts. Now let's say if I have a rectangle, say at the rate 5 feet comma 5 feet, and I extrude this rectangle 5 feet. Now since this is a solid model, now check it. Now what I want to do is I want to cut this object into two parts, like the break command that we did in AutoCAD 2D. I want to do a slicing. I want to slice it. So the slice option is SLICE, and select the object. Now once you do a slicing option, there are different options like XY plane, ZX plane, 3 points, and planar object surface. So now all these heads towards selecting a plane. So I have told you that when we work in 3D, we talk about planes, especially when we are defining sections, slices, and mirroring and other things. So when we talk about the plane, so 3 points define the plane. The first point is the origin, second is the x-axis, and the third is the y-axis. So now here we have the 3 point. So here if I want to define a slice plane with 3 points, so if I want to cut this object with a knife at this point, so 3 point would be this. So the first point I would go with the mid of this. So this is the origin, and let's say the second point I go in this particular direction, or I can go in this direction also, and the third point I want to go this direction. Okay. Now after doing that, there is an option specify a point on desired object or keep both. Now the object is cut. I said I want to keep both. Now you can see that the object is cut into two parts, having the 3 points as the slicing plane. Now let's go with more slice object. So I select this object, and then I have this option called, now same, if I want to go with 3 points, it is fine. If I want to have the ZX plane now, which is the parallel plane to this vertical surface, so now we can have let's say the ZX plane. So if we take the ZX plane, then let's say we can have this point over here, and but if I want to cut this from the ZX plane, so let's say if I want to cut this object from the mid and in this particular plane, so it would be the YZ plane. So I go for a slice option. So I select this object and I go and select the YZ option, and I want to slice it from the midpoint. So let's say here. So here I go and say I want to have both the sides. So B. So now you can see the object is sliced from the particular plane, that specified plane that we have defined. Now let's take more option. Go with slice. I select this object. Now I want to have the 3 points. So if I go with 3 points, so now I want to slice it as it is going in the inclined plane like this and this one. Let's see. Try with the 3 points. First point, second point, and the third point here. So let's say B for both sides. Now you can see that the object is sliced diagonally. So this is way we can do the slicing, and the other options are the object. You can select an object or the Z axis to define the slice plane. So this is slice, and then there is an option called section. Now let's talk about the section option. Let me put the UCS in the world axis and shade 2D wireframe. Now slice basically makes object into two parts with a section, with a cutting plane, right? Let's say if I create a circle at this face. Now I will be telling you how to generate 2D sections from a 3D object. Now let's say if I create a hole. Now I want to create vertical section of this at this midpoint. So section command works like the slice command. So you have got a section option, and here you can click on it, and then you can say the ZX plane. So ZX plane is Z and X plane. So I take the ZX plane as the first point of the section. I mean, this is the section plane, and I click the ZX plane here. Now you can see that the moment I selected, now if I move this object, the section will be created. So this is how you can create the section of any object. So I now want to have a horizontal section plane. Select the object, and now I give the XY plane as the, now the XY plane is going through the center of this particular cut. So now you can see if you move this object, the section will be shown like this. So section command is to create the sectional profile at a particular plane that you select. So now we will be talking about rendering. So rendering is the process. Now let me talk about what is rendering. Rendering is basically a process which gives you a realistic view of the product. Now you can see that when we see this object, how the texture is applied, how the lighting would be there. So the rendering, the process of rendering starts with the modeling. So after you do the modeling, you assign the material to the object, the texture to the object. The material can be a glass, can be a brick, can be stone, can be any kind of material that you want to give it to the object. Then next you provide light. The light can be point light, a spotlight, or a distant light, or it can be a sunlight. So if you're doing an exterior rendering, so you can use the sunlight. And then after doing the light will have a shadow also. You can provide shadow. After doing the modeling, after doing the texturing, and after doing the lighting, then you run the entire combination with a rendering engine, that is where with the software. So the rendering engine basically does, there is an algorithm in the rendering engine that renders the scene with the texture and the lighting in place, and then it creates the actual view. Now before placing the rendering, you should have a view. So there you have the camera. So after doing the material, after doing the lighting, you set the camera view. So you have to set a camera view in which you are seeing. The camera view will be creating perspective view, a 3D perspective view of which the scene of which you would be rendering. So the 3D camera perspective view, after doing that and the particular scene that you create, then you go with the render process. So now one by one we will be discussing about very basics of rendering, and then we'll be doing a project in the next session from start scratch to the end to the rendering part. So the rendering involves the material browsers, where you can open the material browser by going to the ribbon render materials material browser, or in the command you can say rmat or mat, and then the material browser will be open and you can select the materials that you want to attach, and then you can select the object and attach the material to it. So after doing that, So you run a dry run of the rendering, but I would suggest that you can create a new material. You can map the material like the we call it as UV mapping, set the texture sizes, set the size of the box of the map, and then later on you can add the light. Light can have shadows or it cannot have it. You can give the light shadows to the light, or with the light, or without a shadow also you can render, and then you have the rendering environment. So this, then you can save this image, then you can create the camera and the animation. So let's go step by step and see how it works. Now to start to discuss the rendering process, what I have done is I have made the screen black and created a scene. Just opened a scene. So this scene is basically, if you look into it, I have kept a polysolid over here, which is a wall, and there is two rectangles over here. I'm going to put a Buddha image over here and another image over here showing some, and then these are objects in the floor. So here I have, this is a scene where you have got a wall, there's a painting over here, and there is a floor over here, and some wooden blocks or tables are over here. So, and this is the floor. So for this example, the rendering example, I have to go with the step. First, I need to save the views and the scenes. View means which I am going to render. Now for here, I want to talk about the views. So first view that you can see over here is the basic views over here, like with the view cube. So here I want to save that particular view, and then so that I can we have a parallel view, that is an isometric view, or the perspective view. So let's say I go with the view manager, I go to the view tab, and here I go with the view manager, and let me save some of the views for the rendering. Now let me go with a new view, and let's say I want to go with the cam1. So I name this view as cam1 and apply. So this is one view which is the cam1, and let me change the view direction. Let's say I want to put it here. Let's say okay. So with the 3D orbit, I make another view, let's say from the top over here, and I go with the, I can do the new view from here also. I say cam2. So this is another view that I am going to show in the scene. So I have this cam1, I have this cam2. Now I am going to create some views. Okay, there are some default views like new view. I want to create a camera view. Now let's plan the scene. What are the camera views that I want? So I go to the plan and select 2D wireframe. So now from the top view, you can see the wall over here, and there's a floor over here, and there are objects. So I want to shoot the scene. Let me move it standing at this particular point. Now I want to give you the concept of the camera. Let's say here I stand, a person is standing and they want to look from the camera view. For this I am making tripod, a cylinder. Let's say I can have the cylinder of dia, any dia, and I'll give the height of the cylinder as the height of the eye level. So the general eye level is 5 feet 3 inches or 5 feet. So I give a height of 5 feet. So now if I am putting a camera over here, the camera location would be somewhat like the camera will be creating the perspective view of sure. When you are putting a camera, the camera would be at the eye level. So you have the location of the camera. Location of the camera is where the eye is, and there is a target. So there are 2 points that you have to set for the camera, and then the field of view. We will be talking about what is the FOV or the lens. So let's go with the camera option. So you can get the camera from the 3D modeling over here, and then you have this. So in the view itself, visualize tab. So there is a camera option over here. So there is a camera display and the camera, create a camera. So I do create a camera. First, it is asking for the location. So your eye is located at this particular point, and the target where you're looking at. So let's say if I am saying that target is, let's say somewhere I am looking at this particular painting. I can see that you have to give a height, let's say, or I can say the target is down. So I am looking down. So now here you can see the camera, show the camera. So again, let me set the camera. So you have the location here and set the target of the camera, let's say at this point, And then here you have the options. So don't get out of it. So you have the options like the height. So height is 5 feet. That is the location where you have set the camera. Press enter. So you can give the height. Okay, you can keep the height as 5 feet. Then you have the target. Target is, again, you can set the target. Let's say I'm setting the target over here. I'm looking there, looking at this direction. I'm looking down actually. So I said, and the lens. Now, if I have a 35 lens, that means the width of the camera is a bit fine. So we can change the lesser, the lesser is the lens. Let's say 15 lens, the wider is the view. So I want to have a wide view because I'm looking very closely. So let's say 20 would be fine with me, and we will check. And then other things, I want to name the camera. I want to name the camera as Cam3. So press enter. Now look into the camera. Now the camera is, you can basically put it off and on. And now remove the tripod because the location is done. So now if you double click on it, right? If you double click on the camera view, the preview is displayed. Now you can see the preview over here of the camera view and the visual style. So you can see the visual style. So you can see it in the conceptual view. Okay. So now in order to get that particular camera view, go to the view, and that view that you have saved will be clicked. Now you can change the into shaded, let's say. So okay, let me give some color to the wall so that it is distinguished. So let me go with the color. Let's say select it, go to the properties and give the color right down here. So the color I want to give it as, let's say, let me give it as red, and so that you can distinguish the objects. The floor color, let me put it like, let's say, in the properties. So colors are different from the materials. So color is something that we are giving to distinguish that which is a floor and what. Let's say I have a different color. I can go up with color wheel. So you have this color. So I give a. So now you see that objects are distinguishable. Now this is the camera view. Now you want to set the camera view. Now how do you do it? So let's say if one way of doing is to introduce the steering wheel now. So there are different types of steering wheel, but the main and the full steering wheel is the full navigation wheel. So if you click on it, you find different options. The first option would be the orbit option. So click on the orbit option. Now you see the pivot of the orbit is at the target. So just press your left mouse button and just put it up to see how the scene would be looking like. And the next would be, now you have just set the view. Next would be to zoom in and zoom out. So if you put, it depends upon where you're putting the mouse. Zoom in and zoom out. So if you zoom out, the field of view is reducing. And then you have the option of walking. So you can walk inside, walk outside. So now let's put some depth to it. Let me go. Now if you want to see the previous, you can rewind it and see what was the previous view that you have created. So this was the earlier view. We started up with this, and finally we have, so we want to keep this particular, so this allows you to compare the views. So let's say if I put the camera view here. So this is how, or I want to walk a bit down. If I want to go up and down, so I can move my camera up, I move my view down. So what I'm doing is, now I have done a customized view from the camera view. So here in this particular view, you can save this view as view 4. So now you have view 1, that is the camera 1. You have the camera 2. You have the camera 3. And now you have the view 4. I am going to create a rendering from this view, any of this view. So now come to the top view now. Let me change the view to the top. So now go to the 3D orbit. It is a perspective view, and go to the parallel and go for SHA and 2D wireframe. Now SHA for shade, and 2D wireframe is 2D wireframe. Now you have a camera over here, place over here, which the view is this. You can, if you move this camera, you can see the things are happening, or you can also change the properties of the camera. Like for example, if I select it, go to the properties, I can change the height. Now see what are the things I can change from the camera is, let's say if I want to increase the camera Z, this is the location. So if I say it is 6 feet, now you can see that, let's say the target Z axis is, let's say 3 feet. So if you press enter, so with this, the view will be updated though. So the moment you click on it, double click on it, the updated view will be seen in the preview. Displays the window when editing a camera. So just close it down. So this is how you can edit a camera view also. So okay, so here now we would like to go with the next option called the lighting option. Now let us understand the lighting option. How many types of lights are there in our actual scenario? So you have a tube light, you have a spotlight, you have a bulb, you have a CFL. There are a lot of lightings are there in the room, and there is a sunlight. So let's understand about how we can apply those things. So let's say if I am putting some bulbs over here, so I am having this small cylinders over here. So let me have the height of the cylinder to, let's say 9 feet where the light would be given. So you have this one. So I am putting, so now I would be first teaching you how to apply point light in a scene. So point light is, let's say if I have the cylinders, so these are the location of the point light, then I will delete it. Let me move this further ahead, make it height more, so that these center cylinders are reference for putting the lights, and then I will further, then later on I will delete these cylinders. Or you do not need a cylinder also if you can do it of your own, but I always prefer when I teach the students, or when they are also professionals, they should have the light points with the cylinders. That makes them very easy to put the lights. Now let us see how the lights can be done. So for the lights, you have the lights command. Okay, for that, first of all, before using the lights command, you go to the visualize and see the create light option. So you have a point light, you have a spotlight, you have a distant light, and you have a, so bulbs are basically the point light. So now the moment you click on the point light, sunlight and light from the point lights, spotlights and distant lights cannot be displayed in the viewport when the default lighting is turned on. So default lighting is a lighting that is there when you don't have any lights. If you don't have any external lights or artificial light, default lighting is there. So I want to turn off the default lighting because I need natural lighting. So later on we will put the default lighting on. So I'm putting the point light over here, then we will be seeing what are the properties of the point light. So I have one point light over here. So the moment I click on it, so here there are various options like intensity factor, status, photometry, shadow, attenuation, and other things, filter color. So one thing that I would like to go for is the shadow. I would have to have the sharp shadow, so that's fine. And in the intensity factor, maximum is, let's say if I give 4, maximum, I can change the intensity factor. Let's see the maximum value that you can give. Now you can see it is taking the values, so it can take a maximum float, right? So but I want to keep the intensity very small. Let's say if I give a value of 10, and then I will basically change the intensity as per the lighting part. So intensity is how bright and how dark would be the light would be. So press enter. So the moment you do it, you find that the light is put over here. So there is a point light, and here you can go with the properties, and same thing you can do. The lamp intensity is here. So you can change the lamp intensity. Let's say I want to make it 900 candela, and intensity factor we had given as 10, so we can increase. This is the intensity factor. So let me give the intensity factor as 1 and increase the lamp intensity to 900, and then there are different things, so we can change this. And other thing is that we have the type like the attenuation factor, like the inverse square. So we will see in one of the example how it works. You can put the light on and off from here also. So, and the name of the point light, I want to give it as lamp 1. So I can change the name of the light from the properties. So after putting the lights, let's say I'm just deleting this cylinder now because the light location is now fixed. So I can copy this light with the copy option, pick the point, and okay, now you can see 4 lights are there, and here I want to see the effect of each light, how it happens. So what I do is I will put this light, name this light as let me name this light as lamp 1. So select it, go to the properties and say lamp 1, press enter, select this. Now see the name has changed, so I now want to name this as lamp 2. I want to name this as lamp 3, and I want to name this as lamp 4. So I am having 4 point lights, and right now I want to see the effect of this light on the scene. So what I do is I select all the 3 of the lights which I want to put off. So here I go and say I want to put it off. So now next I want to see the effect of the light through the rendering. So go to the view and open the V4. So you can see the scene over here. So what you can do is you can use the pan tool to, so you can close this properties. Okay, here. So now I want to start with the render command. So what I do is there is a render option over here. Different sizes are there. So here there is a render window. Click on the render window to see if the render is there. So now press RR in the command for the render and the rendering starts. So we'll be talking more about the render window and other things. So the rendering will basically now here says, okay, so let me cancel this because this is the material library it is talking about. So the rendering process is on and the screen will be displayed over here. Now you can see that, let me zoom it a bit. So this is the output of the rendering that I'm having it. So let me zoom it more so that I can see the, so in the rendering I can have a region rendering over here. So I can go here and region render and okay, so I have taken the region render and here I can go with RR, cancel this. So pick crop window to render. So let's say if I want to only do this particular rendering process, this part, to see what is the effect of the light. So now you can see that the light is coming from the point light over here. So I can compare it. Now there is a shadow over here and other things that you can see from the light. So go for regenerate command. So you can just, the moment you zoom it out. Now the next part is to see from the top, how you can also see from the top. You can have the top view here and you can see how the light is creating the effect. So you can go with render and you have the crop option activated here. So region crop, so you can have this region crop over here. Now you can see how the rendering is done. So this is the you can see the shadows over here. So you have this all different lights over here. So the effect of this is from the light that is here. So let me see, go to the properties of it and see. So this light is off. So this light is off. So this light is also off. So you can put this light off over here and this light, I want to see the effect of this light. So now in this case I want to have this light on and that is a lamp 2 and other lights off. Now again go for the RR command, that is the rendering. So in my case it is coming over here because of the material library, and then I crop, make a crop window for the rendering, and I can see that how the lights have changed from this point to this. So now if I increase the, let's say for example I have this, I increase the candela value to 1500 CD. So let me see what will happen. So again you can go for a rendering option, and you can check how the candela value of the light intensity can come. Now there will be one shadow over here because one light is coming here. And now you can change the view. With the view you can go with the, let's say, view 4, and you can again see the effect of that particular light that was there. So crop the window. I'm just cropping this particular window which I want the rendering to be done. So you can see that the rendering is done. I'm doing a medium render right now. So now what we'll be doing is we will be also discussing about, now if I about the other lights like the spotlight and the distant light, how they work. But now you can see that the object is having a shadow and the light is there. So now if I want to have a spotlight, so how do I do? So now we are now I would like to talk about the spotlight. All the point lights are off. So now if I have this, if I want to have the spotlight, I'm creating a cylinder right now to get the location. The spotlight will be having the source location, like where it is located, and the target location. So where it is spotting to, for example, it is spotting to over here. And similarly, you will be having the intensity factor. You would be having the, now here are 2 points of this hotspot and fall off. There are 2 things over here. One is the hotspot and the other is the fall off. So here I'm seeing that there is a hotspot and there is a fall off. So hotspot is basically, I will tell you when you will see the rendering. So for this moment of time, let's say if I put this light name and name it as spot 1. So now I have this the location and press enter. Now other things that we can fix. Now you can see that the light is there. I'm just deleting the cylinder. Now here the symbol of, now you can see the hotspot is the maximum area that the spotlight will be taking. Now you can see there are 2 circles over here. Now let's go to the property and see the spotlight parameters. Now here let's say you have the hotspot and the fall off angle. So let's say if I give maximum angle, let's say, so 160 is the maximum angle that I can give to the fall off angle. Let's say here I give the fall off angle as 100, and not only 100, let's say if I give the fall off angle at let's say 30, and the hotspot angle will be lesser than the fall off. So you have, if I say 20, so now you can see that this is the outer is the fall off and this is the hotspot. This is the area where the maximum intensity of light will be there, and fall off area is, it is the extent to which the spotlight will be there. Now let's see a particular render. So go to the view, change the view to the view 4, right? And now look into it. Now you can go for a render, RR command, pick it. I have put all the point light off here. So now you can see, now I would like to have a top view of it in the render. So here you can see that I mean it is not so visible. So let's have the top view so that the fall off and the hotspot will be visible. So let me put it here. So I make the top view. Yeah, this is the light, this is a spotlight. So you can go for the rendering, or if you forget the command, you can directly go from the render settings over here, and here you have the option, the rendering option, and the current presets and the render level that you want to give. And I'm at a draft into the render accuracy, so then I go with render and just close this, because, and then because I'm using a region rendering, so I'm just I will be putting it a crop over here, and now you can see. So there is another thing called the render window. So here we have the render window on, so you can see, so it is the previous one that it is there. So let me close this. So now let me zoom out and okay. let me have the intensity, let me increase the fall off. So I can increase the fall off angle by clicking this grip also, and the hotspot angle also by clicking this grip. So select it, and if you place your, so these two things, the hotspot angle cannot be greater than the fall off angle. So now if you do the render, now see what happens. So I'm just putting this. So the area for the light had increased. So I'm just increasing the intensity. Let's say here I go with the properties and increase the intensity, let's say 5 times to see brighter light. So you can see the rendering option now. So lighting is something that you have to fix, and then the texturing I would, now things are better. So now you can see that the light, this is the hotspot is the maximum light, where the maximum light falls into, and the fall off is where the light is generally extending up to, the illumination is generally extending up to. So this is how you can test it. Now coming back to the scene, so this is the spotlight that we can have. Then other thing is the web light and the other lights we can also try. So here I have put all point lights off. So here I am going to the parameter and putting the spotlight also off. So let me go to the top view again, and let's try with more lights now. And then so here I go and 3D orbit, and I change the to parallel. So I have 3 point lights, 1 spotlight. I can always move the point light to a particular, but that you need to check that the target, the target has to be well placed. Okay, so here we go. So now we have the visualize, and then you can create a light. You can have a distant light. So distant light is just like a spotlight. You need to have a source. Let's say if I'm having a cylinder outside, and it is not like a spot, it is coming, the conical formation is not there. Spot, basically the light is just like a torch. From the torch it happens that there is a cone that is forming over there, the spotlight in the disco light you can see. But in case of distant light, it is a cylindrical light. Now you can see how it is different. So I have a cylinder over here which will be giving me the location of the distant light. So I'm going with the parallel settings. So here I have this distant light, and then disable distant light when the lighting unit is photometric recommended. Okay, allow distant light. So I'm going to allow the distant light, and here I have the light direction. This is starting from here, and this is here, it is coming. So now you can change the light name, and you can name it as sunlight. So this is a light which is coming from very far. So press enter. So now the distant light is you've given the direction and the location of it. So once you render it, you will find that there is a distant light which is acting from the very far, and it is creating the shadow because I put all the lights off. So coming back to it, okay, so now you have the now let me have the plan here. SHA 2D wireframe. So just another thing is the web light. Let's say now here we have the point light. So let me have the web light in place. So it will be doing the application of it from point to point. So here we have this rectangle at the top, and I create a web light. So the source location is here, and this is just like the chandelier, and the target location of the web light is, so it is falling down. So web light basically fills the light. It is a fill light that we talk about. So I name it as, let's say here, I name it as fill light. So I should have a fill light in my scene. So press enter. Now there's a web light is here. So let me do a quick rendering of the web light and see how it looks like. So going with the RR command and close it, and I'm putting a window over here. So you can see that how uniformly the entire now web light is giving a fill to the room. So I would recommend that we should have a fill light as a web light, and then we can put other lights also. So if you go to the properties, so you have the intensity and other things, you can see you can put it on. So I have named it as fill light. So this is where the lighting part ends. Now the last that I want to talk about is the material and the texture. So I'm just putting it because I want to give an image over here. I want to give the texture over here, and then I want to finish the session and go for the project. In the session 13, we will be studying in detail about how the modeling and the rendering can be done from the scratch. That is the project. Now, after putting the lights, I would be telling you how to assign the materials. Now here I want to assign a tile material over here, and a wall I want to assign a plain color, and here I want to assign two paintings. Now see how it works. So here we have the material browser, or you can type the rmat command, which is an old command. So here we have the material browser. So in the material browser there are different options over here. Now let's say, talking about the material browser. So the material that you will be creating for assigning it to the object has to be present over here. And here this is the document material. So how do I go it? So here I have this Autodesk library, and from here I would select what is the class I am going to select. For example, if I want a wall painting, so I will go with a wall painting. So the category over here, you can see that and then you can further go that if you need a wall paint which is matte, so the category can be here. So whatever wall paint that I want to have, let's say I want to have a beige color, just you can put it up, and here you can add material to the document and display in editor. So if you click into it, it will be and the editor will be visible. Now you can see the editor is where the material information are there. So if you double click it, the editor will be there. So the name of the material is beige. You have the RGB, that is the red, green and blue color over here. So for a material to be created, you need the color and you need this finish. So here, because it is a wall paint, it is showing the category as a wall paint. So it is only showing these two parameters. Now let's say if I want to assign this wall paint to this particular wall. So I select this and right click into this, and there is an option called assign to selection. So when I click on assign to selection, now here I have this option called realistic. So I can always see in the realistic view how the texture will be there. So here you can see in the realistic view. And so if you want to try with more of the wall paint, or you want to create your own wall paint, so what you need to do is, so you select that particular paint and duplicate it and name this paint. Let's say if I need a custom color, let's say I name it, and here I double click into it, and then here I give a, let's say, color which is a dark red, and then I can have it as gloss or semi-gloss. So the I can give the application. So now I have another, if I select this, I can assign it to the, so now you can see the change over here. So this is how I create a material, let's say for the wall. Now if I want to go for the floor, so I need to go to the Autodesk library and say I need a flooring. So here you have some flooring from the Autodesk library, default flooring. Then we will be going, okay, so let's say I need a carpet. So put it over here, go up. Now for the flooring, I have selected this carpet. So you can double click on it to see the preview of it. So you have this edit option if you want to. I think there is the appearance, this dialog box was hidden behind this, so I just moved it. So now you can see the carpet pattern is the pattern that you can see, and there are different things. So okay, so here I go with, and I close this again. I open the material browser, and I want to assign this. So I just reduce this size. So I select this floor and add sign to selection. Now you can see that the pattern is assigned to the floor. Now I want to add a picture over here of a Buddha. So for that, the relevant class would be, I would like to go, you don't have like fabric or something, so I would like to have a default. So or I can go with a generic. So I can, what I can do is I can create a new material over here. So a new generic material. So here I have this default generic and name it as a Buddha image. So here I can give the image. It is saved in the folder of so this is the image. So just putting it over here. So this is the Buddha image that you can see, the this is the image that I wanted to have, and this is the sample size. So it's a 12-inch scale I have done. So I want to give it a size of, let's say, 3 feet by 3 feet. So that's the scale that I want to have. And then I want to assign this. After creating this, you can see what I have done is I have increased, I have double clicking on it. I have set a scale over here and select this object and put and assign to selection. Now you can see here. So if I want to make it a full Buddha image over here, so there are two things. First of all, I have to set the map of the. So here comes the next option for texturing is the setting the map. So you have this material mapping over here. So select this box in which the image is there. So now you have the option what you want to do, what mapping you want to do. You want to either go for a box or a planner. So the moment I say enter, so I have a box option. So here with this box option, I can basically do a mapping, and now you can see how I have changed, right? So in the box, I have the length, width, and the height that I can change. So here I can increase the size of the box so that the Buddha fits, and I can increase to a point. So here with the box shape, I have changed the size of the map. So now if you do a render, so let me have the spotlight on and go to the view. Now you can see a beautiful Buddha image would be seen in the, so I go with the view 4 here. So I go for a render RR and so I have this, press enter, close this default. So this is the window that I want to do. So I have now a paint and there is a issue with the lighting. So what I will do is I will change the light over here. Let's say, let me regenerate it, just move it. So I want to put this light on, which is right now it is off, which is near the Buddha image. So to select that light, what I need to do is I can go to 3D orbit, change the view, and let me see if the light is selected or not. Or I can rotate this because I have to select the light. So here I have, so with the 3D orbit also you can see, and if you can select the light or not. Yes, the light is now selected, and in its property you put it on to see and give the intensity twice, so that it is more brighter, and select the spotlight, that what you can do something with the spotlight. So select the spotlight and make it on, so that, so now you go with the view 4 again, go for the rendering option, close it, create the box. So this is how you create the texture for Now similarly, you can see that in the floor you need to have a mapping, because the carpet over here is not seen clearly. So here again, I would suggest that I'll go to the material browser again, where the materials are present. So I put this off. So I go to the material browser. So I have this carpet over here, the floral pattern. Make sure that it is basically assigned. So I go to the 3D orbit and change the view to see the. Uh, so what I will be going is I'll go for a top view so that I can see the texture of the carpet. So now here, this is the carpet over here. This is a floral pattern. So you can assign it. I can drag it. So now I will go with realistic to see the images. So now you can see the carpet is the floral patterns are not organized. So what I can do is I can go with the UV command, that is the set UV that we were talking about. So the UV mapping is generally used for mapping the texture. So now if I use, let's say, a map which is in the material mapping, if I use a box, that means I'm telling AutoCAD that this is a box. Select the faces of the object. So if I select the face, now here I have to select. So I have to tell that this is the cylinder box and this is the where I want to put it. So this is how the UV mapping can be done, and because of the view it is, now I can increase or decrease the, I'm increasing so that and I can rotate the Gizmo also. So this is how basically the mapping is done. Now you can see it is diagonally done. Now if I go with the scene, so the rendering will be done like this. So I think I'll just put another map. Now you can see that here the textures are changed. So let the rendering go. So here rendering takes time because it is an algorithm that has to be put across. So now here another thing that we can do is to assign the image to this particular frame. So here I have this, I would be creating another generic material. So for that I would go with create new material and new generic material, and I name it as painting 1, abstract painting. It is an abstract. So I name it an abstract painting, and here double click into it to open the editor, or I can click on it to open the editor. Now you can see the editor is open here, and here in the image you can give the abstract image. So you can see, if you want to see the preview of it, you can see the thumbnail of it. So this is the image that I want to put into the browser, and here I have the material browser. So this is the image that I want to put, the custom wall paint and the abstract painting. Now here if I want to assign this, I can drag it, so it is going into the wall. So the best way is to do is to select it, select the material and assign to selection. So now you can see that the painting is again two things that you can do is, first is you can basically go for the tiling. Let's say if you want to change the scale, like you unlock the scale and you say the sample size, the width is let's say 3 feet and the height is let's say 5 feet. So unlocking is basically you're unlocking the scale. So I have this 36, that is the factor of the image. So now you can see that here the images is stretched off. So what I can do is I can go with set UV, that is a UVW mapping, and I select it as a box option. So similarly I select this faces of this and press enter. Now you can see that with this the grips are developed, so I can change the scale and see. So this is how I create an image over here. So this is the UV mapping and the rendering, and you can try with different options once you do the rendering process. So what you can do is, so you have this rendering RR is the command. So pick up the window that you want to do, and if you want to save the rendering, So you can go with the render to size. So here we have this all the options. So now the rendering is been taking place. Now you can see that rendering progress bar is there, it's complete. And here you have this rendering window where so once you have this rendering done, you can save this rendering by save image option, or you can always, so here you have this, because in the rendering bar there is an option to save it. So if I go with the render option, so there is a render gallery, so there's nothing in the gallery because it would be 360. So now to save this rendering as a JPG or an image file, what I would recommend is you have this scene created with a camera view and other thing. So here you have this option of the setting in the render. So this render preset manager will be displayed. So here you go with the window option and select the rendering size. Let's say I select this size. And then once you render it, so the rendering will be seen in the rendering window over here. And from here you can save this image as a, so you can zoom it, now you can see the rendering over here. Once you finish this rendering, you can save this from the rendering window from here, and here you can basically have the image saved in PNG, JPG, TIFF and other formats. So you can save it in JPG also. So the image now is, and you can have the best quality. So this is how you do the rendering. And so in the render gallery also, it will go to the Autodesk 360. So the render window here, now you can see the render window. So with this, we finish the rendering part of AutoCAD. And in the next session, I'll be taking a quick go through for the project. Thank you. Hope you have learned. So welcome to the project session to the AutoCAD drafting course. So here in this session, I would be telling you how to create a 3D model out of the plan that you can see over here and the elevation that you can have. So the complete step of creating a building. So first, I would like you to first of all copy the plan that you have, and then go with the layer command and create some new layers like 3D wall. Give a color to the 3D wall, and then you have 3D window. Give a color to the 3D frame. So window will be having a frame. Window will be having 3D window mullion. So this is the 3D frame, is a 3D window frame, and then we will be having a 3D window glass. So we'll be creating the layers for elements, like then we will be having 3D door, then we will be having a layer of, let's say, 3D door frame, then we'll be having a 3D door panel. So this is a very kind of then we will be having 3D floor. So rename it. So now let's see how basically the process of 3D modeling comes. So we will be looking into the all the process of building this 3D model, starting from the creation of a 3D wall to texturing, lighting, and then rendering. So I'm going to go for a quick tour of the modeling. You will be learning how to create a elevation and how to create the 3D model from a plan. So you have a plan like this that you can see. So what you need to do is, this plan is out of the clutter, like the text command, and it should be a wall like this. So now put the layer on of the wall layer. Let's say I'm having the wall layer on, and then go for the boundary command. So the boundary command is used in order to create the region or polyline from a close point. So you click on this particular part. So now you can see that when you press enter, the region will be created. Now here, if you go for a 3D view right now, so I'm changing it to the right. So I'm opening the view cube, and let's say I'm changing my screen to black screen. So to change the screen to black screen, you go for an options, and then you go for the color, and then you go for the black option. So yeah, here what I need to do right now is I have to change I have to go to the shade, and so the moment I need to change the shade. So now I can see that here in this the plan option creates the plan view that is the parallel to the UCS. So this is the UCS. Now again I need to go for a pick point and create the walls. So this is something that I created, and here I have two doors to this particular space. So you have this door here, and this is another door that would be going to this passage. So there are three rooms over here in this particular building that we are going to make. And apart from that, there is something that you want to create is the floors and the parapets. So we'll be getting the heights of it. So now first thing that you need to do is you need to basically see what is the height of the building from the plinth level. So go to the plan and just measure what is the height of the floor. So height of the floor from the plinth level. So I go for a dimension linear, check the dimension from the elevation that I am having. So it is 3000. So let's say now I will extrude. So this is the region that I have right now. So I go to the 3D orbit, and then I go for parallel projection. So what I can do is, rather than going to change the view every time, I go to the view tab and set this view as let's say view 1. So what will happen is, every time I'm going to switch off over here, so I can always put the view on and come back. So first of all, extrude this particular set of walls to a height, let's say around. So now one thing that you need to be sure of, that you don't select the lines. So what you need to do is put the layer isolated of this particular plan, so that you don't select other objects. So you have this extrude option. So you can go to the view and select the V1 as the current. So now you have this extrude option, and here I select this particular region and extrude it, let's say 3 meters. So I'm not extruding the plinth. So I will be creating a floor and doing a plinth at the bottom. Here I have this entire wall with the uh, openings over here. So now first of all, I would like to develop the opening for the window. So here I will take the layer, specifically the layer for the uh, window I have created. So I will go for the window, 3D window. So I create a rectangle here from here to here, and the next thing that I would do is, so V is this and V1. Okay. The next what I would do is I would move this or I would say, let's say for example, first of all I would like to find out what is the sill level of this. So here, to find out the sill level, I need to go to my plan and see the sill level is 600. So here what I'm doing is I'm extruding this window to 600. So if I'm selecting this particular and making it 600, so this is the sill level of this particular wall. So then what I would do is I would like to have the top covered also. So here I go, I put my UCS at this face. So I go with UCS and face, and I put the UCS at this particular face, and I click right, and I go here. So I'm extruding this at let's say the distance that I have of the lintel level is, let me check. So this is what I have. So this is the distance is 600. So it is 600 from the top and 600 from the bottom. So this is, I will go for a 600 minus 600. So now you can union this particular wall and get the window opening. So let me first of all change the color of the wall so that it looks better. So let me put it at a lighter shade, and the window, let me get it into a greener shade. So we have this window. So next I would like to have the opening for the, so I will put my UCS in the world. So you have this again, I do my rectangle, and let's say I do my rectangle here and extrude this rectangle to, let's say, 600. So similarly, I take my UCS over here, create a rectangle of 600. So it would be somewhat like this. Select the rectangle and create it minus 600. So you can union this, and this is what we have created. And then I would like to have my door. So I would put my UCS at this face itself and do the rectangle part from here to here, and definitely the doors and windows are at the same level, so I would go with minus 600. So you have this door opening, the window opening, and here we have, you can union it. Similarly, I will be having my UCS at space, and I would like to cover this particular head of the door. So I'll put the dynamic UCS off. So here I have the extrude option, and I can have minus 600 now and go with the union option. So now you have these openings that you have done. Now you're going to put the doors as per the elevation. So now I have created the wall shell of the building. Now I will be creating the windows. So for that, let's say I go to the view and let me select the view that I was working in. So here, let's say I go to the plan. Now what I need to do is I need to create the elevation that is over here. So what I do is I copy this elevation here, and what I will do is so 3D orbit. and you have this parallel option. So the moment you copy this elevation here and bring this elevation here, let's say, so I'm going to put it in alignment with this so that I can match with it. Now let me see which layer it is right now. So okay, the elevation is in the 0 layer, so that's fine. So what I will do is I will make this elevation into group so that it is selected together. Now I will do a rotate 3D option and rotate this in this particular axis in 90 degree and move this uh, in parallel to the, I mean, I'll bring it here uh, at this point so that I will be able to create the elevation buildings front view as per the elevation. So what I did is I moved it and now I will be creating the elevation. So now to create the elevation, again I'm going to the view that I had made it set current. So I would like to put my UCS at this face because I would like to uh, do with the lines. That's fine. So now I go to the plan and here I would say that how to create these uh, panels is again one technique that I would be telling you about. So just you need to, for the doors and windows, just copy the elevation on the side because you are now and then ungroup this and fine. So the moment you ungroup this, you find these lines. So here I am interested to only create the take the profile of the windows and create the profiles from them. So that's fine. So now here I can see that this part is of the frame. This is the mullion and there is a glass over here. So what I would do is first of all create. I would first of all put the door frame, the window frame layer current. So let me give a particular color to the window frame layer. Let's say I put a color, let's say brown, and make it current. So now what will happen if you go for boundary and for region, we will be creating region. So this is the region. So you can, if you look into it, this object is filled. So what you need to do is select the bigger region and go for a subtract option, select the bigger region, and there is a smaller region over here. You need to subtract it. So this is a frame that is done over here. Now the next is basically the mullions. So for the mullions I keep a different color, okay, and make it in current. So go for a boundary command and then there are 1 2 3 mullions. Again what you need to do is subtract the object, and if you don't cannot select all the object, because the common will be subtracted. So you have this okay. So now let me see. Okay, so what you can do is select the bigger object and then press enter the smaller one. Select the bigger object, then press enter, select the smaller one. Select the bigger object, press enter, select the smaller one. So you have the frame ready for the 3D object. Next is the glass. So go to the layer and change. So you have a mullion, so make this layer as the glass layer. So I would rename this layer and make it as glass and keep the color as let's say uh, glass color like cyan. So I'll go with the boundary and then I'll have the region 1 2 3. So change the object to the layer called glass, 3D glass. Now this window has a different size than this. So then this is the projection that I will be making. Similarly, you can have this window done. So 3D frame boundary, and you have this region and this boundary done. So you have one. So now you need to look that, there should not be opening, otherwise the boundary will not be created. So in order to see that where the frame is not getting worked out, so let me check it and see that. So here we have this boundary. Let me start with the mullion boundary first. So let me have the mullion boundary first. So boundary, and let me check whether the mullion boundary is working. So you have the mullion boundary is working, so you can subtract it from the right, subtract bigger one, enter. So bigger one, enter. So okay, so if let's say the smaller one is not selected, okay, okay, so you need to try with the select object option. So sometimes the smaller objects do not get selected. Then you can go with the layer of the glass. So you have the glass layer, you can go with the boundary, and you have the region, and so this is the glass. So here we have we had to create the frames. Now let me, so there is an opening over here. Let me check the opening is there. So you can go with the fillet radius boundary. So go with the bo command and see whether the boundary is getting created or not. So again, so now this so now what you need to do is I have undo the command. So I would be looking for a window frame. So I go with the boundary and see whether the boundary is created or not. So right, so now first of all we will be creating the frame. So go to the 3D and the view over here. So here just isolate the because there are two layers, two regions that has been created. So I'm isolating this layer so that I can get the exact layer. Yeah, so you have this subtract option, so you can subtract this from, so you can have all the subtraction done. So this region is also deleted. Now you can put on the layer and see how it works. So now this frame you can basically now go to the layer of the frame and extrude the frames by, let's say, I have selected this frame and I'm extruding this frame inside like minus 75 mm. So the frame is extruded. Similarly, I'm extruding this mullions by, let's say, 30 mm. So what happened is since the mullion layer was not current, so I would like to put this into the mullion layer. Okay, and then we will be extruding the glass. So this way we are creating the assembly of the window. Okay, now put the layer of the glass on. So go for an extrude option of all the glasses, select them, and minus 15 mm you can give the glass thickness, or minus 12 you can give. So now just move the mullions, let's say 15 back in the z axis. So select the mullions because there will be some kind of, so you select this and you move it, let's say minus 20 okay. So now if you look it into this, so if you have this mullions, now look why we are moving this. So select this and move this in this direction. So let's say 15 you want to move inside. So and then similarly this glass you want to move, let's say more 20 So there will be a kind of depth that would be created here. You can see the depth here. Similarly, move both of them and then you will move the glass. So you can see, so I am moving 20 the entire assembly, and I am moving the glass at 5 So there is now we have created the windows. Now put the layer off of the zero layer so that we can group the windows. So I'm creating a group of this window, and I'm creating a group of this window. And the two groups are created. Now this is selected individually. Now what I will do is I will copy this window and put it over here, and copy this window and put it over here. This way you are basically placing the window into the opening. Now what you need to do is just place this 20 back, so that, or you can create more niche to the side, so you can have this. So I would be moving more 50 in fact, so that it goes inside, right? So this is what I have created for the windows. So now I will be creating the projections. So I go to the layer and create another layer called projections. So I make this projections layer current. So all the projections that I was seeing in my elevation, now open the layer. So go with layer on. Now here you can see that the projections are there. So go to the plan, because so what you need to do is you need to again put the UCS over here. So what I will do is I'm going to save the location of this UCS. So UCS manager, I can go and here I can, so you can see the unnamed UCS over here. So in the UCS command there's option called face named object. So here you can basically save the UCS wherever you want. So but so now let me you can set it current, and you can rename it, name it as 1. So if the UCS is at word, so if you go to UCS man and press 1 and set current, it comes to the UCS. So now press plan. Plan will take you to the front. So now keeping the layer projection on, so I will be giving a different color to the projection. Let's say I want to have a grayish color kind of thing. So here I have this projection, and I will give the layer BO, and I'll be having two regions, one at here and other is here. So I have got two projections, and then I can go to the view and go to the V1 and set current, so that I can basically create this projections as so. Okay, let me go to the plan and see how the projections are created. So have the projection layer. So, okay, by default the projection layer became frozen, so I'm just going to unfreeze the layer. Okay, so go to the shade option. So let me see how I can retrieve. So this is the projection layer that I was having. So go to the view and v1 and set current. So you can have this so here okay, go to the plan, right? So there's something that is going wrong with it, so let me check the UCS first. So go to the view and v1 set it current, and UCS manager put it at 1. So I'm going to set current so that I get the actual UCS. Now I can see that in this particular case uh, the I need I go to the plan and set the boundary layer current that I did previously, so that or the projection layer current. The selected layer cannot be make current because, let me check, because the projection layer I think is frozen. So if you unfreeze or thaw it, yeah, it is there. So you don't need to create the region. So it became so now go to the view and go to the v1 and okay. So the moment I go to the v1, in the v1 the layer is thawed. Okay, so here I go and extrude the projections. So this is basically the extrusion would be around 450. So I put this all into the layer called projection layer, and then what I would do is I would copy this. Let's say if I want to copy this, I need to take a particular point. So here the particular point can be the point of the steps, or so second point of the step. So here I click in this point, endpoint, and just click it over here. So now you can see that the projection is rightly placed in the elevation. So next we are interested to create the doors. So go to the plan and so again you need to change the UCS location, UCS manager, where the saved UCS is there. So go for set current and go to the view and go to the v1 and set it current. So here I need to go to the plan view here. So okay, so I'm going to the view and then I would change my UCS manager, set it to 1, and I am here. So here I have this frame that I need to do. Let's say the frame is can be like this. Okay, go to the plan and again you can put the door frame on. So you can have the boundary option, select the frame over here. Now you have the, now next the layer would be the panel, the door panel. Go to the boundary, so you have this panel ready. So now change the layer of the color of the layer of the panel, let's say to a lighter color, and the door frame to, let's say, a darker color, so that they are distinguishable. So now you have this door ready. So go to the view and v1 set current, and you can see the view which is there. So now you can have the copy of this, or first of all extrude this particular door frame -75 back, and then put this layer as a door frame, and just need to extrude this minus, let's say, 20-30 mm, and put the layer as door panel. So here you have this assembly of doors. So now just select this, and in the second stairs, take the base point and just place it from where did you pick it up. So the projection layer is again frozen. So let me, okay, put it on. Now you can move the panel, let's say, select the panel and move the panel to, let's say, in the Z axis minus 20 mm. So if you move them in minus 20 mm, there will be a depth that will be seen. So just put it and go towards 20, not minus 20, and then overall this frame and this you can move around 150 mm, so that there's a particular depth that happens. So just push it forward, let's say 30 mm forward, so that it does not go beyond the wall section lines. Okay, that's fine. Now you can see that the wall is detailed. Now we are in the verge of finishing of the modeling of this particular wall. So now I would be creating the plinth level. To create the plinth level, uh, I would go to the UCS and press world, and here I would like that take a rectangle over here across the plan, and then okay, go to the view, V1, set correct. So here I take this rectangle, come to the layer, put the projection layer on, and that's fine. So if you put the lay off, okay, so lay off. So I'm putting the layer, current layer off. So now you can see that there, okay, here I wanted to create a rectangle. So now let's say I want to have the floor layer on. So what I wanted to do is I wanted to have the plinth created over here. So the plinth is the floor, in fact. So you can do what, you can extrude this line, let's say minus 600, whatever the plinth height is, and change the color. I mean, it is not required. So you can give a different color to it, or go to the layer and give a color which suits. So let's say I give a color, this color. So now I put the layer on, and I can see that the uh, floor is having a different color pattern than the wall. So what will happen in the periphery of the wall, there would be a, a wall cladding which would be moving over here. So we'll be putting a wall clad over here, so that we can so let me do that wall clad, and after that I will be doing the staircase. So how to put that wall clad? So throughout from this point, so let me take the idea. So you go to the UCS world and see what is the layer. First of all, it is a 3D floor. Go to the so I want to have that wall cladding in the 3D wall layer. So I made it current. So go to the UCS face at this particular point. So I want to have the face here, or because the wall will be having the sweep from here. So right. So what I want to do is I'm going to move this UCS and put it here. Okay. I want to put the X, Y, whatever it is. but I want to create a rectangle. The reason why I did is I want to create a rectangle which is, let's say, height. Now it is in the x-axis, and let's say 50 is the width. Now here, this one I want to sweep across this path. So what I will do is I'll create a polyline. So I take the layer, zero layer as the base layer, and right. So I create a polyline, or what I will do is rather than creating a polyline, I will copy this particular face. So solid edit, face copy. It will, so I select this face. So solid edit, face, and I want to copy this face. So this is the face that I want to copy. So two faces found. So let me, the reason why I'm copying this, because I want to have the profile. So solid edit, face, copy. So let me isolate this layer along with this. Lay ISO so that I can work individually. Okay. So what will happen? So if I do a lay ISO, uh, go to the settings. Okay, put all the layer off, enter. Okay, so settings. So enter settings for layer not isolated. Put it off. So all the layers are off. So this is in the wall layer. So let me match this. Okay. So now I will be also putting this off. Now see why the reason I am putting this off is I want to create the profile. So in 3D there are, so yes, so here we are. So you have this profile here. So you want to have a, you want to copy this profile. So you have the face, you have the copy. Now you can select it very easily, and then you can copy it. So now let me change the layer, the current layer, to projection, or I can have the 3D floor as a current layer, so that anything which I create shall be visible in the current layer. So when I do a solid edit face copy, I have to see that the layer which is current is available. So now you can see that I will explode this, and then what I will do is I will put my UCS in this face so that I can join these lines as a polyline. So I have the join option, and here I will bring this profile and put it here. So since this is from the bottom, I want to put it here, or I can get it from the bottom also. That's not an issue. So you can have it in the top also, let's say here. So you extrude, or let's say delete this. You can use an extrude option, and you can select the, so now if, let's say, if I want to give a profile into it, so UCS world and UCS 3 point. Now see what happens. So I'm just thinking that I should give a profile into it. So giving a profile is, let's say if I have some rectangles over here and I copy this down. So it's a checkered profile that I'm giving to the, okay. So here what will happen if I do a boundary and do a region? So only this particular portion will be selected, and now you can extrude this in the path that you have created. So this entirely you can move it into the 3D wall layer. Close it. So you put it on the 3D wall layer, and now you can move this 3D wall layer and put it above the to create a wall clad. So here in this particular area I don't require it, so I want to cut it. To do so, put the UCS here, and what you can do is you can create a rectangle at this particular point, and let's say you want to so what you need to do is put your UCS at this front. There are two ways. You can either create a bigger box and subtract the object. So here we are. So I am creating a box, let's say move last. So I'm just stretching this to the part that, okay, and bringing it here, and so 3D orbit, you can do a parallel view. You zoom in and you can see that line. So just extrude this line here and subtract this from this. So you have this cut out there, and then you need to also have the staircase at this particular point. So put the layer on. So now we are going to create the staircase, and then we will do the rendering part. So let me have the doors copied into the inner part. Okay, so you have the doors over here and the windows given, and then you have the clad of the wall which is surrounding over here. So I will be having a stone cladding here. So seeing so, now what I will do is I'm just putting off the layer and erasing this part. So I'll be creating a rectangle at the top. So put my UCS at the top and create a rectangle here of this particular size. Okay. So now if I do so, okay. Now this rectangle will be having, let's say, this is a floor 150 thickness. So the layer is 3D floor, and what I can do is at this stage I'll so if I am creating a floor, it is good that I create in the internal part so that it does not merge with the walls. So yeah, so I extrude it. So minus 150, let's say, or 150 I can give, and then I will copy the entire element including the, let's say, so what I'm going to copy is I'm going to copy the wall from this point to this point. So the wall is copied, and similarly I'm going to copy the windows and doors. So I can take this as the base point because it is visible over here. Right. So now there is certain things that we can do over here with this building. First thing is that we need to create the staircase at this particular part, the steps, and then create another floor. So I can have an opening, I can have the staircase at this particular point. The staircase can be here, or it can go from here. So I can keep an opening so that the it can be maneuvered from the uh, front, from the back. So go for the UCS. I'm just creating the elevation right now here, and go with the rectangle part, and so I'll go with the smaller rectangle part and create again a floor. So I'll extrude it the last, and let's say 150. So now the outer wall has to be extruded. So now you can see that uh, so I put the layer off of the floor. So select it, and I want to put it off. So now I want to have the parapet. So let me put the 3D wall on, and here to get the parapet, what I need to do is I need to create this wall, and let's say 230 mm offset. So just move the last wall that we have created, and go for a 230 mm offset, and put the region over here. And the parapet is, let's say, if you want to subtract the region right now, so you can always subtract it. And parapet is, let's say, 600 millimeters, or 900 millimeters in fact. So you extrude it 900 mm and move this particular part over here. So let me check. So you have this extrusion, and you have a 900 mm extrusion, and then you move this at this particular part. So you have this union over here. So I'm doing the union of so now I can copy the frame and the door that I have done over here in the upper part, because right, so I can do it in the upper part. So the floors are off, so I can put the floor on right now, so I can see the parapet with the terrace. So this is the building that can be created in AutoCAD by simple rules. So you can have some elevation and facade detail. Let's say if I want to put a UCS over here, so if I, let's say, and I want to have some detail, like I want to have a projection done at this particular point, let's say, so get a rectangle REC. So see what type of facade design you can make. So make the layer first of all on. So if I draw a rectangle, so I think I need to change the color. So I go with the projection layer as current. So now let's say if I want to have some projection of this lines, so there is I can go for a plan first. So in the plan you can have a 2D wireframe, SHA 2D wireframe, or hide. You can go for a hide. So let's say here I can there is a there are a lot of rectangles which we try to create, but let's say I want to create a rectangle at this set. Okay, let me come over here. So there's a rectangle that is created. You can have a shade and see, and let's say I push this rectangle to this particular part. I'm creating some features over here so that the 3D look can, let's say I have a 15 meter, or let's say extrude it at let's say 115 mm. So you can have a different kind of, so you're giving it to the projection or let's say 3D wall itself, but a different material you are posting it. So this is how, let's say, similarly you can do a mirror command, mirror 3D. Select this object, and let's say here the axis would be, mirror axis would be YZ axis. So you select this YZ axis over here, and you can have the similar object, but you can see that in this particular case the profile should be a little so what you do is you go for solid edit, face extrude. So what you can do is you can reduce the size, let's say so rather than increasing, so what you can do is solid edit, redo, solid edit, face extrude. Select this particular face and let's say give the value of -300 and taper angle. So this is moved over here. So if you want to give a projection over here, so you can have the UCS, it is always there, the UCS is here. So you can draw a rectangle to the nearest point over here, and then you can extrude this rectangle that you have created. So -115. So you can union this file, and this is something that a kind of projection that has been created into the building, so that the projection that is happening, so then we will be having a balcony over here. So let me put the projection down. So I'll go with the solid edit, face extrude. So here you can go down and you know to the part. So you have this okay. So what I will suggest is go for view and get it current, and go to the 3D orbit, and okay. So I want to extrude it, solid edit, face extrude it. Select this face, and let's say I want to extrude it to the bottom of this particular part. So I think we need to give a particular value. So I go for solid edit, face extrude, and here select this, and let's say I want to extrude it at 1500 mm. So you have to measure it. Uh, so this is the extrusion that is done, and similarly you can extrude it at 1500. So here in the parapet you can give some design, like for example here you have, so you can go to the view, set current. So this is the parapet that you have. So let me erase this. I think the extrusion has become quite bulky, and okay, there is certain amount of extrusion has been done here unknowingly. So what you can do is, if you can slice these things, so go to the view, and here in the V1 you can always say that go for a slice option, and slice this object that you have created, and you can have the slice plane as ZX plane, and the yeah, and both. So now you can see that this object can be deleted. Now you can have different color to it. Let's say go to the properties and give a different color to it. So I'm giving a different color to it, so that it can be easily visible. So this is something that it has to be understood while we are working. Okay. So lay on, and the I think in the layer, the projection layer is again frozen. So the last is basically going with the stairs that we can do. So to draw the stairs, go to the plan, and next we'll go with the material and then render it with a light. So here to enter into this, I create, let's say, 300 thread. So there are 4 risers to it. You don't select the correct one. 1, 2, 3, 4. So what you can do here is you can create stairs out of these risers. So 3D orbit and go to the parallel view and zoom it over here. Boundary, create the regions for the staircase. So you have one, that is 150, 150, 150, and then you have to have another staircase. So you need to have another one because 600 should be. So here we go. This is 150 first stair that you create. So you need to select the region itself. You select the lines, so the surfaces will be created. So select this 300, select this 450, and select this, it would be 600. So now if you do the union of all these, the staircase will be created. So this staircase you can copy it and put it here at the edge of the door. So right, so let me put this layer off. So there are certain, if you can see that the staircase is okay, of the biggest size. So what we can do is, right this moment, I can slide this part. So I can have a slice option, select this staircase, select this rib, and go with the YZ plane, and here is the YZ plane, and keep both the sides. So here one is there and the other is there. So here again you have to slice this, and you have to have the YZ plane and put this both the sides. So now this object is separated now. So this object, so now you have sliced it and removed the unwanted edge. So what we did is we created the stairs for this particular. Let me give a different color to it so that it looks a better uh, part. So I have this color, and let's say I give it a different color, let's say a gray color. So after doing all these, so let me have another, let me have some feature over here so that it looks a better feature. So I go here, and so I want to give some small features, like I go with the rectangle right now and put the, it is off. So I have this thin features that I want to give. So let me have the projection layer on, so that or any, let's say, window frame, which is the darker layer, shade 2D wireframe. So you can normally do a shade command, and if you draw a line, so it will not be visible because of the color, or okay. So let me create the snap.
So if I am doing it in the hidden line, so let me do it in the plan view first. So I have this rectangle here, and I create so SHA2D wireframe. So there are a lot of objects have been created, but they are not visible due to the transparency factor. So I go for a hide option. So let me create a line. Let's say so. I just put the snap off. So what I'm trying to do is I want to cut through some uh, features. So before, so let me put it the UCS at the face first. Let me see if I had put it in the correct face, and then I can create, yeah, I can create the line. So let me create the line. Let me create the region first, so that can- so so now you have this objects here. Copy this or just extrude this uh, region, let's say back, and copy this and array this in the number of rows. Let's say number of column is 1, rows is 1, and let's say the number of rows you can give it as 30. And so close array. So what I want to do is I want to subtract this bunch of object. So what I need to do is first of all make it non-associative. So if I explode it, all the objects now will be different. So after creating the array, I need to, so I select all the objects from where I want to create the features. So this is something that I wanted to do with this particular feature. So once you have this, go to the plan and UCS world. The next what I would be doing is I would be setting the cameras. So SHA to the wireframe, and now you can remove the clutter, put it in a particular layer. Let's say I want to put this into the layer called extras, and keep the layer color something bright, so that so whatever I create, let's say I will create all these objects, and I would like to put it in the layer called extra, and then I will go put the layer off. So that's fine. So select this, select this, and here you have extra, and put it off. So now you can also erase this because these are, so now the scene is ready. You have this so I want to give a small balcony kind of thing, or a projection that is required here. So here I can go with the UCS face, and right here let's say if I want to create a rectangle, so I have to check, okay, so put the snapping on, and here let's say I want to have the balcony till this particular end. So some kind of
let's say this is something that I wanted to give. So let me have a line over here so that I can do an offset, or I can create a rectangle again, let's say REC, and I just uh, I will just create an offset over here. Let's say I go for a perpendicular at this particular point, and let's say 150 is the slab thickness. So I can create a rectangle from here to here and create let's say, so let me create the rectangle again from here to here, extrude last, and let's say I extrude it by 1200 So this is, and I would not be having this particular here because, so this is the balcony, and let's just check the thickness. I think it is 150 that I had given, or it can be lesser than that, let's say. So here I have this floor slab, and just I want to have the uh, face moved at this place, say extrude. So this is, I want to have 300 more. So I can have the balcony here with the wall. Let's say put my UCS here, and so I can create a small wall. So to create the small wall, I have to put my UCS in this face. So let's say if I want to put my UCS in this face, so UCS face, or I can go with the dynamic UCS also. So just so if I want to put the dynamic UCS on, so right, so put the rectangle over here. Let's say I want to have a wall at the rate, and it is, let's say, 6 750 or 900 is the standard, comma 115, right? And just, this is the I want to create here, and UCS I want to put it in this particular face, and create a polyline so that it can be, so go with the polyline option, first point. Okay, so, or you can do a solid rated face copy here, and shade to the wireframe. You can hide it and see which solid edit face copy, copy, and you can copy this face here. If you explode it, it will be in different line, and then you remove this, and then you go for a p edit or a join command. So once you join it, it becomes a single object, and then you can move it here below the wall. So when you move it, make it a shade parameter, move this or you can get this wall parameter, wall section over here, and go with the extrude, and then path, select this, and then you can copy, you can have the layer on, it's a wall layer, so you can always have the 3D wall, copy, and put it here. So this is basically something that you can see that the elevation is getting created along with the plan. And so this finishes the modeling part. Now next is get the UCS in the world and create the floor of this particular plan. So I have this floor over here. I can extrude this and say minus 50. So if you look into this, okay, 3D object. So move this floor 600 down because of the we have moved the plinth down, right? So you can move this object back and you can have this here also. So now let's say if I want to have a camera view, select a cylinder and create a cylinder actually with a circle. So now you can see a circle is created. I created a cylinder of the circle. Let's say it's 1500 and so 3D orbit and I make it parallel. I go with the camera view and here let's say I want to name the camera as cam1. I want to give the height is 1500 and the target height in the Z I would like to give a particular value but not now. In the lens, so in the lens let's say I want to have a 35 mm lens and press enter. So you have the height already done, target already set, press enter. So 1500 you have and press enter and enter. So the camera is set. Now you remove this. So here you can see the camera view at this particular point and here to see and uh, control the camera you need to go to the view here in the visualize there is an option here uh, okay. Okay, I think some parameters are needed to be checked. Okay, okay, in the visualize has come. So here I can have the sun status. You can see adjust keep exposure settings. So I'll keep the exposure settings. I want to have the full shadow or I want to give the ground shadow on. So if the ground shadow is on, there would be a shadow, or I want to go with the full shadow option. And here I want to go with the realistic. Right. So apart from this, I can also have a distant light or some kind of. So now the next is after we have the camera. So you can see the camera. You can set. You can start with the camera one and see how it looks like. So here what you can do is you can put the steering wheel on now and the steering wheel you can basically orbit the camera and pan them and create a perspective view which is suitable for the uh, okay. So here I can create the perspective view so that it's a this is the perspective view that I wanted to create and move it into the center of the scene, and you can do the orbit a bit part, okay, so that the projection comes, and this is the you can save this view as cam2 and press OK. Next is basically setting the you can set a light also. Let's say in the plan you can set the light. Say you can have a distant light. So for the distant light, I can have, let's say, the distance at any time, any height. Cylinder can be any height. So I create a light and I have a distant light. Keep the off the default lighting recommended. So I keep disable distant light when the lighting unit is allow distant light. So now I have this light over here, and the direction is this point, and just I wanted to change the photometry. So here, and press enter. So now I have set a distant light at this particular scene. So go to the view, go to the V1, and or you can go to the cam 2. In fact, you can see the okay. So I need to get the cam 1 set current. Okay, view cam 2 set current. So now next I would be getting the materials. So go to the material browser. So sky background, I can give some sky background or and illumination. So that some illumination is there, and okay. So this is the 3D view that you can get. Now with the material, you need to have the material browser on here, and I want to give some stone material to the and the granite here. So I'm putting the material browser on. So let's say here are the list of materials that are here. So there is the name of the material. Let's say it's a rough pink stone is there. So granite. So here I want to give this particular object assigned to selection. Okay. Okay. So you can see that the material is assigned to the element that I was talking about, and then you can give this. You can see this particular in the material editor. So let's say if I want to give this particular tile this rustic stone, so here you can see it looks like this. So I can do a set UV to do the mapping of this particular. I will go for a box, and so this element is now inside a box. It is mapped over here. So you can size the box to have the masonry, but this is fine. Similarly, this material you can go with rmat as a command, and let's say I want to have a blue stone given to the wall. So here I go assign to selection, and or I can go with the Taventine stone. So you can see how it looks like. So it is somewhat like the very. So you can go with select the object and assign to selected. So again the wall is now having some color, you can see here, and the texture is given to the wall. So I can go with the set UV command and go with the box mapping, select, and as per it the mapping is done. Similarly you can give the mapping with the rmat, the different kind of let's say you can give both of them format to look how the effect would be done. So select, so all the selections that you're having, let's say uh, this is the Travertine cream, and so this is, I want to have, let's say, an kind of polished pink that this yeah, or I can have this rectangular stone gray. It looks more better. So yeah, I can have this in the uh, okay. So format, select the object that you want to. Uh, so in this case, I want to give these two set assign selection to these two objects. So if I do a set UV right now, set UV box, and now you can see that both of them are given a particular material. So with this, now you are going towards, you can see that how objects can be given different materials and shades at different time. So here this, or you can give, let's say you are not happy with it, so I can give a stone which is alabaster, select it, and try with the different kind of options that we can have for different materials, because in CAD you can try with a lot of options in 3D modeling. So here you have this, so close this, and let's see, so select all of three of them, and you can assign them the same material that you had given to the staircase. Now you can have this particular stone, just try with it. Doesn't mean that it would be actually practically it can go, but it's just you can play with the colors and see how it looks like, and the material. So you have this, uh, so you can always assign to selection. So now you can see how it look like if you give. So go for the set UV, and check the box mapping if it fits over here, and press enter. Now let's give it to the, let's come to the wood family over here, the mullion frame. So I want to give a white kind of, so here in the library, what I would be looking for is the Autodesk library. Here in the Autodesk library, I would be looking for, let's say, metallic paint. Uh, so white satin, let's say, this kind of paint that I wanted to uh, give. So fleet satin gray. So I'll be selecting this. So I'll be ungrouping this right now. So I put the lay off of this wall, and select it and ungroup it. So select this object and assign the selection. Okay. So this is the slate gray that you can have, and similarly for the frames, other frames also you can have the, select the frames. Let's say you can ungroup them here, ungroup them,
ungroup them, and okay, so select the frames together, 2, 3 and 4, and click right, assign to selection. So all of them will become, and then you want to give a glass, so you can select the glass option. So it's a clear blue glass that you want to give. Right click, select all the glasses, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So all the objects are now given a blue glass. So and this particular frame of the door would be given as the, let's say, this material, and so this is how the and then you have the mullions. So I want to have a white and dark shade, so for the go for the plastic, and let's say I want to go for aluminum or steel. If let's say, so you don't have that aluminum or steel, but I can have the white. So now you can go to the 3D orbit and see how it looks like. So select the mullions over here and right click and assign. So similarly select the mullions here also, and assign to selection. Okay, so just zoom it inside and select. Okay, and assign to selection, select, assign to selection, and select, assign to selection. So this side I had given a different texture, and the other I had given a different texture. So let it be and put the lay on, and let me have some call on the wall feature. Just take a call if I want to change the design of the wall, pattern of the wall. So come to the library and see if I can uh, change something over here. So I come over here and I go for a wall paint. So if I go for a wall covering, so it's a wallpaper. So I go for a stucco. So I can go for a exterior white. So select it and I go for a stucco. That is an exterior white color, and or yeah. So this is what we can, and then you can, right, you can set UV, select the wall, go for the box. So right, so you have this building ready for the rendering part. So go for the view, right, go for the view, and cam2 is ready to be rendered. So the last thing that you should do is go to the render environment and exposure, so that put the environment on over here,
So sharp highlights, dry lake, you can have different kinds of environment. uh, okay, and then go with the rendering option. So when we go with the rendering option, so here we have the rendering window here, or render. So okay, so go with the render command. So let us set the size, and that's all. So go for the RR, and now you can see I'm just RR is for the rendering option, and you have the rendering window open. Then we'll go with the rendering presets. You can see what are the presets that the rendering is having, and then okay. So you can have the camera on and off, and you can have the shadows with the presets. So first of all, finish it off, and then we will go with the command again. So you have the render gallery, you have the render to size, and render window, and here is the environment and exposure. So click on the setup here, and then you have this window option or a region option, whatever you want, and then you can do low or draft, and then you can put it off, and you can see the rendering done. So you can adjust the exposure of the, so let's say if I want to do it in a high draft, so I can put a rendering on, so it will be done in a high draft resolution, so it is level 0. Finish. So this is what the rendering is. You can see the shadows of the building is there, along with the textures over here that we have created, and the shadow is coming because of the sunlight and the distant light that we had given, and and the textures you can see that is available. So I'll just give a copy of this and see that how the rendering can be processed fast. So this is a level 1 rendering that you can see. You can save the render as JPG, and you can have it sample JPG or PNG. So you can always, then you can print them. So you have this different levels of rendering that you can change depending upon how good you want to make the rendering process. And let's say, so I want to mirror this entire building, and the YZ axis, YZ plane, I want to keep it as a, this is the point. So you can see that uh, let me have the okay, so it is mirror 3D. Select all the objects, and YZ, and put it here. And so you have a similar building that you have created, and similarly you can do the both the mirror over here, and select all the objects, and select the YZ,
and so the mirror line would be so go with the mirror 3D and select the objects. Okay, and press enter, and it would be the YZ plane, and the YZ plane will be going through this point. So you can have a series of objects that is created. Now together you can do the um, you can see the view, perspective view better. Go with the view, cam 2, and you can use the now you have the rendering option. So you can do RR as rendering, or so you can open the environmental map. Uh, so here I can go with the rendering settings over here, and so I can increase so I can change the level. I'm making it at higher render, and apart from that I am changing the exposure. So here I'm putting the environment on and use IBL as image. So just I can reduce and increase the exposure as I want. So depending upon how I wanted my uh, so so I can have it into a exposure that a bit dark. So I can have a cool light as a background, or so I can give different types of background. So I give a soft light and see how the rendering will be there. So they are all uh, images as of you can see that how the building is getting rendered. So you can feel the depth of the building as it goes more deeper. So with this, we end the session of. So it will take time because I have done a level 5 rendering. So a lot of actions were there during this session. Hope you will create models up to the expectation. Thank you.